Hello and welcome to this course. In this video, I would like to show you what you will learn throughout the course and tell you a little bit about the projects and in general give you an idea of the structure of the course. All right, so let's get started. First of all, you will get an introduction as we have already started. There, I just give you some tips on how to take the course and how to get most out of it. Then we get ready with Android Studio, which means we're going to set up Android Studio in order to start using it on our Windows, Mac or Linux machine. And then we will start with our first little application. We will set up the emulator so that we can test the applications on our emulator directly. So we don't have to always use our phone, even though you will also see how to test your applications on your phone. Then we will get into the Kotlin fundamentals, because it's important to understand the Kotlin fundamentals before we dig deeper into developing applications, because we're going to use Kotlin as our programming language to develop Android applications, and that's why it really makes sense to look into the basics. So first of all, general fundamentals, then object-oriented programming basics in Kotlin, and then we're going to look into some more fundamentals which will be important for the ongoing chapters. We're not going to cover all of the fundamentals directly at the beginning, because we are going to add new fundamentals step by step throughout the course so that we can directly dive into building applications. Okay, then we start with this very basic application, Age in Minutes app, where you will learn how to do the following. So we're going to build this little application in which you can select your birthday, and then you can just go ahead and calculate how old you are in terms of minutes. So in my case, let's say I select my birthday, which was May 31st, 1988, and then I can see, okay, this is how old I am in terms of minutes. Okay, so I'm super old when it comes to the minutes count, 16 million minutes already. And that's the first little application that you will build, because I think it makes sense to have multiple aspects that we could directly cover and not just a very simple basic application. Okay, so I think this is good enough for the start, and then we of course go ahead and build more and more advanced applications. As a very classic application that you have to build, for example, in universities, or that is taught quite often when it comes to learning to use UIs, so user interfaces, and build user interfaces in Android, there a calculator of course makes sense, and we are going to build a little calculator therefore as well. And then the apps get more and more advanced. So you can see already in terms of the length of the sections, you can see the quiz app is already a more advanced application than the calculator. Then the drawing app is even more advanced, and the 7-minute workout app is a 7-hour section. So let's look at the quiz app. Here you will learn a bunch of cool new features which are super useful, and of course you're going to build a cool app. So here you're going to build this application in which you can first of all enter your name, and then you have a little quiz where you have an image and a question, and then you can answer the questions as well as you can and submit the answer, and then you'll see whether the answer was correct or not, and you can go to the next question. So in this one, it's just a very basic quiz with flags, and you have to guess for which country this flag stands, and then of course you will learn how to adjust that, so you can create your very own quiz at that point. Once you're done with this quiz application in the course, you can just adjust it to your liking. You can make a very own quiz with however many questions you want to have, whichever image you want to display, and also whichever questions and answers you want to display. All right, so that is the quiz app. Once we're done with the quiz app, we go over to the drawing app, and this one is a little more advanced, but here you're going to learn very different features. So you're going to learn how to use views in a more advanced way than in any other application pretty much in this whole course. So I think this is a very useful thing, because it allows you to customize everything to its fullest, and you will be enabled through this chapter to customize your UIs as you like them. And along this journey, you will build this little application here in which you can draw something. All right, so you can play around with brush sizes, you can change them, you can make the brush size a little thinner, for example. So if you want to draw a beautiful little smiley as I do here, you'll be able to do so. And then you will learn how to import images, how to export images and share them with your friends, for example, via WhatsApp or whatever application you have that allows exporting and sharing. And you can see we are going to play around with colors and all of that. And also you can just redo whatever you have drawn. Once we're done with the drawing app, we go to the 7-minute workout app, which is a app that will teach you one of the most important parts of development, I'd say, and that is to use recycler views. So you can see that there are a bunch of intros, demos, and so forth, because each time that we introduce a new topic that is relevant and big enough, I created an extra demo to teach the concept first before we then apply it in the actual application. So I think this is going to help you to get a better understanding and also feel more comfortable using the features. Of course, we also have exercises, and most of the exercises will be inside of the actual lectures. So I will show you how to do something, and then I will ask you to try to rebuild that with your own understanding of how it's done. And there are many things that are just coming back. So many features are just coming back and you have to do them multiple times. So in every new application, you have to do it again, or maybe even in the same application, you have to use the same type of code multiple times. And sometimes it's just minor adjustments, but still it's slightly different. And that really helps you to get into the practice of developing real applications. And that's exactly what you're going to learn, right? So then that's the 7-minute workout application. You can see there's a BMI calculator in which you can enter your weight and height, and then it will calculate whether you're fit or not. Then you will see a history of your exercises when you finish them. And of course the exercise itself, where you can just see here, for example, jumping jacks is the upcoming exercise, and then there's a little timer running, and once that's done, you will get over to this activity in which you can see which exercise you have to do. And here at the bottom, you can see there's a little recycler view, which also indicates in which exercise you currently are. So this is very adjusted and very specific. You can even see here a little dialogue which says, hey, do you really want to quit this exercise? You have come so far. So you will learn all of that. All right, so that's the 7-minute workout app. Then we go to the Happy Places app. And in this one, you will learn how to use third-party libraries quite extensively, because we're going to use many of them here. And this is very, very important and super powerful, because you don't want to build all of the code by yourself. You want to reuse as much code as possible and not having to build everything, because so many third-party libraries are available, and they are made available by other developers that want to make our life easier. And why wouldn't we want to use that? And that's exactly what you will learn extensively in this chapter. So you're going to learn how to use many different features and also many different third-party libraries. And by the end, you will have this little application here. So you can see you can add little happy places, which you can then give a title, a description, a date when you were there, then the location. You can search for the location, or you can set the current location. Then you can add an image and you can save that. And then it will appear here in this recycler view, or in this list pretty much. And then you can also, of course, edit that. So you can view it on the map and then make changes to the settings. And you can see here Mount Everest, it will display the map. So we're going to, of course, check out how to use Google Maps, how to use Google Places, and many other third-party libraries. At this point, you're going to learn one of the most important things when it comes to developing real and advanced applications, and that is to use JSON. So JSON is a way to store data or to display data that can be used quite well in programming in general. So you can get data very well designed and you can quite quickly use it in your application, okay, and display it accordingly. So however you want to display the data. So in this case, we're going to create a little weather app which allows us to download data from a free source. So we're going to see how to use a free source for this one. And of course, you will be able to reapply that knowledge to whatever application you have to build. And many customer inquiries that I've gotten have been something where you had to use JSON. All right, so where you had to use API calls, where you had to use REST and so forth. Okay, so all of these beautiful keywords that you might have heard, well, you're going to learn about those, and you're going to learn how to use them and how they actually work. So here, for example, this is going to be the weather app, where you can then see different data and, yeah, for example, the temperature and so forth. Okay, and then the final app is the banger. As you can see here, 14 hours of content. So this is really a huge project, but it's that on purpose, because it's not just stupid stuff that you have seen all over and over again, but it's a lot of new content that you will learn here. So here you will learn how to use Firebase, how to use Firestore, how to use user management, drag and drop, online database, and so forth. So a bunch of very advanced and very important features when it comes to highly advanced applications. Okay, so if you ever want to build something like a Tinder app or a Facebook or a Twitter or whatever you can think of, where you need to display a lot of different data, then using Firebase is a great choice for this. And we are going to build a Trello clone, which is a project management tool that I use quite extensively, and I really like it, and many other people do. So it's a very great application. And this one is super advanced in terms of the functionality, of course. So you can see there are many lectures that we're gonna work through, and some of them are repetition, but that's great, because then you can really apply all of the knowledge that you have gained so far and build those pieces yourself. And I will often enough give you time to try to execute that. All right, try to build parts of the application all by yourself. And at the end, you will have built such an application here. So you can see here we have a list of tasks or boards, so to speak. So these could be projects, right? And then we can go ahead and add steps to here. So we have task lists and individual cards to which we can then assign users who are responsible for their task. Okay, so this is a real project management tool. If you have ever used Trello or any other project management tools, you will see many of the features in here. Okay, so we can add cards anytime. So this one will be, let's say, card 2, and then you will also learn how to use the drag and drop feature, which allows you to basically drag cards and change the position of those cards. All right, so this is super cool stuff, and I built this application with Trello in mind, right? I thought about how do I want to teach all of these things that Trello does that will help people and help my students to build super advanced applications and become really good developers. All right, so at that point, I just came up with new ideas and what I wanted to add and how deep I wanted to go there. So you can see you can even edit cards, you can delete cards, you can change the name, you can select the label color here, which will be then the color for this individual card. You can add members who you assign to the board to be responsible for this specific card, so that they know, okay, I have to do something, and they get a notification knowing, okay, well, I have a new card that I'm responsible for. And cards could be tasks, right? So for example, finishing a part of an application, developing something like this feature could be a card, and then you can select the due date at which the card has to be finished, and you can update that, and it goes to the real-time database Firebase in the cloud, and it's stored permanently there. So of course we have a full user management where you can register via multiple approaches. We are going to use email to keep it simple. Then you can see you will have a profile which you can then change. You can change the profile image here based on whatever images you have on your phone, or you can use the camera to make new pictures and so forth. So this is a fully advanced application, and I've looked at other courses, and I have made other courses before, and I've never created such an advanced project, because many of my students asked me, hey Dennis, could you please make a huge project? Because all of those small projects, they're cool and all, but I would really like to see a huge project to really build something from scratch and all the way through. And that's exactly what we're doing here. So we're building this huge application, and it's really prepared. So all of those other projects, they prepare you to build this. Of course, there is a lot of new stuff that you will learn, but many fundamentals that you learn throughout all of these other chapters, they will be necessary to build this. Okay, so this is super duper important in my opinion. And of course, you have a bunch of exercises, and what's even better, you can download the code of all of those videos. So for every single video, I have a version, so to speak. All right, so you can download the version that you have for specific features, and then you can see how to build those features with a step-by-step instruction. So not just in the videos, but also in the code itself, you will have an instruction on how to implement a specific feature. So this will help you, and I think this is something that I have not seen in other courses, and I really think that this is a huge changer, because when you want to build something, you of course can check out the video, but you can also just download the code and check out how it's done using the step-by-step guides. You can see I am very very excited about this course, and I'm very, very proud of the work that I did there. And I hope you enjoy it, because that's really what's my main goal, that you enjoy it. And when you enjoy it, it automatically leads to you finishing it. And when you finish it, you will become a real Android developer. And that is what my huge goal is. That's like my life goal, right? To make as many people as possible real developers. And not just that, but become more happy, because if you have a better job that pays better and that just gives you a lot more freedom, this will make you happier. And I want to make people happier, right? So that's really my goal. So thanks a lot for watching through this very long video. This is maybe way too long for the first video of the course, but I still think it's important to give you a good understanding of what you're going to learn. Okay, you're probably super hot to get started directly, and that's why I don't want to stop you from that. See you in the next lecture, and thanks a lot for being with me.
Thank you very much for taking this course. I'm super happy to have you here. I have this goal of teaching 1 million people how to program. And the idea behind that is that I think that there are so many different advantages that we have through IT, and it has changed our lives so much. And I think with more great developers, we can even get a better life, even have better solutions for many problems in our world. And this is just the beginning. We are at the point where more and more people start to program, and we can really make a huge impact. That's why I'm grateful that you are in this course, that you learn programming, that you learn from me, because I really put a lot of love and effort into making these courses. So I'm very happy to have you. So thank you very much for being in this course. I hope you enjoy it. I hope you get most out of it, and I will also show you how to get most out of it in the next video. So see you there. Welcome back. In this video, I would like to show you how you can get most out of this course. So the course was created in a way that you should work through it step by step. So you should work from the beginning towards the end. And if you necessarily need to skip a part, then be prepared that there might be some code parts which will not be explained as in depth as at the point when they were introduced. So that's why I recommend to start from the beginning, because we are going to use a bunch of features that we will reuse quite a bit. And that's generally normal. When you develop, that's the case very often. There are a bunch of things that you will need to reuse, and that's why it's important that you work through it from the start, because at one point, after we have used a feature for the third or fourth time, I will not explain it step by step anymore. I will just assume that you have gone through the specific piece of code or specific example or specific challenge or a specific feature with me. And that's why I will not bore you with going through it again, but I will just reuse the code. So this way you get more knowledge throughout the course, because it's still the same length of course, but I'm not going to repeat a bunch of stuff that is going to bore you at one point. All right, so that's why it's important that you work through it step by step, and also try to finish the exercises. I made those exercises for you to just double check whether you understood what you have just seen there. And in general, they are positioned very often at points where you have seen how something is done, maybe once or maybe even twice before, but now it's your turn to try to do it yourself. And in programming, very often when you start to develop a new feature, it's not like you're going to start programming and typing and typing. It's a lot of research, a lot of finding something on the internet that works and then making it work for you, so adjusting it. And at one point you get a feeling for it. At one point you get really good at it. So learning a programming language is similar to learning a language. When you learn a new language, at the beginning it feels so weird and so difficult because there are so many words that you have never heard and so many, maybe even sounds that you can't even make a distinction between. And that's also a little bit like programming, where you start to see all of the code and it is confusing at the start, but step by step you get a feeling for it, and at one point you feel natural and at home using this new language. All right, and that's also what I hope that you will get with this course as well. At least that's how I build it. Okay, so that is one part of it. Do the exercises, work yourself through it step by step, then also download the code from the videos. All right, so for almost every video I have a bunch of code that you can just download, and there are a bunch of comments which explain what the code does. So if the comments that I gave you or the explanations that I gave you during a video aren't good enough, you can use the comments from the downloadable code examples, and you can also of course work through the code step by step. So there are a bunch of to-dos in the code that you can download, so you could even just follow along the code versions itself. So the projects, you can download the project and do the step-by-step process, because that's also how I build the course. So I do a step-by-step building up of an application. Okay, so the other thing that you need to consider is to, of course, search the internet sometimes. So if you don't understand something, or if you necessarily need to really dig deep into a specific topic because you really want to understand it in a very deep way, then I recommend to do so. And also, if there are questions left and you can't find them in the Q&A and you can't find them on the internet, then of course you can use the Q&A to ask your own questions and we'll be there to answer them. All right, so I hope you get the most out of this course. And by the way, what's super important, work through the whole course, because once you're done with the whole course, then you've got the most out of the course. All right, so thanks a lot for being with me, and see you in the next video. Welcome to the first chapter. In this chapter, we're going to set everything up so that we can get started with Android development. So first of all, we are going to install Android Studio. Once that is installed, we are going to prepare our AVD. So we're going to set up our Android virtual device, which is our emulator that we can then use for testing. Of course, you will also see how you can set up your device itself. So if you have an Android device, how to set that up in order to do the testing on the phone directly, which is a little faster than doing it on the Android virtual device. All right, so we're going to do both of that, and then we're going to test our first little application, which will be Hello World, and then of course a little bit at the more advanced, which will be a people counter, so a very basic app where you can press a button and it will display something, or the number pretty much, on the screen. All right, so let's get started with it. I hope you enjoy this chapter, and see you in the next video.
In this video, we are going to install Android Studio, which is going to be the integrated development environment, so the IDE, so the software that we're going to use in order to develop Android applications. Therefore, you can just go to Google and search for Android Studio Archive, and you will find this page here. Just click on it. You see it's under Studio Archive. That's where it's going to send us. And I don't want to install the latest version of Android Studio because that will change constantly, and I want you to have the exact same Android Studio version that I'm using in the videos, because this will reduce confusion and it will make the learning process for you a lot smoother and a lot more enjoyable, which is very important to me. So let's go ahead and scroll through this page here. You can of course read through the terms and conditions, and you should, because well, you agree to them with this button here, which you need to click on in order to get to the downloads themselves. So here is an overview of the different versions of Android Studio, and you can see there are a bunch of them. So Bumblebee is the one being currently developed, but it's in an alpha phase, or maybe beta, you could say. The canary version here is 11 at the point of recording, but we're not going to use that. We're going to use Arctic Fox, which allows us to create Android 12 applications, which is what we want to do. And even if you're watching this course at the point when Android 13 or 14 or whatever is out, no worries. The basics will stay the same, and the changes with each version, they don't really make that much of a difference for us developers in the sense of what we need to develop, because most of the time the features that we're going to use are features that are pretty old and they have been available in older versions of Android already, which is very important because if you look at it, the devices that currently support Android 11 even are super limited. So even though Android 12 is coming out now, not all devices have the latest version of Android 11. So that's really something that you have to take into consideration, because what you want to achieve is that your application will be able to run on as many devices as possible. And we're going to see a little on that in the next video as well. So here, let's go ahead and install this version because that's the one that we're going to use. The Android Studio Arctic Fox 2020.3.1 patch 2. So it came out on September 1st, 2021. And that's the one that we're going to use throughout the entire course, which is why it's really important for you to use this version as well. Otherwise, things might look slightly differently or they will not work exactly the same and so forth. And this will really diminish your enjoyment. And that's not something we want. And especially as a beginner, for you, all of these extra features that will come out with new versions, they will not be relevant for you. They will be relevant once you are an advanced developer, and this will take you to basically finish the course first in order to get there. Okay, so once you're done with the course, you will be an advanced developer. And at that point, you will be confident enough to get started with new versions and discover new features and stuff. Okay, so once you click on this, you see that this pops up here. So the installers, the zip files, and so forth. As I'm using a Windows PC here, I'm going to use this Windows X installer, which makes it easier for me. Of course, you can also use the zip file and then extract it and then use the installer from there and so forth. But I'm just going to use this exe file. So just click on this file and then save this file. By the way, if you're using a different operating system, accordingly you would of course download them from here. So if you have a Mac with an Intel CPU, use this one. If you have an M1, M1X, M2 or whatever processor, then the Apple Silicon version will be the right one for you. And finally, if you're using Linux, of course, use this downloadable right here. Okay, so once you have this exe file on your PC, just double click on it and start the installation process. Android Studio Setup will then open up and you can just click next. And here, by the way, I will keep the Android virtual device active because I want to use an emulator on the PC so it's easier for me to record. But if you want to test only on your actual phone, you can of course not install that if space is an issue on your PC. But I really would recommend to install the Android virtual device because I will also show you some neat little tricks with it later on in the course. So then click next to install it, select where you want to store it. I'm going to keep the default settings here and click next again. Then if you want to add it to your start menu, just click install once you're ready. Okay, so once that is done, click on next and then you can start Android Studio. So let's do that real quick. You can see this beautiful Fox pops up. So in order to record this, I installed everything that had to do with Android Studio from my PC, but it seems like it didn't show me this first screen where I could select the colors that I want to have. So in case you want to use a different theme, you can do so. And I'm also going to use a different theme and you can go through the settings that will appear before that. So once you're done with that, you can just see this screen here. Welcome to Android Studio. So once I'm at this point, I want to customize my Android Studio a little bit. So here you can use a different color theme. So you can see it's this IntelliJ Light theme that is currently used, but I want to use the Darkula theme, which will make things a little darker. And then also you can change the IDE font, which means the size of the text on the Android Studio software. And then in the editor itself, so the code, you can change that here in order to make the code bigger or smaller. But that is something you can change anytime in your Android Studio project. Okay, so we're going to get back to this point in the next video where we're going to create our first project. Welcome back. In this video, we are going to look at how to install Android Studio on a Mac. So therefore, you just have to search for download Android Studio, and usually you should get to developer.android.com with your first link here. So let's just go there. And once you're here, you can download Android Studio. And you have multiple download options. So in case you want to use the latest version, you can of course just download it directly from where you were here at the top. So you can just click on download Android Studio. Then you have to read through the license agreement and download Android Studio for Mac. So you can see in this case it's 3.6.1. I'm using an Android Studio 4 Canary version for the course, but you can easily just use Android Studio 3.6 or whichever version is out at the moment when you download it. So usually they make changes, but it's not like huge changes. So no worries if the version is different than the one that you can see here on the screen. All right, so then just download this file. And once it's done downloading, you can just open up this DMG file. By the way, if you go to download options here, you can find that there are offline components that you can download, command line tools, and also the system requirements that there are for Android Studio to work properly. So you can see you will need Mac OS X 10.10 Yosemite or higher, and then 4 GB of RAM minimum, 8 GB are recommended, and you need some available disk, even though I would recommend more than just 4 GB because you will also need the emulator. And the emulator usually is bigger than just 1.5 GB. Alrighty, once the download is done, you can just click on the DMG file, and that will then unpack the file and start installing. Okay, so at this point, you just need to drag Android Studio to your applications. Just drag it over to your applications. And then it will copy Android Studio to your applications. Alright, now at this point, you can go over to your applications and find Android Studio there. And here it says that the app is downloaded from the internet and whether you want to open it or not. And here you will have to press open if you want to proceed. And there you see Android Studio pops up. So here you can import Android Studio settings if you have any, but you can also just choose do not import settings if you don't have any. So it's no problem. Then you will come to this Android Studio setup wizard, in which you can just press next, and then you can decide which type of setup you want to do, the standard or the custom one. If you want to make more changes, then you would use the custom one. Usually the standard one is totally fine. So here you can select the UI theme. I'm personally using the Darkula theme, so the darker theme. If you prefer that one, you can choose this or the light one, however you prefer. All right, and then you can just press finish, and the final download of all of the missing components is gonna start. This can of course take a little while. And once the download is done, you can simply press finish. Okay, and at that point you can start a new Android Studio project, and that's what we're gonna do in the next video. So see you there. Alright, so in this video we are going to set up our first project, and we're going to look at the user interface and, for example, also change the text size of the code that we have. Okay, so the first thing that we see here is welcome to Android Studio, which is great. And then we can create a new project to start from scratch, or we can open existing projects. So if you want to open the projects that you will find as a downloadable file for the lectures that you have in the course, then you can of course click on open. But we're going to start with a new project here. So once you select that, you will find this screen here, and the screen allows you to select from the different options that there are. So if you want to develop for a phone or a tablet, you would select the templates from here. So basically you have a bunch of different templates that you can use in order to get started. And the beauty about those templates is that Android Studio is going to already give you a bunch of code that you don't have to manually write. And that's really the power of using an integrated development environment such as Android Studio. So if you were to develop for the watch, you would use Wear OS, or for Android TV, you would select something here, and the same goes for automotive. But the course is going to focus on phone and tablet. And you see by default, the empty activity is selected. So you can see that there are different types of activities that you can select from, and they will have different kinds of predefined code in them already. For example, if you want to navigate between different screens, you would use this bottom navigation activity. If you want to have this button here at the bottom right where you click onto it in order to add something, you would use this basic activity. But we're going to start with this empty activity, which is going to be pretty clean, and we can just build everything from scratch. And that makes sense for you as a beginner, especially because you need to understand how things are connected and how they are built up. So it doesn't make sense for you to have this bottom navigation activity where a bunch of code is already in there and you wouldn't understand it. So I think it makes sense to start here. Of course, you can also see that there are beautiful things such as AdMob ads activity, where you have ads in there, or the Google Maps activity, or even such a login activity, which you will definitely need in your developer's career. But let's start with this empty activity. So click next, and then this screen pops up where you can create a new empty activity. You can first of all give your application a name, and I'm going to call this one My First App. Okay, and then here, the package name, it always consists of those 3 keywords separated by a comma. Usually that's com.example.myfirstapp. So it's like you would go to a website, then it would be the other way around. So you would say something like myfirstapp.example.com. So here you need to use a package name that will be unique to your own app, because once you want to release your application, it has to have a unique package name. Otherwise, the Android Play Store will not accept it and you cannot publish the application. So here it really makes sense to have a package name that fits you. In my case, I'm going to use eu.tutorials because my website is called tutorials.eu.myfirstapp. And you can see everything is in lower capital letters. Then the save location is basically where your project will be stored on your PC. You can change that anytime by clicking on this button, and then you can select a different folder if you want to. I'm going to leave it at that. And then you have the language here, so you can select Java or Kotlin. So this course is going to focus on Kotlin entirely because, well, Google said that they want to focus on Kotlin when it comes to app development, and they don't want to work with Java that much anymore. It has to do something with them running into some issues with Oracle, who own Java and so forth. So I'm not going to go in too deep into that, but that's basically how they at one point decided to go with Kotlin, and we're going to use the latest and greatest, which is Kotlin. Then you have the minimum SDK. And SDK stands for Software Development Kit, which is a collection of software development tools in one installable package. They facilitate the creation of applications by having a compiler, debugger, and even a software framework. They are normally specific to a hardware platform and operating system combination. So in this case, the SDK is specific to the Android apps that we're going to build. So here you can see that you have the API 21 with Android 5.0, which was called Lollipop. Back then, Android versions had a name that was somehow connected to a sweet. You can see here Marshmallow, Nougat, Oreo, Pie, Jelly Bean, and at one point they just called them like letters, QRS. So Android 12 is of course the latest version at the point of recording, but it doesn't mean that you should select Android 12, because if you do that and you want to specifically target phones that have Android 12 installed on them, you can see that this app will only run on 1% of devices. So that's not a good idea, even though it will contain all of the good and great features that Android 12 has to offer, but it will be limited and it will only run on devices that have Android 12 installed on them. And until it is a reasonable amount of devices, years will pass. So even if we take Android 10, you can see it's only installed on 8% of devices, which is why, by default, it offers you API 21, which is running on 94.1% of devices. And this is basically most people that have a phone. So if a phone uses an Android version that is older than 5.0, then probably it's not being used that much anymore. Now, the cool thing is that Google was smart enough to create things such as AppCompat, which is an app compatibility namespace that basically allows us to develop new features that will run on old devices. So they've really found a smart way around it. So basically you can use Android 5.0 or the API level 21 in order to build your application, and that will work flawlessly on 94.1% of devices that are out there. Now you can activate that you want to use legacy Android support libraries, which is if you really want to specifically target old devices. So I'm not going to check that box. Now let's click on finish and let Android Studio set up the project. You can see here that it says Gradle:build, and there is this progress bar, which basically just says, okay, it's preparing the project. So it's creating all of the code and all of the project files that there are. Okay, so here you can see that you have your code in the main activity KT, which is opened by default. .kt stands for Kotlin, by the way, so this is a Kotlin file, and it is a physical file on your PC. So if you want to go to this particular folder, you can right click and then go to Open in Explorer. This will then open up the Explorer and you can find this is the main activity KT file, which is in all of those subfolders. So there's the tutorials folder, then EU, then Java main, SRC, app, my first app, and Android Studio for projects. So this is my first app, which contains all of those folders, which this IDE, this Android Studio, has automatically generated for us. And that really makes our life a lot easier. So you have this code. Let's say you think that this code is too small or too big. Well, what you can do is you can go over to your settings right here, or you can press Ctrl-Alt-S on Windows, and then you can go to appearance and change the font. Well, this font here will not change the code font. It will change the size of this UI, for example, or the UI in general in your Android Studio. I'm going to keep that at 18 because I believe that's just big enough for you to follow. But now, if you want to change another font, you can just search for fonts here and then go to editor font, and here you can change the size. So if you were to make it bigger, you would select a bigger value here. If you want to make it smaller, you would select a smaller value here. So I believe going with 20 is going to be fine for you. So this is going to be the size that we're going to use here. Now you can see that it has. Now let's have a very quick overview of what's going on here. So on the left hand side, we have a bunch of buttons that we can click on, and these are tabs. So when I click on this, you can see that this closes. It's the project tab, which allows me to see all of the project files. And here I can go to different settings, which will also change the way those files are displayed. So if I go to project, you can see that suddenly things look very differently. And I would recommend to always keep it at Android because that's how I'm going to use it, and it will make it easier for you to follow along. So you can see there are a bunch of files, right? And most of them will not be relevant for us at the beginning, but we're going to go through them step by step, and I'm going to explain what they do. Now, the most important file for us is going to be this main activity right here. And it's this file that is already opened. And you can see once I click on it, well, it opens up this screen. It was open already. So let's go to another file. Let's go to this file, for example, and now click on main activity, and you see it jumps over here. So this is going to be the starting point of our application where everything starts. Now, at the same time, you see that there was a different file opened up for me as well. It's called the activity_main.xml file. So this is the XML file which takes care of the user interface. So let me drag this around a little bit. You can see there are many different options here what you can drag and change the appearance. So let me zoom in a little bit, and you can see that this is basically going to be the UI of my application. So currently the only thing that it has is this little text that says hello world. And I can click on it, and then I can see the attributes here on the right hand side and make changes to it, but we're not going to do that for now. Now, the important part is that you see that there is a little editor which allows you to edit the UI, and the main activity and the activity_main XML, they are connected, which basically means that this main activity uses this activity main XML as its appearance, so to speak, as its user interface file. because here we are setting the content view. So we're saying the content in the view, which means on the screen, should use this file called activity_main, which is this XML file right here. Now, this activity main XML file, by the way, is inside of this res here. So in the Java folder, that's where our programming code goes, and inside of the res folder, that's where our resources go. And there are drawables, which are images. So for example, this green image as well as this little robot, these two are images, which in fact are vectors that then create this image. And then we have the layouts, in which we have our activity main XML file, which is this file here, which we're going to adjust accordingly in order to make our app look differently. So this is just for you to know where files are. The Gradle scripts, we're going to look at that a lot later because we're not going to touch that anytime soon. All right, but that's it for this video. In the next one, we're going to set up the emulator. Welcome back. In this video, we are going to set up the AVD, which stands for Android Virtual Device, which basically is an emulator that emulates Android on our PC. This then allows us to test our applications directly on the PC without having to connect our phone to it, or maybe you don't even have an Android phone, so you couldn't even test it. So let's go ahead and set up an AVD, and you can see here at the top it says no devices. That's because I have no Android virtual device set up. So let's go to the AVD manager. You can find it either this way, or you can also find it here on the top right hand corner, or well, even under tools you can find the AVD manager. So many different ways of finding this Android virtual device manager. So here you can set up your Android virtual device. So let's go ahead and create one, and you can then choose between different categories. So if you want to create a virtual device for TV or for the watch or tablet or automotive, you can change the category here. You will find more details here on the right hand side, and you can then select between different options. So what I'm going to do is I will use a Pixel 4 that uses the Play Store. So you can see this little icon here. Let's select this. Okay. You can of course also select Pixel 5, but the problem will be that it will not have the Play Store installed on it. So the beauty would be then that you can also install Play Store applications, but at the same time use Play Store extensions, which we will do at a later point in the course. But you can of course then delete the emulator and just create a new one. That's really very easily done. Okay, so then click next, and here you need to select the system image, which basically just means the Android Studio version. Now let me make the screen a little bigger so you can see everything a little better. So you can see that you can download the different versions, and the one that is allowed to me at this point would be Android 11, which would be the latest version. But I instead want to use an Android 12 version because I want to be able to run it even on Android 12 and just test if it works on new devices very well. So I'm going to go to x86 images here. That's because I run an Intel PC. In your case, you will then have to go to other images and then select an ARM-based emulator. So it really depends on what you're using. If you have an ARM-based PC, I would recommend to go to other images and then download the S version. So Android S with API level 31 with Android 12. In my case, I'm going to do the same for the X64, including Google APIs. You can also select the one with Google Play, but the Google APIs in my case will be good enough for now. If I ever need to change that, I will just download this and then just install the new Android version. So just to show you, this is how it's going to look like. So the component installer will pop up and it will download the latest Android version, which is another 1.3 gigabytes of storage, which I don't want to use now. Okay, so let's click next, and now we can give it a name. So it says Pixel 4 API 31. I'm going to call this one Android 12 as well. Now you can still change it from here. You can still change the version if you wanted to. Then the startup orientation will be portrait. In my case, I don't want to start in landscape. And you can also show some advanced settings once you click on this button here. And then you can change things such as what the back and front camera should be like. So I'm just going to say that it should emulate the front camera, but you can also use a webcam that you have installed on your PC in order to then use the actual camera of your PC for the Android virtual device. The network speed is something you can set up. So if you wanted to simulate a certain speed, let's say you want to test if your application runs on 3G, you could change that to UMTS or HSDPA. So that's something that you can do from here, but you can also change that later on, as well as some latency and so forth. So I'm going to select the quick boot, which will make the booting process a little faster. I'm going to say that it should use 4 of my cores. Now you can change that depending on how many cores you have. In my case, I have 10 cores. So I'm just going to say that my Android virtual device should use 4 of those cores. You can also change how much RAM your device should have. I'm just going to say it has 1536 megabytes of RAM, a little bit of heap, and 800 megabytes of storage. Now you can change that as well if you need some more storage for your device. In our case, we're going to create very small applications in terms of their size. So they will have certain functionality, which might be extensive, but the programs itself will not be very big. Okay, so that will be pretty much it. So let's click finish, and then you can find this Android virtual devices overview here. So you have one device at this point. You can see it requires 530 megabytes on the disk, but once we start it up, it will require multiple gigabytes. Now you can edit it if you want to make changes to it. You can wipe the data if you have any issues with it, or you can even delete it and create a new one. And you can even have multiple virtual devices at once. So if you want to test it on different devices just to see how it's going to look like on different device sizes and screen sizes, you can create multiple emulators at a time. But I would always recommend to just have one emulator running at once, because otherwise, well, it will require a bunch of RAM and CPU power on your PC. So now let's close this Android Virtual Device Manager, and you can now see here at the top we have the Pixel 4 API 31 Android 12 device selected, and we can now press this Run App button. Let's quickly do that to see if our emulator will pop up and even start our little application. Now in my case, I have installed some anti-cheat software for some video games, and that's what pops up here. So I'm just going to get rid of that. And it also even says that my antivirus program might impact the build performance, which means the performance at which an application is being built and run on a testing device. Okay, so there we are. This is my first app, and you can see it's basically this hello world that we have here. So before we change that hello world application, which we're going to do in the next video, we can see that our app in general works on this virtual device. And by the way, this is an actual Android phone, so to speak, on your PC. So you can just press the home button and you come back to the home screen. And now you can swipe up and you will find all of the apps that are installed on this device by default. So my first app, by the way, is also installed on this app. So let's on this device. So let's click on it and you can see my first app pops up saying hello world. Okay, so that's pretty much it. Before we go to the next video where we're going to create our first hello world application, let's quickly look at the settings. So if you click on this ... here, you can change the settings. So for example, you can fake a different location. Currently the location is set to Mountain View, Palo Alto, probably there where the Google head offices are, but you can make some more changes to your device. For example, here on the cellular, you can change the network type to 4G, 3G, 2G, and so forth. You can change the battery settings. So you can see now it's at 100%. So let's go down to, for example, 50%. You can see here, there it changes based on our settings. So these are little things that you can change. Also, now I'm charging, so you can see the HC charger setting is set up. So there's this little lightning icon there. And the camera, so if you want to use a specific camera, you can set that up here as well. So these were just some things that you can set up. You can of course go through all of the settings here to familiarize yourself with it. By the way, if you want to make your phone louder, you can do that with those buttons here. Or if you want to tilt your device or turn it, you can use those buttons here. Okay, so that's it for this video. See you in the next one where we're going to set up Hello World. Welcome back. In this video, we are going to change our code a little bit and prepare our first app to actually do what we wanted to do. And that is to not display hello world, but actually our name. So therefore, let's get started and look at what the code does for us. So let's go to the main activity. You can either go to it from here, and if you by accident closed it, for example, you can still find it in your app, Java, then the name of your package, and then main activity. So you can see this is the name of the package that we have selected when we created the project. And you can also find that package name up here. So eu.tutorials.myfirstapp. This just says that this file, all of the code that is in here, belongs to the package of eu.tutorials.myfirstapp. Then you find this import keyword. And this import keyword has 3 dots in it, which means there's something behind it. So you can click on it and then this pops up. You can see here Android X appcompat.app.appcompatactivity, which is a library or a namespace, however you want to call it. Both words are fine, which basically means that there is a lot of code behind it and it allows us to use its functionality. So if we delete this line of code, then suddenly our program starts to not work anymore. So we get an error. You can see here it's red underlined here, this main activity. So it doesn't understand what this override method does because, well, we never had set it up. So that's something that is set up in this appcompat.activity, which basically is a lot of code that somebody else wrote for us and we can now reuse in order to not have to write that code manually ourselves. So we should be thankful to them because they really save us a lot of time. So thanks a lot for doing that. Now we are using this appcompat.activity here again, you can see, and that is only possible because we have this import. Now the same goes for this bundle here. You can see saved instance bundle. Well, we're using this bundle code in our class main activity as well. So that's why we have these imports, and we're going to add more imports later on, which will then allow us to use different kinds of code and functionality, which is very powerful. If you want to understand more what's behind this appcompat.activity, you can just hold your command key or control key and then click on to the name here. And you will find that it opens up this declaration for this file. You can see it's called appcompat.activity.java. So it's a Java file. It's not a Kotlin file. You can also see that by its structure. So the code is slightly differently written. So you have the access modifiers here everywhere. You don't even need to understand what that is at this point. So you can see there are hundreds of lines of code basically allowing us to use them. And then the same goes for this bundle. You can just click onto it and then you can, well, access it and make changes to it, but I'm not going to do that for now. So then this is the important part. This is basically where our own code starts. So we have our main activity, which is a class. So then we have this class keyword, and we're going to look deeper into what a class is later on, but generally it's going to be the container for our code. It's going to hold our code and it will allow us to execute some code. So we call this class main activity, and it has this colon here, then appcompat.activity, which basically just means that it inherits from appcompat.activity, and we're going to see what inheritance is later on once we get to object-oriented programming. It would lead way too far for now. What's really important is that we have this onCreate method, which will be called once our main activity is going to be created. And by the way, an activity is just a screen. So if you have multiple screens in your application, for example, the login screen and then the profile screen and so forth, all of those would be different activities. And we're going to create multiple different activities later on when we create more complex applications. But that's what you just need to remember for now. Activity equals screen. And then we have this override function on create. So this is a fun, which means a function. This is not about having fun or something like that, even though you can have fun with functions, but this is our function, which is overridden on create. So basically it just means there is some onCreate method inside of the appcompat.activity, and we are overriding it with our own code. So we're just saying, okay, we're going to run our own code. Then there is a bundle passed here. That's something we're not going to cover for now. And the super method is called. So super onCreate saved instance, which just means that whatever appcompat.activity wants to execute by default in onCreate is being executed. And then comes the interesting part. That's where we actually can make changes. So this is going to be the set content view, which actually sets the content of the view. Who would have guessed it? And what we're saying here is, please set the content of our layout activity main. And where do you find this file? You find it under r.layout.activity main. So where is that? Well, R stands for resources. So if you go over here, you will find this res folder, not the generated one, but the other one. And then you will find a folder called layout. And that's exactly where our activity main file is. So we're just saying, okay, set the view to have the contents of our activity main, which means that this is the XML file, which will be actually displayed on our application. So let's change that up a little bit. First of all, click on this hello world here. You can either click on it from the component tree here on the left-hand side, just click on this text view, or you can access it directly via the designer view. So here, let's click on this hello world, and then on the right-hand side in the attributes, you can go to declared attributes. Okay, so there are a bunch of different settings. You can go to common attributes, to declared attributes, and so forth. So I'm just going to go over to the declared attributes, and we can declare the hello world to display something else. So here I'm just going to say hello Dennis and press enter. And you can see that now the text should say hello Dennis. We'll get a little exclamation mark, but we're going to ignore that for now. It would go too far at this point. We're going to see what that means later on. But now it just says hello Dennis. But I'm not very happy with that. I would like this to look a little different. I would like it to be bigger. So in order to change that, you can go over to your common attributes, and you can go to text appearance, and here you can change, for example, the font family if you want it to look differently. Here there are serif, black, medium, light, and so forth. You could change the typeface, but what I'm interested in is the text size. So I'm going to change that to 25 SP, for example. SP hereby stands for Scale Independent Pixels, which just means that it's going to look more or less the same no matter which device you're using, because pixels are different on each device. So let's say you have a big screen, then each pixel is going to look bigger, right? But SP, what it tries to do is it tries to make it independent of the size of the screen or the amount of pixels that the screen has. This text should always look the same, or more or less the same. It will never be exactly the same, but here at the top you can even select the device and you can see the DPI. So now if we look at it on a phone that has a different DPI, so let's say 560 for example, you can see the text still looks more or less the same. Okay, so I'm gonna go back to Pixel 4, which is the device that we're using here at the top. So that's how the text is going to look like. Now let's run the application. So click on this button here at the top and see what's gonna happen. And there we are. My first app says hello Dennis. Now of course it shouldn't say hello Dennis. In your case, I would like you to enter your own name here. Now you can of course also write something entirely differently, maybe even in your native language. If English isn't your native language, then just change that to whatever text you want to display and try it once again. With the common attributes here, for example, you could change the color as well. If you don't want to use black, you could use red, for example. I really love the color red. So change that, rerun the application, and then go over here and you will see that it says hello Dennis in red now. Okay, so that's pretty much it for this video. We have set up our first own changes. We understood what the main activity does and what all of this stuff more or less does, even though we are going to go into a lot more depth into what is happening here. So no worries if you don't understand what's up here. The only thing that you needed to understand is that there are packages you can import, different libraries that allow you to then use their code, and we have this container which basically is going to take care of what we can see on the screen by setting the XML file that we have here that we can then edit. And by the way, if you want to jump to this file directly, you can hold the control key, click on it, and it will jump to this activity main XML. And just a very quick one, we're not going to change anything there, but this designer here is just one way of looking at this. We're going to work a lot with the code, and this is how the code is. And we're going to see what all of that means later on in the course. but you will probably already see it says hello Dennis here. It says that there is a certain text color, which is this red, and you see that there's a certain text size that we have defined. And that is basically representing what we see right here. All right, so see you in the next video where we're going to create a people counter app. Welcome back. In this video, we're going to adjust our code so that we can actually interact with our application, because so far it doesn't really do anything, right? It displays hello Dennis, but we cannot press any buttons. There's nothing to do with it. Just to look at it isn't interesting enough, I believe. Well, let's change that by actually adding a button to it. So what I'm going to do is here in the palette, I'm going to select a button and I'm going to drag it into my application. So let's just put it in here. And let's scroll in a little bit. You can see that now the button is in our application. It says button and it has the, well, text hello Dennis underneath it. Now, there is a little bit of a problem with this button because it doesn't have any constraints. So it would look like this here, but once we run it on our application, on our device, you can see we get this little error here. So let's look at it and we can see the button jumps over to the top left corner. And that is because we are inside of a constraint layout. Here you can see that, and it needs constraints. So it needs to know where items should be displayed. And because our button doesn't have any constraints, it's just floating somewhere, it just thinks or assumes that we want to position it at the top left corner, which isn't what we want. What we actually want is we want this button to be exactly where we have it right now. Now we can go ahead and magically infer constraints by clicking this button here, and then it will magically just add this constraint so that it's just on top of our hello Dennis text, which is 33 pixels up from it. So if we rerun the application now, we should see that now our button will in fact be just on top of it. Now a cleaner way would be not to let Android Studio do it for us, but actually do it manually. Therefore, you can hold the mouse button on top of the button and then drag this circle to the top. Then drag this right circle to the right and the left circle to the left. So this will position the button towards the center. And then let's add another constraint so that it's connected to our hello Dennis text. So now this button will have constraints and it will be centered pretty much between all of its constraints. That's the default. And we're going to later on see how we can change the UI significantly by making, well, a bunch more changes, but that's going to suffice for now, I believe, even though I would like this distance here to be a little less. What you can do is you can go to your layout here at the top right corner here on the attributes and then change the constraints that you want to have. So you can see currently it just says that there is a vertical bias of 50%, which just means that it's in the middle on a vertical level, and the same goes for this horizontal bias, so it's 50% at the horizontal bias. So here, if you want to change that, you can click on this X button. It will delete this constraint entirely, but you can also override the distance that you want to have here. So if I'm adding 20, you can see now it takes the bias into consideration, but at the same time, it adds another 20 pixels distance. So if you were to add negative values, you would see it goes down here. So that would be one way. The other way would be to just drag this bias towards the bottom. So it's going to have a bias further towards the bottom. So this will make our button be closer to the hello Dennis text. There are other ways to play around with it and change it, but I would just say for now it's good enough to play around with the editor. Most of the time, however, in the future, we're going to work with the code, but I'm going to give you a pretty extensive introduction into what XML code looks like and how to use it for your purposes. So now let's make a couple of changes to this button that will be relevant, not just its appearance, but also what the text will say. So you can see once you click on this button and you scroll to the declared attributes, you find that it has a text, which currently is just saying button. I want to change that. I want to tell it, click me. Okay, so it should just say click me. Once you enter it, you can see that the name or the text changes that is appearing on the button. Now, there is an ID for any given item that you have in your user interface. At least you can set up an ID. This ID will allow you to access the UI element in your actual code. So if I want to, for example, register, I click on that button or I tap on that button in my code, I need to know which button was pressed because maybe I have 5 different buttons in there. So we always need to have an identifier or an ID which tells us what item was pressed. In this case, if the click me button was pressed, then the ID would be for that button would be just button. I would like for it to have the name my button, like so. And then this rename option comes up and I can refactor it. So rename the ID source button and its usage to my button. So I'm just going to do that. Now I can access my button. And let's actually do that. Let's go to our main activity and let's access my button. Therefore, we need to get access to this button. Therefore, let's create a variable here by using the val keyword. We're going to see what this means in particular once we look at Kotlin fundamentals. But for now, just follow along because I want you to have an application that actually does something in this video, and you're going to then step by step later on understand how all of this is working. So first we need to give this a name, and I'm going to call this one click me. So button click me, and then I'm going to use the find view by ID method, and I need to say that I'm using a button. So you see, once I enter button and I press the enter key inside of those brackets here, you can see that this new widget here at the top pops up. So this new import, which says Android widget button. So this now allows us to use the button class, which basically says, okay, now we can use buttons in our Kotlin code. Now here in those brackets here, in those rounded brackets, we need to say which button we want to actually find by its ID, because that's what this method does. So it just says, okay, find a button by its ID. So find a view. A view could be a button, it could be a text, it could be any viewable item in your activity main XML. So the button is a view, this text is a view, and well, any of those, like they also even have the name like image view, recycle view, they even have the view in their name, but you can access them directly. So here, let's say I want to find the button that was called my button. Okay, so I gave it the name my button. So now I can access it. Now this button click me, let's quickly change its text to haha. Okay, and then let's rerun the application real quick, just to see if we can actually access the button. You can see now it says haha and it doesn't say click me anymore. That's because what we did is here we got access to this button, and here at this line we overwrote the text of the button, so whatever the button shows as its content. So, but that's not what I'm interested in. Usually what you want to do with buttons is you want to be able to click on them and then execute some code. So in order to do that, let's add an action to our button. So let's use this variable button click me in order to set an on click listener. So here, if you enter this, you can see that there are multiple options. I want to use this on click listener with those curly brackets. So let's double click on it. And now inside of those brackets, I can now execute what I want to happen once I click on the button. So let's just use the same example that we just had, where we just set the text to haha, for example. And I would say you clicked me. So something like that. So now I'm changing the text of the button to haha, you clicked me by executing this code once we clicked on the button. So this on click listener is basically just listening or waiting for us to click on the button. So we're just saying, okay, once we click on the button, do something with it. And what should it do? Well, everything that is inside of those curly brackets, which is in the current situation just this one line of code. You can have multiple lines of code here. That wouldn't be a problem. You can see curly brackets here as well. So for example, this onCreate method here also has curly brackets. It starts here and it goes all the way down here. You can even press this minus button to see where it starts and where it ends. The same goes for our class. You see it has curly brackets. It starts there and goes all the way up to line 18. This is basically just the starting point here of this body of the code block, so to speak, and this is the ending point. And here, this one is the starting point of this onClick listener. This is the ending point of this onClick listener. So let's run this real quick just to see what's going to happen once we click on the button. And you see it says, haha, you clicked me. So well done. We changed the button, click, and it works. But now what I actually want to do is I want to access my text view, because I don't want to change the text that is on the button. I actually want to change the text that is in my text view. So how could I access it? How could I change it? Well, it will be a similar approach to what we've done here, where we find the text by its ID, but instead of using a button here, we would use the same name that this item has here. So here at the top it says text view. Okay, so this is AB, this is a text view. Currently it has the ID of 2 in my case. So if you go to the code here, not the design, you can see that it is a text view. This is, by the way, also the internal class name that you would have to use in your main activity, and you will have to import it the same way. So if you feel super confident and you really want to try it by yourself, I would recommend that you pause the video now and you try to access the text and change the text of the text view once it's clicked. It won't be easy, but you basically have to do a similar thing to what we have done with the button. Okay, so I hope you paused the video and tried it. This will not have been easy, but if you managed it, congratulations. So basically what you need to do is you need to get the ID of your text view. Now you can get the ID of the text view the similar way as we've done earlier. You click on the text view here, and then you look at its ID right here. Now if you want, you can change the ID. By the way, you can find the ID here as well, right? It's at the very top because it's very important, but you can change it from here as well. So in my case, it's called text view 2. In your case, it might be called text view without the 2 at the end. So what's important is that you use the one that you have in your case. So I'm just going to change that to text view because it's very likely that you have the ID of text view in your case. So I'm going to refactor that real quick. Okay, so this is now going to be my text view. That's the default ID. Of course, we could give it a proper name, saying something like my number text view, because I want to change it to be numbers later on. But for now, let's just use that. Let's go back to our main activity code. And now let's create a val, and I'm going to call this TV my text view. And I'm going to find it by its ID, find view by ID. And here I'm going to use the text view keyword. And then in the brackets, I need to give it the r.id, and I call it text view, right? Text view, like so. Now it's complaining because text view doesn't exist, because it doesn't know what to do with this text view class, as it didn't know about the button earlier. But now what you can do is you can just right click into it and then show context actions and then import. Alternatively, you can also hover over it and just press Alt Enter and then click on import, and it will add this import line here at the top, which now allows me to use the text view. Okay, so now we have this text view. Cool. So let's go ahead and use it. Let's now, instead of changing this button click me text, let's actually change the text of that TV my text view. So I'm just going to use the text property again, and I'm going to use the equal sign. So this equal sign basically just assigns something to this text, and I didn't really say that before, but that's what basically is happening. So I'm assigning something to this property here. So what is it that I want to assign to the text property of my text view? I want to assign, maybe let's just use this, haha, you clicked me for now. So now once we click on the button, both of them will change to haha, you clicked me. So let's test this real quick. Okay, click on it and you see both of them have been changed to haha, you clicked me. Now that's not necessarily what I want. What I want instead is I want to write a little program that is going to be a people counter. So each time that I click on the button, the number that is displayed should be increased by 1. So therefore, I'm going to create a new variable. This time I'm going to use the var keyword, because this is going to be a variable that will be changeable, and we're going to see what that means later on. But no worries for now. Just follow along now. So here, I'm going to call this one times clicked, and I'm going to assign a value of 0. So this variable now is going to hold the amount of times that we clicked on the button. So what I'm going to do each time that we clicked on the button, which means that this code will be executed, I'm going to increase the value of this times clicked by 1. So let's do that real quick. Let's get rid of this button clicked me text here. Let's say times clicked will be equal the old times clicked value plus 1. So that's how you can assign a value here. This is just a slower way of saying it. Of course, you could have also just said plus equal and then get rid of this times clicked, and this would have done the same trick. But that would go too far for now. It's just what Android Studio doesn't like. It just says, hey, this is inefficient, so just do it quicker with this plus equal sign. So you can click this replace with and it will do the trick for you. Okay, but I'm just going to keep it like this. So times clicked will be the old times clicked plus 1. Okay, and then we just need to assign the value of times clicked to our text view here. So instead of just saying, haha, you clicked me, we want to display the amount of times we clicked on the button. Now the problem is that times clicked is a number. And if you look at this text here, it actually expects a text, so a string and not a number. And we can very quickly change that by using toString here. So .toString will just convert this text into a string, and then this error appears. So again, you don't have to fully understand what's up here. No worries, we're going to go over all of those things. The idea behind this video is really just to give you a quick result of having an application that you can then test on your own phone and just have available. So for now, let's go back to our activity main and let's change the text from hello Dennis to, let's say, 0. Okay. So text, set it to 0. It will be this red 0. And now let's run the application. And let's click on the button, and you can see now it changes magically to 1, 2, 3. And each time that we click on the button, the number is increasing by 1. Now, if we were to close the application and we go back to opening it up, you can see it starts at 0 again. Once we click on it, you can see the numbers go up consecutively. So what is going on here? Holy smokes, Dennis. Well, the thing is, what we have done is we have our main activity code. So this is the class in which everything happens. So this is the view in which everything happens, right? And then we said, once the application is created, we want this code to be executed. And what basically happens is it sets the activity main as the layout that is used, which is this XML file. We changed this XML file with our designer by dragging in a button, by changing the text view and so forth. And we gave those IDs that we could then access. Now in our main activity, we access them by using the find view by ID method. This just allows us to say, okay, what is it that we are currently looking at? So we're searching for a button that has a certain ID, and we want to assign this to this variable called button click me. So we're doing that with this button click me. We're doing that with our text view. This text view, by the way, is of the type text view, and we can very easily find that out by, well, either looking here, you see a text view is called text view and the button is called button. And you can also go to the code. You can see this is the text view and this is the button. So these are the class names that you need to import as your widgets. So import Android widget.button. And we saw that this was done automatically for us by Android Studio. Thank you for that. And then we have this variable called times clicked, and we use var here because we want it to be able to change. But as I said, this will be something we will cover later on in more depth. And then we have this button click me, this button that we have defined earlier. The cool thing is this button click me comes from the type button, so it is of type button, and the cool thing is that buttons can be clickable. So there is this method called setOnClickListener that we can then execute. And basically what we add as code inside of those curly brackets will be executed once we click on the button. So what we're doing now is we're increasing the value of this times clicked from 0 to 1 once it's clicked for the first time, and then increasing it by 1 each time that it's clicked. And we're changing the text entry, so the text property of our TV my text view, to be whatever the times clicked currently is as a string. So this line here, there's a lot going on here. So no worries if you don't fully understand each detail, but the general idea is hopefully graspable for you. Now, before we go to the next lecture, I want to quickly show you one last thing. And that is how a toast works. So there is this beautiful thing called toast. Let's use it. It's not the thing that you can eat, but it's just something that you can write something on the screen with. So you use the keyword toast dot make text. Then you need to pass in the context. I'm just going to say this. Don't worry, just follow along. And then you say what you want to display. Hey, I'm a toast. And then you just say how long this should be displayed. And here you can just use toast length long. And then finally, we need to show this toast. Okay, so dot show. So if you want to display this beautiful thing that I'm going to show you in a second, just add a code like this and test it. And you see, it says, hey, I'm a toast. You can also say something like, hey, Dennis. Let's run it again. Click on it and you see it says, hey, Dennis. Okay, so that's what you can do with toasts. And you don't need to understand what's going on here in depth for now. The only thing that you need is this structure in general, and then you can just replace this text with whatever you want to display there. And we're going to see what make text means, what this means, what contexts are, what this length long is, and what this show method is, and so forth. You're going to learn about all of these things. This was just a little bit of an introduction and creating a small application that allows you to, well, do something. So now you can install this on your phone and you have your first little people counter, where now if somebody comes into the bus, or you are a teacher and you need to check how many children did come into your bus, you can just use this application now. Congratulations. Welcome back. In this video, I will show you how to run this application on your physical device, which means on your phone. Let's test this on a physical device. In order to run this application on your device, you need to activate the debugging feature. All right, therefore you can go to your settings and then scroll down to about phone. And here, so here in the settings, scroll all the way down and you should find about phone. And here you click onto about phone and onto software information. And there you find the build number. Now, when you click on the build number multiple times, now in this case, I have to enter my password. And once I entered my password, I can press next and my developer mode has been enabled. Now I can go back and go back again. And then in my settings underneath about phone, I will now find developer options. So here I can click on developer options and you can see they are turned on. So the switch is set to on. And now I can scroll down a little bit and activate USB debugging. So here you can activate this as well, and it will say allow USB debugging, and I'm going to say OK, because this will now allow me to connect to my Android Studio and directly test applications, test my code on the phone. Okay, now you of course need to also allow USB debugging once again. You can either allow it always from this particular computer or just do it once, and I'm just going to do it once here, and then I can run it on my phone. All right, so let's do that real quick. Okay, so there we are. Now let's click on the button and you can see click me works. And it says, hi Dennis, and the number is adjusted all the time. All right, perfect. So now you know how you can prepare your phone to test the applications on your phone, because this comes in handy if the virtual device is too slow or it just doesn't work for you, or for whatever reason you don't like it. You can always test the application on the phone. Now, of course, the application will be installed on your phone. So if you go over, you will find your Hello World application there and you can open it anytime. So you have installed the APK on your phone. You can now show this application to your friends. For example, you don't need to bring your PC. You can directly show the app on the phone. All right, cool. So that is something that you will be using quite a bit, or that I recommend you to use quite a bit throughout the course, because the phone is just so much faster than the Android virtual device ever will be. So it's just a lot more fun to use it on the phone, in my opinion. All right, so thanks a lot for following along. See you in the next video.
All right, so now we're done with the first chapter. You have seen how to set up your Android virtual device with Android Studio. then you have seen how to create your very first Hello World application and a little app that allows you to count. So pretty much just a people counter, you could use it for that, or whatever you want to count. So just a button that you can use and then display the number. All right, so that is it for this chapter. In the next chapter, we are going to get started with the Kotlin basics, and I think it's super important to look into those, because before we can start apps for Android, we need to know Kotlin or Java, but in this case, we decided to go with Kotlin because Google decided that Kotlin will be the future of Android development. So we need to look into the basics and then we can get back to Android development. So see you in the next chapter. Welcome to the second chapter. In this chapter, you are going to learn the Kotlin fundamentals. So the very basics of the programming language. We're going to start with variables and data types. So things that you need to consider when storing little bits of data, and then you can reuse them by using variables. So we're going to start with that. Then we're going to look at condition-based code. So we're going to only execute code that we define based on a condition. So only if a condition is met, then the code will be executed. And then we're going to see how to use for loops and while loops and other loop types, which are executed multiple times, so they can rerun your code depending on which part of code you want to rerun. And then you will see how to use functions, which are basically a way to combine pieces of code that you can then reuse. And this is a super powerful tool that will help you to develop more advanced applications and also makes your code a lot more readable. And we're going to look at nullables. So this is a concept that is not available in all programming languages, but it's used in Kotlin and it's used in most newer programming languages, I'd say, and it's super useful and powerful. All right, so what I would recommend is that you definitely do the exercises, so try to do them as well. Go through the video step by step, and if you have any questions, of course, we're there for you. All right, so thank you very much and see you in the next video.
Welcome back. In this video, we are going to get started with Kotlin code, and the focus of this video will be to, first of all, set up Android Studio so that we can use it in order to learn the basics very easily. And then we're going to learn the difference between val and var. These are super important keywords in Kotlin development, and they are really the absolute basis, because you need to have a way to store information for the runtime of your application. And in this case, we're storing, for example, the amount that something was clicked. So we're storing it in this variable called times clicked. But let's go ahead and create a separate project where we are going to not have all of this boilerplate code, so the code that just is created for us in order to get even something running. Let's really have a very simplified version of it in Android Studio. Therefore, let's go ahead and create a new project, and I'm going to create one with no activity. And I'm going to call this one Kotlin Basics. Kotlin Basics. Like so. You can call it however you want. And the package name is also not going to be very important in this case, because we're not going to publish this application. It's really just for us to play around with Kotlin. The only thing that is important is that you selected Kotlin here, which should be done by default. And now let's create the project. Now, what will potentially happen is that this screen stays open and you don't even know that there is a second screen open with the Kotlin Basics. So you will find that there are two instances of Android Studio. Okay, so let's go ahead and go into the app folder and then into Java. And what's important here is that you have Android selected here at the top. Otherwise, the structure will look differently, as you see here. If I select project, for example, or packages, everything looks very different. So let's go to Android, and then under Java, let's go under EU tutorials Kotlin Basics, or however your package name was that you have selected. And let's create a new Kotlin class/file. I'm just going to create a file, not a class and nothing else, just a file that I'm going to call basics. Okay, so this creates this basics.kt file for me, which is a Kotlin file. The extension KT stands for Kotlin. And now inside of it, you can see that it just has one line of code, and that says package EU tutorials.kotlin basics. If it has any more code in here, you can just delete it. What's important is that it is just a Kotlin file. Okay, now at this point, we can shut down this project part and we can get started with the code. So I'm going to start with the main function. So I'm using fun, main, and then brackets, and then curly brackets. So this fun just stands for function. So we are creating a function, and this function is called main, which is a very special function. It's not a general function. It's really a function that is the starting point of our application. So if I were to create another function here, let's call it hello, you see that it has a different color. That's because it isn't used. And second of all, I don't have this play button next to it. So this play button is only going to be available for the main function because, as I said, it's the entry or starting point for our application. It doesn't exist for this hello keyword. Now, inside of those brackets, I could add parameters. We're going to see what this means later on. For now, it doesn't matter. And then we have the curly brackets, and they are important because they are the body of the function. So what's inside of those curly brackets? That's the body of the function, and that's where we can add the code that we want to be executed once we run the code. So if I run this now, nothing will happen because there's no code inside of the curly brackets. So even though the Gradle build will run, there's really not anything to be displayed. So you can see here, no text, no nothing. Let's change that by quickly adding a print statement. So print is a very special method, and we can now enter something that it should say. So I'm just going to say print hello world. So if I run this code again, it will display hello world here. You can see now it says hello world. This print method is just a code block that tells our IDE, okay, I want to display something. So it displays it onto the console, which is this part here at the bottom. So here you see run. You can close this by either clicking on run here or by clicking this hide button, but then you can open it again by clicking on this run option here at the bottom. And then you can, of course, make changes to your code. So let's change this to, for example, hello Dennis, and run it again. And there you are. You see, it says hello Dennis now in our console, which is this part here at the bottom. Okay, so that's the print statement. And we're going to use print statements quite often because they just allow us to see the value of something. In this case, the something will be a variable. So I'm just going to go ahead and create a variable, and I'm going to give it the name, my name. So the variable is going to be called my name. And then I'm assigning Dennis to it. All right. So let's use my name instead of using Dennis here. So instead of saying Dennis, I'm just going to say hello, empty space, plus, and then my name. By the way, you can also see that we are using parentheses here. So these parentheses, they just say that this is a string. Okay, we're going to learn about the data types in the next couple of videos, but for now, we're just focusing on variables. So we see that we have this new variable called my name, and then inside of it, we store the value. So we assign it with this equal sign. We store the value Dennis. This allows us then to reuse this variable and use it in our print statement. So what we're doing here is we're just saying hello, empty space, and then at the point after that, we add the entry of my name. Okay, so let's run this and see what's going to happen, and you will see that there will be no change. It will still say hello Dennis. So now let's change that to, for example, Frank. So my name is going to be Frank. Now let's change it, and here at the bottom it will say hello Frank. Now there is another thing that we can do with variables, and that is to assign a different value to it. So I can now go ahead and use my name and assign a new value to it. So I could just say, instead of Frank, it should say Heidi. All right. So now my name is not going to be Frank, but my name is going to be Heidi at that point. Because even though it was assigned Frank at the beginning, it was overwritten later on. And then when it was actually retrieved or used, it had the value of Heidi. So let's run our project again, and we will see that now it says hello Heidi. So that is pretty much what you can do with variables. You can store values in them. And we're going to see what kind of values you can store in them, because currently we're just storing text in them, right? In this particular case, even names. But of course, you could store other types of text in them as well. And now we have used another keyword in the last video, which was val. So we didn't use var, but instead we used val. Now the difference between var and val is that a var variable can be overwritten. A val variable can not be overwritten. It can only be set once. So here we are setting the value for that variable, and it cannot be overwritten, which is why we get an error here. You see, we get a little problem. We can hover over it, and it will say val cannot be reassigned. So we cannot reassign a new value to a variable that is using the val keyword when it is created. So that means that this line is not going to work. Now we can get rid of it, and then everything will be fine. But now we have the name of my name. So we are writing a variable where we want to only be able to assign it once. We don't want our code at any point to be able to override that value. And that is what you would use the val keyword for. And by the way, it's also more efficient in terms of processing power. So if you know that you don't want to ever override the value for a given variable that you are creating, then use the val keyword. If you're not sure and you believe that you will have to override it at one point, then you use var. Of course, you can start with val, and then when you realize I actually want to override the value or reassign a new value to this variable, then you can change the declaration later on and change that to var. And you can go ahead and just change the name here to Claudia, for example. And let's run it real quick. And we'll see, we get hello Claudia. Okay, so that's basically the difference between var and val. In the next video, we're going to look at the data types of numbers. Welcome back. In the last video, we created our first variables and we used immutable variables. And we also saw what an mutable variable is. So immutable variable. Now, what I'm using here is a comment. So this here is a comment. This is code that will not be considered by the compiler, so it will not have any influence onto our application or our program. It's just a comment that helps me to understand what my code does, and it also helps other developers to understand what code does. And they are really great to not only understand what code does, but they are also great in order to know what you need to do. So for example, if you add to do, then you know, okay, at this point I will need to add a functionality, add new functionality, for example. And this is great because then you can go to your to-do window here at the bottom and you can very quickly find this. So let's say I go to a different document and I go to my main activity. And now in my to-do, I can simply find my to-do element and it directly goes over to this spot. And this is amazing because it really helps me to navigate through my files. In this case, it's super easy because I only have 2 documents. But once I have many different documents, this will come in very handy. Other than comments with just 2 slashes, we can also create multi-line comments by using a slash and then a asterisk. And with that, it automatically creates the closing comment or the ending comment, which is an asterisk with a slash. So everything in between here will be a comment. This is a comment. So this is a multi-line comment, to be precise. Multi-line comment. All right, so just so you know how you can create comments and what they do. So they don't have any impact onto our program, on the execution time, on the compiling time, none of that. It's just for us as a developer. All right, now let's have a look at other variable types. I told you that Kotlin is a typed language. This means that every variable is of a specific type. And type inference is a concept that allows us to just assign a value to a variable, and Kotlin will know of which type that variable will be. So for example, it knows that this is of type string. If I create another variable, let's say my age, and I assign 31 to it, then this my age variable will be of type string, will be of type int. So this is an int, and this here is a string. All right, ints are used for whole numbers, and they require a certain amount of space in our memory. For example, an integer requires 32 bits of memory. If we want to use other types, they're available as well. So I'm just gonna paste in some other types in here. For example, there is this type called byte. Then there's this type called short, the type called int, and the type called long. And all of them are integer types. And integer types are whole numbers, and each of them requires a different amount of space. So for example, a byte is just 8 bits, requires 8 bits in the memory. A short requires 16 bits in the memory, and 32 bits, and long 64 bits. Now here it says the value is out of range. So this value is too long for even a long value. So if you have a very long number, this could be used, for example, for a social security number or for a credit card number, then you could use a long. And here, actually, it doesn't fit like this anymore. So let's do it like that. And then we have a super long number here. Now, you might wonder, where is this byte, short, int, where are all of these coming from? Well, they come from me entering them. So here I explicitly say this variable called myByte should be of type byte. How do I do that? Well, I can do that by using the colon and afterwards the type. But of course, if I use a byte type, I can not use a long number, because now it will say the integer literal does not conform to the expected type byte. This means that the value that I entered here is so long that it's usually an integer. But we are trying to store it in a byte variable, and that doesn't work because an integer needs a lot more space than a byte. So we need to make sure that the value that we assign here is correct. Now at the same time, we don't need to do that. You see, I do that here. I say this is a byte, this is a short, this is an int, this is a long, but we don't need to do that. You saw it here. I just assigned a value 31, and that will automatically assign the right data type. And usually, if you don't explicitly say that you want to have a byte or a short, it will just assign an integer. Kotlin will just assume that this is an integer. How do I know that? Well, you can just enter my age, and you can see here on the right hand side that it is an integer. So Kotlin did the magic for us, and it automatically assigned the type int, which is called, or this approach here is called type inference. So it just inferred the type based on whatever value we assigned to it. Of course, if we do so, then we have to assign a value to it. So I cannot just create var my age without assigning a value to it. I need to assign a value to it. There are a bunch of other types as well. So these are the integer types that we looked at. Now let's look at the floating point number types. So there are types which are required for floating point numbers. For example, the floating point number types float, which is a 32-bit data type, and double, which is a 64-bit data type. Now here I'm assigning 13.37 to my float variable, which I called my float, but it's still complaining. So what's wrong here? Well, if I assign a floating point value, it usually assumes that I want to assign a double, as we can see here. But if I explicitly only want to use a float, which has a lower range, so which just can't be as long as of a number, then I have to explicitly state that by adding an f at the end. This f stands for float. So I'm just saying, okay, this variable should be of type float, or this value that I'm assigning here. So if I should get rid of this, for example, and I now check my float, you will see that it is a float. All right, so if I get rid of this f and I check what my float is, you can see now it's a double. And that has to do with me assigning this f to it and explicitly stating that it should be a float. So if you really need to save space, you can use floats if the numbers are not going to be huge. But if you need flexibility, long numbers, or you just don't care about space, then you can use doubles. And generally speaking, doubles are preferred by Kotlin, or they will be most of the time used if you don't explicitly state that it's going to be a float. Using floats is important, for example, when you develop video games and you want to calculate the physics. Then having as fast as possible calculations will be more important than having super duper precision. So that's where float comes into play. But most of the times double will be your way to go. All right, so these are the number types, but there are other types as well. Welcome back. In this video, we're going to look at other data types such as booleans. So for example, Boolean is a type which represents logical values. So it can have two possible values, true and false. So we have this variable called isSunny, and I'm going to make it a Boolean, and now I'm going to assign true to it. Let's say a little later the sun is not shining anymore, then I can just say isSunny is going to be false. So I reassigned a new value to it. So I assign false to it now, so sunny or isSunny will now be false. Of course, I don't need to assign the Boolean to it, or I don't need to explicitly state that I want to use it as a Boolean, because once I assign a Boolean value such as true to it, it will know that isSunny is going to be a Boolean type. Then there is another type which is called character or char. So you can assign a char by using the apostrophes. So here you can see the value letter char is just an A, and I make this a char by assigning a value, or a letter in this case, which is surrounded by apostrophes. So if we look at letter char, we can see it's of type char, which is character. The digit char is also of type char. It's really not that much of a difference. It doesn't matter if it's an A, a 1, or even a $sign. But as you can see, it cannot contain more than one sign. That's the limitation of char. So a string is basically a connection of multiple chars. It's just multiple chars together. In this case, it's 5 chars which come together to becoming a string. Now that we talk about strings, let's have a look at strings a little more. So let's assume we have this string variable, which is called myString or myStr, and it has the text hello world. Now, if I want to access a certain character from that string, what I can do is I can use the following approach. So I'm going to call this one first char in string, and this will be my string at the position 0. Why 0? Well, because Kotlin is a language which starts calculating or counting at 0. There are other programming languages which start counting at 1, such as R, but most programming languages start counting at 0. So 0 is the first letter. So if we print this now, let's say we want to print this first char in string. So let's just do that. First character, and we run this code. So let me run it again, and we see first char or first character is H. All right, so in hello world the first character was in fact H. Now if you want to get the last character, what you can do is the following. So I'm just gonna paste it in here. Last character in string will be again my string, and then in square brackets I use my string.length. With this I get the length of the whole string, and then I say -1, which just says okay, give me the last one, because if the length is in this case 11, so 5 characters here, then 1, which is this empty space, and then another 5 characters, we come to 11 characters. So 11 minus 1 is going to be 10. So we're going to get the 11th position, which is going to be the D. So now let's just print out the last character, and we can see it says last character is D, which is in fact hello world with the D. All right, so summing it up, there are multiple different types that we can use when we create variables. Variables are immutable if we use the val keyword, and they are mutable, so changeable, if we use the var keyword. Then we don't have to specifically state what kind of data type we want to use if we assign the right value to it. If we assign a value which is of a specific type, such as a number, which is a whole number, it will automatically assume that we want to have an integer. So if we want to have a byte or a short, for example, then we need to explicitly state that by creating the variable with that type. And with long numbers, we can use an underscore in order to make it more readable. This is a new feature that is super useful. We can use that for integers as well, by the way. This makes them more readable. And the same concept goes for doubles as well, where it assumes that we want to assign a double if it's a floating point number, but if we want to specifically use a float, then we have to state that by adding an f to the number itself. Then there is the type Boolean, which is used to only have two states. So either something is true or something is false, which is super useful, and we will use that quite a bit. Then we have characters, which we can use in order to just use one character, which doesn't have to be a character, but it can also be a number or a symbol. Then we have strings, which is a collection of a bunch of characters, which we can use for text. And if we want to print something out, we can use this print statement, which then prints it onto our console, which is this little area here at the bottom, which helps us to test stuff and test if a certain variable has a certain value. Of course, there are other ways to do so, but the print statement is a very convenient one. And another one important aspect, and I told you multiple times, but I really want to state it again, you don't have to specifically state your data type because of type inference. And maybe I'm going to add this word here, type inference, which just means that finds out the type from context, which is super powerful and useful and makes our life a lot easier in most cases. So I'd say see you in the next one. Welcome back. In this video, I just wanted to quickly talk about a concept that is called string template or string interpolation. So when you hover on the values inside our print statement here, you can see that there is a suggestion. So it says I should convert the concatenation to a template, because what we're doing here is we're concatenating, right? We're adding strings together. But the alternative is to convert that into a template. And that is something that Kotlin prefers and is a very magical feature because it just adds this with a button click. So it's pretty cool. So here, instead of adding two strings together, it's one string. So it's just this one statement, but then it uses this $sign and then the variable name. So it just says, okay, at this position, please replace the entry in the string with whatever is inside of first char in string at that point. So in this case, we will receive the same result. We will still get the character H, but we don't have to add this plus and the empty space and so forth, which can be very tedious when you have a very long statement where you use multiple different variables. So this $sign here, it starts a string template expression. So let's look at it with a little more depth. So here we can actually make a whole sentence and at the same time get values that we need from any variable. So we have this first character is, and then first char in string, and the length of my str, my string is, and then let's use the length of my str. So how do I get the length of my str? Well, we saw that with this here. Okay, so my str.length gives me the length of the entire string. In this case, it's 5 plus another 5 and another empty space, so it should be 11, right? So how do I get the length? Now, of course, I could go ahead and create an extra variable that stores the length. So let's call this my length. And this would be my str.length. That could be a way, but there is another way. How about we just copy this here and put it in there with the $sign? And you see that this doesn't seem to work properly because there's this So let's just run this real quick. And it says the first character H and the length of my str is hello world.length. So that's not exactly what I wanted to achieve. So how can I make this work properly? Well, the thing is, you can just surround it with curly brackets here. So let's surround my str.length with curly brackets, and then it will treat it as an entire statement. So now we're using dollar and then the curly brackets with the statement inside that we want to be used. So let's run it again, and we will see first character H and the length of my str is 11. So this concept is called string template expression or string interpolation. Welcome back. In this video we are going to look into operators, and we're going to start with arithmetic operators. So I want to show you the following. The arithmetic operators that you probably have seen before, of course, as you were in school, I guess. So plus, minus, the multiplication, division, and then the modulo operator. So this might be the only one that you have not seen because it's not very common to use the modulo operator outside of programming. So what we can do is we can, of course, create a variable called result, and it's going to store the result of a calculation. So we're using this arithmetic operator, the plus sign, so we're adding two values. And by doing so, what we get is 8, and the 8 will be stored in result. So it's not going to store this calculation itself, but it's going to store the result in this variable called result. So now what we can of course do is we can print result. So let's do that. But before we do so, I'm going to comment out the print that we had before, this last character one, and let's run this. And there we are. So I had to run it twice again due to the bug. So we can see 8 is printed onto the screen. Now what we can do is we can override result with a calculation that will use result itself. So if I do something like this, where I say result equals result divided by 2, it will store 4 in this variable called result. So now, instead of 8, it's going to print 4 onto the console. And there we are, it says 4. Now you see that I get a little warning or a tip here where it says replace with /equal. So instead of saying result equals result divided by 2, I can say result /equal 2. This will give us the same result, so the same value pretty much. So what this line here does is it says the result value is going to take its own value and then divide it by 2 and then store the new result into itself. So in this case it's going to take 8 and then it's going to divide by 2. So that's what this slash sign does. So now instead of using the slash, let's multiplicate. So let's use the asterisk here in order to do the new calculation. So it's going to take the old result and now multiply it with 2. So this will result in a 16. So let's test this. And there we are. It says 16 here at the bottom. So that's the multiplication. Now, of course, we can also use the plus sign. Plus equal will then add 2 to the whole thing. So it should be 10. And there we are, it says 10. And of course the same thing with the minus. So minus equal 2 is going to be, in this case, 6. So all of that is cool, but what is this modulo operator? What does it do? Well, let's see what we have here. So let's say we want to have a result which is going to be 15 modulo 2. Let's just test what we get there, just to see what the result will be. And we can see we get 1. So what is this 1? So what the modulo operator does is it gives us the remainder, which pretty much means 15 divided by 2 is going to be 7, remainder 1. So it just gives us the 1, which is the remainder. So the rest, so to speak, of our calculation. If we use 3 here, for example, the remainder will be 0, because 15 divided by 3 is 5, remainder 0. So if we run it twice, we can see the remainder is 0. Now, on the other hand, if we use 4, then the remainder will be 3 because 15 divided by 4 is 3 and remainder 3. And there we are. Now, of course, what you also can do is a calculation like such. So var A is going to be 5, var B is going to be 3. And because we're not going to change them, we can also use val here. So we make them immutable. And of course, the result can be A divided by B, for example. So this works as well. And of course, all calculations will work here. Now, what you can see is it says the result is 1, even though 5 divided by 3 should be something like 1.66666. Why is that? Why does it not give us the right value here? Well, that's because it says that this is an integer. So val A is going to be an integer and val B is also going to be an integer. So if we divide integers, then we also get an integer as a result. An integer only contains whole values, so it cannot have a floating point value, or it cannot be a floating point value. So what we can do is we can make this one, for example, a double. So if I do 5.0 and then try to divide it by 3, you can see I get an error here. It says type mismatch, required int found double. So now it's trying to divide a double by an integer, and that creates this type mismatch. Now, what can we do about it? Well, the thing is that our result itself is an integer. So we cannot do this calculation because result is an integer. Now what we can do is we can either make this whole thing an integer. So we just say toInt. By this, we make this whole expression an integer, or the result of this expression an integer again. So this is a function or a method called toInt, and what it does is it converts this value into an integer. That solves the problem, as you can see, but that's really not going to give us the result that I wanted. I really wanted this to be a double, which means I wanted this to be a floating point value, which will give me something like 1.66. So that's not the solution. The solution is to change the result type to a different type, or to create a new variable which contains the value in a different type. So what I can of course do is I can go ahead and say result double, for example, is going to be of type double. So now I can go ahead and use my result double instead for this calculation, and also print result double. All right. The other way would have been, of course, to change this variable here, but because this variable is created and already used for something, later on changing it can be very tricky. In our example, it's not really tricky because we are the developers of this line of code. But let's say we are using this variable and it was created by someone else, and he used this variable at multiple different points in his application. So then we have this situation where we are using a variable and we are changing it, and maybe even changing its whole purpose, and then it might not work for other occasions where it was used. So that's something that we really want to avoid. So we just create a new variable which will be of the right type, of type double, and then we do the calculation. So now let's see what the result will be of this calculation. And if we do so, now we can see we get this 1.66666, and then at the end it says it's a 7 because it just can't add more sixes, because it would be infinite amount of sixes, but at one point it just rounds up the last value here. All right, so that was a little look into arithmetic operators and also into types. So we have to be careful with the types that we are using. So I'd say we check out the other type of operators that there are, and the next one will be comparison operators. So see you in the next video. Welcome back. In this video we are going to look at another type of operators, the comparison operators. So comparison operators are the ones that you can see here. So double equal, not equal, less than, greater than, less than equal, or greater equal. So now let's see how they are used in Kotlin. first of all, let's create this variable called is equal, and it's going to be the result of the following operation, which means 5 equal 3. So what does that do? Well, it checks if the value on the left hand side is the same as the value on the right hand side. So that's what this double equal sign does. So it's comparing two values to each other, and it's going to give us a Boolean result. So it says it's a Boolean expression, even though we can simplify the Boolean expression. So let's just do that. You can say it gives me the result directly, which is false. But of course, that's not what I wanted, because what I wanted is to display this operation here, which is just saying, okay, one side equal the other side, or is the one side the same value as the other side of this double equation here. So if you do that, you will get a result which is either false or true. So if we do the same with 5 equals 5, then of course the result will be true. And in this case, it's super obvious because we can see those values. But let's say they are hidden behind a variable where you can't always see the variable's value, then this will be a very useful operation, because maybe you even want to do something based on that operation. So let's say if this condition is true, then you want to run some code. Then it's going to be very important to do these type of comparison operations. And of course, this is also something that we are going to look at later on, which are if statements. But for now, this is our very simple operation that we have here. So now let's go ahead and print something onto our console. And I'm going to write is equal is plus is equal. So what I'm doing here is I'm using concatenation. So it's just using this string, and then it's converting this into a string and just saying whatever the value is. So if we run that, we can see that is equal is false. So our is equal is false. So then, of course, our IDE, which means our Android Studio, says, hey, you can convert concatenation to a template. So let's do that. And you can see what it does. It changes this to having a very different way of writing it. So one was the concatenation, and this one is a template that we're using here, which requires this $sign. So what we can do is we can use this $sign, and afterwards, whatever the value or the variable that we want to use will be printed here. So in this case, it's just going to be the result of whatever we had here. So if we run this, it will result in the same type of print statement that we have here. So I need to run it twice, and there we are, is equal is false. So now let's use this a little more, because let's create another comparison where I'm just going to create is not equal is going to be 5 not equal 5. So let's just test if that is true or false. Of course, it's going to be false because 5 is equal 5. But if we just print that now, and let me print this again, but now with is not equal. All right, so now I'm using is not equal instead of is equal, and I'm going to comment this line out, and I'm going to change the name here as well. So it's going to be is not equal is, and then let's see if it's true or false. And we can see it says is not equal is false, because 5 is equal 5, but we are checking if 5 is not equal 5. So this exclamation mark here says that it should be not equal. So this here is another way of testing a comparison. But of course, there are a bunch more that we have here. So what we can check is, let's say, the following. So instead of creating a new variable for every single one of those comparison operators, let's just do it in the print line statement directly. So is greater, so in this case is 5 greater 3 is going to be, and now I'm using something very cool here, because I'm using another pretty cool feature here of Kotlin, where we have the same principle that we had here, but now because we don't just have one variable that we want to put into a string, but we want to put a calculation, so to speak, or in this case a comparison. So a whole expression, so to say. And then we need to use these curly brackets. So we're saying, please run the code within the curly brackets and then print the result in this stead. So at this spot of our code. So now if we run this, we can see that it says, is 5 greater 3 is true. Well, of course it's true because 5 is a greater number than 3 is. But now let's say we check the same thing with a -5. If that is greater than 3, then it should be false. And there we are, it says false. Of course, I didn't add the minus here in the print statement. All right, but you get the gist of it. Now, of course, we can do the same with some other print statements here. So println is 5 lower equal 3. And then please try to do the expression in here. So try it yourself before I will show you how to. All right, so the expression starts with a curly bracket, and then we say 5 less than equal 3. All right, so this is the expression. Now let's see what we get as a result here. And we can see, is 5 lower equal 3? It says false, because 5 is a greater number than 3. So the whole expression ends up being false, and that's what we get as the print statement here. So this concept that we use here is called string interpolation. All right, so just so you have seen this keyword. Of course, you can now go ahead and do the same with the other comparison operators that we've seen there at the top. So instead we can use greater equal, and here is higher or greater equal 3, and then we saw the other one, right? Actually, is less 3. And now let's run this. So now we have all of our results here. Is not equal is false. Here is -5 less than 3. It's true. Yeah, of course, because a negative value is going to be less than a positive value. Then we have is lower or 5 lower equal 3 is false, and is 5 greater equal 3 is true. Now, of course, we can also set a 5 in there just to see if this is still gonna work. And once we run it, we can see is 5 greater equal 5 is also true, because 5 is equal 5. That's why this equation is correct. So this greater equal is accepting both. So it's gonna return true if the left value is greater than the right value, or if they are equal. All right, so that's it for assignment operators. In the next video, we are going to check out increment and decrement operators. So see you there. Welcome back. In this video, we are going to check out the assignment operators and the increment or decrement operators, because we are going to use them quite a bit. So assignment operators are the ones you can see here, and we have already seen them to a certain degree, where we just had a variable, and I'm going to call this one my num is going to be 5, and then I can go ahead and say my num plus equal 3. So what that will do is it will add 3 to my num value. So it's going to be the same thing as if I wrote my num equals my num plus 3. All right, so these two are interchangeable, and as you can see, it even prefers the other one. So it even prefers the operator assignment, as we have seen here. All right, so assignment operator is this plus equal 3, or this minus equal, or multiplied equal, and so forth. So now I can of course go ahead and print this. Println is going to be my num is $my num, and I'm going to comment out all our other print line statements from earlier videos, and let's run this again. And as we see, it says my num is 8. All right, so that is an assignment operator. Now please go ahead and multiply that with 4. So multiply my num with 4 and store that in my num, but use an assignment operator for this. All right, I hope you tried it. So it's my num multiplication or asterisk equal 4. And now let's print this again in the next line. And we can see it's 32. All right, so these are the assignment operators. Now let's look at the increment and decrement operators, because they are something that is used quite often as well. And they're just a double plus or double minus sign. So we can just go ahead and do the following: my num plus plus, nothing more than that. So let's print my num again. And this is going to be here. Actually, let's print it here, and let's print it after the incrementing. So this plus plus is incrementing, which means increasing the value by 1. And then minus minus is decrementing, which means decreasing the value by 1 or reducing 1. So once we run this, we can see my num is 32 and my num is 33. So my num is 32 here at this line and 33 in this line. So that's what this increment does. Now let's do a decrement, and at that same time I want to show you something that is super interesting, and that is to use the increment after use, which means we use increment after my num, and then again we can use it before. So in this case you can see we cannot just use this approach, we have to use the brackets. So I'm going to use curly brackets here as well, because this is an expression that I want to execute before actually printing it on the screen. So let me show you how this will impact our application here. So let's run this again. All right, so there we are. So we had my num is 33. That's this line here, right? So we increased my num of being 32, which was at this point, and then we increased it by 1 here. Then we go ahead and print that number, and then we say, okay, let's increase the value by 1, but for some reason it didn't increase the value. Why is that? Well, that is because this plus plus will only be executed once this line of code is finished. So pretty much at the beginning of the next line. So in line 75, my num is still 33. Then it's increased by 1. So in line 76, at the beginning of the line, it's going to be 34. And then we do plus plus my num, which means we increment just before we execute or we use this variable, which means that now it was 34 at this point plus 1, which means now it's 35, and that's exactly what is printed onto the console. So now you can see that my num is 35. So that's the difference between using the plus plus or the increment or decrement operators before or after, because it really has an impact on when they are executed, and now you know the difference. But very commonly it's used afterwards. So you increment afterwards because usually you don't use it in line as we do it here. So now please add another print line statement just underneath it. So in line 77 in my case, just underneath this statement, and there decrease the value so that it will show my num is 34 as the next print line statement. All right, so I hope you tried it. So what I need here, of course, is to use minus minus before my num and not after my num. So I'm going to decrement the my num variable just before it is going to be displayed and printed onto the console. So just before it will be used, so to say. So there we are. It says my num is 34. All right, so that's assignment operators and the increment and decrement operators. And in the next video, we are going to see how we can finally use some of those operations usefully, because so far we had some examples of what we can do with it, but now let's see what we actually can do with it and get something from it, because so far it has been rather fundamental or rather basic. So see you in the next video where we're going to check out if statements. Welcome back. In this video we are going to use if statements, and we are going to finally make use of what we've learned so far. For example, the comparison operators, which are very useful when it comes to if statements. So we had this comparison operator where we said 5 equal 3, and then if that was true, we can now go ahead and execute something. So now let's go ahead and create an if statement here. And before we do so, I'm going to create a little variable called height person1, and it's going to be something like 170, and then maybe height should be written correctly, and then I have another one, height person2, should be something like 189. All right, so these are centimeters for those of you who aren't aware of what I'm talking about. So 170 centimeters and 189 centimeters. I think that's something like 5'7" or 5'8" or something like that. And then this should be 6'3" in terms of feet and inches. All right, so these are the two height person 1 and height person 2. So we have two people, and we want to execute something based on a condition. So if person 1 is taller than person 2, then we're going to use raw force in order to beat it. Let's say we have a fight between two people, and now we have to decide what kind of technique we want them to use. So let's say our fighter is 170 and the opponent is 189. So what shall we do? Shall we either use raw force or shall we use technique? Of course, a combination of both will be useful, but then we're going to check if height person 1 is greater than height person 2. I simply want to print something like use raw force. All right, so let's say, or let's assume that if someone is taller, then he's also going to be stronger because he's going to have more weight, and that is going to be very useful in a one-on-one fight. But now, if we execute this line of code, we will see that pretty much nothing will happen because the condition isn't met. So we have this condition of height person 1 shall be greater than height person 2. But if we look at the values, we will see that that is not true because 170 isn't higher than 189. So we can see we get nothing here printed. So now let's say the other way around. What shall happen if height person 1 is less than height person 2? Well, that's something that we can use with an else statement. Okay, so in this case it's either if or else. So if this condition is met, then execute the code that is within those curly brackets. And if the condition is not met, then run the else block, which means run the code which is within those curly brackets. So here I'm just going to say use technique. All right, so now let's run this again and see if anything will be printed whatsoever. And we can see it says use technique. So because our person 1 was smaller than the other one, we advise him to use his best techniques instead of trying to apply raw force when fighting one-on-one, because we're one hell of a coach and want only the best for our fighter. But what shall happen if they are both the same size? So let's say we have the situation where both are actually the same size. Is there any special advice that we can give our fighter? Even though in this example it's rather weird to have such a situation, but let's just say we have this other condition. So what you can do is you can have an else if. So there are 3 different types of checks. So the if check, then the else if check, and then finally the else, which is not really a check, but which is a code that will be executed as a default if none of the above are true. So what does that even mean? Well, let's say we have an else if in between here. So let me show you. So we have an else if again with a condition. So here I'm going to say that those two have the same height. So equal. All right. So we had this first condition here, which was height person 1 greater than height person 2. Then we had the second condition here, which was height person 1 is equal to height person 2 when it comes to his size. And then we can execute some code if that condition is met in here. So let's just say something like use your power technique 1337, something like that. So the fighter has a power technique and it's very useful against people who are the same height as he is. So he should use that technique. But then we have this else block, which will be executed if none of the above are true. So if neither this if statement or this condition here is true, nor this condition here is true, then the else block will be executed. So then the text use technique will be executed instead. Now the cool thing is, you can have as many else ifs as you want. So we could go ahead and check if the height of person 1 is greater than 150 and execute some code. Then check if what should happen if the person is smaller than 140, or all kinds of combinations that we can think of. Even though we have to be careful that certain conditions don't overlap with each other, because if they overlap, then one of them will be useless. Okay, so what we have here, if we execute this, let's say when the person 1 and person 2 are both 170, then it should display use your power technique 1337. So there we are, it says use your power technique 1337. So let's say the person 2 is smaller than the person 1, then it should say use raw force. So there we are, use your raw force. All right, and what you see here, so this whole if, else if stuff is a control flow, and we're using if statements here. Now a little challenge for you. Please go ahead and create an if, else if, else if, else block where the first age check will be greater equal 21. And if that's the case, then it should write something like, or print something like, you may drink in the US. Then else if the age is greater equal than 18, then you may vote. And if somebody is older than 16, you may drive. And then finally, if none of the above is true, then it should print something like you were too young. So try to use this kind of structure to print those different statements based on a variable called age that you of course also need to create. So go ahead and try that. All right, so I hope you paused the video. So I'm going to create this variable called age, and actually I'm not going to change it, so I could go ahead and use a val here. So the variable will be age, and then I use an if statement here. If age was greater equal 21, then I want to print something saying now you may drink in the US, because in other countries you may drink before that, right? If you do that, then in our case, of course, this will not be printed because age is not greater than 21. But now let's have another check. So else if the age is greater equal 18. So what shall be printed if that's the case? Well, let's print something like you may vote now. All right, println, you may vote now. And then we have another check, age greater equal 16. And then in the US, you may drive. So println, you may drive now. Of course, you need a license for that, but at least you can make the license or do the license at this point, and then you can use it. And then finally, we have an else block, which will be executed if none of the above is true, which means if the person is 15 or younger, then it should say something like, you're too young to do whatever. All right. So if we run this, you probably already guessed it, it will print you may drive now because our age is 17. All right, so let's run this. And there we are. So it says you may drive now. Now, if the age is, let's say 31, as I am, you can see it says now you may drink in the US. All right, so of course I can do all of the others information as well. So I also may vote, I also may drive now, and so forth. Of course, I could adjust the print statements here accordingly, but this is the latest thing, so to speak, that I can do due to my age. All right. So we have this if else block that we can use in order to execute stuff when certain conditions are met. Now, by the way, a thing that you can also do if you have a very basic if statement. So let's say you only have one line of code that follows a condition. So age is greater or equal 30. Then you can just go ahead and do or add the text in the next line. You're over 30. All right, so that's something that you can, of course, also do directly. So just one line of code without having these extra curly brackets around it. So if you see anything like that, that's what it does. But you have to be careful, because in the next line, so if I add something like this in the next line, this line will not be part of this if statement. So it will be executed either way. So be careful here. Alrighty, so these are the if statements, and in the next video we are going to look at when, because you might see already that it's complaining. So it says cascade if should be replaced with when. So let's do that in the next video. So see you there. Welcome back. In the last video we looked at if statements, and I wanted to give you another example of if statements, and this time with a different type, because we used integers and we compared integers, and you can even see that it says I should change that to a when statement, so a simplified this expression. And if I hover over it, it says cascade if should be replaced with when. And I told you that we would look at when expressions in this video, but we're going to do that in the next one, because I want to do a little more on if statements. Because, for example, I want to create this variable called name, and I'm going to set the value to Dennis. So now I want to show you how to use if statements with strings and other data types. So if name is equal Dennis, then I want to write something like welcome home. So print line, welcome home, Dennis. All right, but else I want to say, who are you, for example. Okay, so this is something that we can also do. So we can check strings as well. What's important is that whatever is within those brackets can be either true or false. So it has to be a Boolean that will be the result of whatever is within the brackets. So the simplest form would be, we have a variable here, is rainy, is true, for example. So now it's raining, and now I can check if is rainy is true, then do some code. So println it's rainy, even though here of course it's complaining, or it says the condition is always true. So is rainy will always be true because it's a val, so it can never be changed. If we change it to a var, then it at least can be changed. So now this warning is not there anymore. But you can see this is another way of doing if statements. So the important part is that whatever is within the brackets can be either true or false. So is a Boolean in the end. Another important aspect of if statements that I haven't covered yet is the following. If we look at this if statement here, we can see that it says age greater equal 21, and here it says age greater equal 18. So this statement is true if that statement is also true. Or let's say this statement here is true if that statement here is true. So what this means is that even though the statements underneath are also true, we first of all look at the first one. And if that one is true, then we ignore all the other ones. That is something very important about if statements, because they always only look at the first expression if it's true. And if it's not true, then it starts to look at the next expression, then at the next one. And if none of the expressions are true, then the else block is executed. So it's not like all of them will be executed if the age is greater than 16, because all those three would be true, right? But only the first one. And that is generally true for if statements. So it always goes top to bottom, which means first line to last line of this if statement. And this is a whole if statement block, so they're all interconnected to each other, which means that this else block really depends on all of the other if and else if blocks to be false. Otherwise, it will never be executed. All right, so I'd say let's go to when expressions and see how they are different to if statements. So see you in the next video. Welcome back. In this video, we are going to look at Kotlin's when expressions, which is a replacement for switch statements from other programming languages such as C, C++, C#, Java, and many others. So if you have never seen any switch statements yet, no worries, because it's something that is similar to what we are going to build in this video, and it's just what is used in other programming languages. But it's a more compact and more powerful tool than the switch statements of those other programming languages. So let's go ahead and use it. And therefore, I'm going to go ahead and, by the way, our IDE already said, hey, why don't you use a when expression here? So when we use this if age so-and-so, it said a better way would be to simply use a when expression or simplify this expression. Of course, I could do that directly here. The IDE would do everything for me, but I want to build one myself. So I want to build a when expression myself. Therefore, I create a new variable called season, and it's going to be season 3, or I'm going to set the season to 3. And then I have a when expression. So I use this when keyword, then the brackets, and then the variable that I want to look at, because here I specifically look at a variable. Let's say I look at the season. And depending on what the value of season is, I want to execute specific code. So let's say season is 1, then I want to execute the code which just says it's spring. Then if season is 2, I want to execute the code that is going to be summer. So you can see the structure is the value, then an empty space, and then minus greater sign, and afterwards the code that you want to execute. Now, of course, you can also go ahead and execute a multi-line code. So it doesn't have to be a single line code. And here I'm just going to say println fall, or println, or in this case, both println autumn. And then, of course, we have our final season, which is winter. All right. So println winter. So what is the default case? So the case that should be executed if none of the above is true. So if season is neither 1, nor 2, nor 3, nor 4, well, then we can execute the else block with the else keyword. All right. So here I'm just going to say invalid season. So at least on Earth, we only have 4 seasons. So let's say we were on another planet, maybe there were more seasons, but these are all the seasons that we have. So this is in general how we go about using when expressions. So you have a variable that you look at. It doesn't have to be an integer. It could be a string as well, but we are looking at a variable, and then depending on the value that we have, we execute some code. Now, the cool thing is we can go ahead and do a slightly different approach to this as well. So I'm just going to go ahead and say I have a month instead of a season. So here the month will also be 3. But now, when the month is 1, then we, for example, have winter. 2 is also winter. 3 is spring. 4 is spring. 5 is spring, and so forth. So each season has 3 months. So now what we can go ahead and do is we use the when keyword again. In the brackets, we say which variable we want to look at. And then in the curly brackets, that's where our code, our execution code will be, where we check the different states. So let's say I want to execute 3.5. So in those months of 3 to 5, I want to print spring. Then in 6 until 8, I want to print summer. So you see, very similar approach, only that now we're not looking at just one value, but we're looking at a range of values. Here the range is from 6 to 8, and then of course we can also go ahead from 9 to 11. So print ln fall. All right, but now what do we do with winter? All right, we cannot do something like in 12 ... 2. Print ln winter. Because if you hover over it, it says, did you mean to use down to? Because it says this range is empty. Well, we could try down to, but now what it will do is it will go from 12 down to 2. And we had those cases here already. You can see that if you want to go a range down, you can use the keyword down to. But what I want to do is actually have the values 12, 1, and 2. So I can do it like that. I can just say, okay, if those 3 values are true, or if the month is one of those 3 values, then please go ahead and just print ln winter. And then of course our else case, we can just use the same as we did before. So else println invalid season. And now if we execute that, then we will see it's fall, autumn, and then finally we have spring, because month 3 is March and March will be spring. Alrighty, now a little challenge for you. Please rebuild what we had here, but do it with a when statement or when expression. But don't just use the autocomplete feature here, okay? Alright, so I hope you tried it. So what we need to do is, of course, go ahead and use when age. And now we have the different cases. So let's say somebody is 21 and above. So we can use 21 ... let's say 150, because no one is older than this age. Of course, we need to use the in keyword. So let's say in that range. If the value is in that range, then please just go ahead and print you now may drink in the US. And by drinking, I mean not water, of course. Then in 18 to 20, we can say something like you may vote now. In 16 and 17, and here we don't need to in keyword actually, so let's get rid of those. We can just say you may drive now, and then finally we have an else block which says you're too young. So this is something that we can of course do, especially the one here at the top. But what if I don't want to write it like that? Because I just want to say if somebody is none of the below, so none of the less than 20 or 20 included. Well, what you can do is you can use this exclamation mark before the in keyword, and you just say, okay, if it's none or not within 0 to 20, then run this expression. So what that will just do is it says, all right, if the person is less than 0, so younger than 0 or older than 20, then execute this code. Alrighty, so now you saw how to use when expressions. Now I want to show you one more thing about when expressions, because we also can use a keyword which is called is. So we have this variable x, let's say, and it's of type any. So I specifically say that it's of type any, which means that it's of type object and other programming languages. So if you know any other programming language, it just means that this is going to be of any type of type. All right, it could be any type. That's pretty much what I'm saying here. And I'm just assigning a value of 13.37. And now I can check x for its type. So I can just say if it is an integer, then please print something like x is an int. But if it is a double, then please print it's a double. And then of course if it is a string, print ln is a string. And finally, we also have this else block here as well, where we say, okay, println x is none of the above. Okay, so this is something that you can also do using this is keyword to check if it is of a certain type. That can be very useful because sometimes you get data and you don't know of what type it is, and then you want to execute code based on the type that the data is, so that the variable is that you're looking at. All right, so if we execute this, we can see that it says 13.37 is a double. Of course it is a double because there is a point or a dot there. So let's say we would add an f here, which makes this a float value. So instead of double, now it's going to be float. Let's see what we get, because it should say is none of the above. So 13.37 is none of the above. So it's neither a double nor a string nor an int. While looking at when expressions, you can of course also use not is. So you can say something like not is double, then is not a double. All right, let's run this again just to see if this or else will be executed. And there it says 13.37 is not a double because it is not of type double. It's of another type. But you can also see this is never printed because this statement here is true. X now could be of any type except for int and double for this whole thing to be true. So let's just say we want to make this a string and see if this string here at the bottom will be executed. Let's see. If it says x or x is a string and it says x is not a double. So you see we have the same order here. It goes from top to bottom because this statement here is true. Actually, this one here, this one and that one, so those following ones will never be executed. Even though this is in fact a string because we added the exclamation marks around it. This is a string in fact. But this code will never be executed because one of the above is already executed. All right, so it all follows the same structure as we had when looking at if and else if. All right, so it always goes from top to bottom. So you see, when is just an alternative for if, but sometimes it's more convenient and more precise and dense. And it just reads when x is of certain value or type, then do something. So do whatever is after the arrow. Welcome back. In this video, we are going to look at another control flow, which is one type of a loop, and there are multiple types of loops. And we're going to start with the while loop. So a while loop executes a block of code repeatedly as long as a given condition is true. So we're looking at this while keyword. Then we have a condition in the brackets, in the square brackets. And then in the curly brackets, we have the code that should be executed as long as the condition is true. So now if we look at a specific example, it could look like this. So we have a variable called x and it should be 1. So it starts with the value of 1. And then we compare and say as long as x is less or equal to 10, we want to execute the following code. We want to say x. So it should just print the value of x, nothing more than that. All right. So if we do it like this, then we get an infinite loop because this while statement will always be true because 1 is always less than 10 or equal to 10. So what we need to do is we need to at one point lead to an end for this condition. So this condition has to end at one point. It's really important. It can either be done through whatever happens within the while loop, or it can be done from outside. So let's say we execute something as long as the mouse is moving. As soon as the mouse is not moving anymore, we don't execute it. This is a very basic example, and this is something that probably shouldn't happen. But if you look at our mouse, while we're moving it, it's also changing its position in our UI. Even though, of course, it will not be executed via a while loop, how the mouse is displayed, but it's going to be something that really is calculated all the time, meaning our screen, so refreshing the whole screen and displaying the position of the mouse at a specific point. All right, so this while loop will be executed all the time until the point where the condition is not true anymore. So we need to actively lead to an end of this condition, meaning that we can do something such as incrementing x each time that this while loop is executed. So what will happen now is our x is 1 in the first iteration, then this condition is checked. So is 1 less or equal 10? It's true. So execute the code block. And in the code block, it's just going to print x, whatever x is, in our case 1. And then it's going to increase x by 1, which means that in the next iteration, it's going to be 2. So we check, is 2 less or equal 10? It's true. All right. So please execute the code block. So it's going to print 2 and increment x by 1. So it's going to be 3 in the next iteration. And that's how it's going to go until it's at 10. So it's going to check 10 less equal 10 is true. All right. So execute the block. Print 10, increase x by 1, which means x is going to be 11 now. So we check, is 11 less or equal 10? No, it's not. So don't execute the block anymore, but go to the next line of code, whatever that will be. So if we have something here, while loop is done, only then this while loop is done, code will be executed. So let's execute this code. And we see 1, 2, 3, 4, and so forth, 5, 6, 7, 8, 9, 10, and while loop is done. Now, if you want to print them next to each other and not line by line, you can, of course, instead of writing print ln, just print it and it will print it just next to each other. So there we are, 1, 2, 3, 4, and so forth, while loop is done. Now, by the way, what if you want this while loop to be in the next line? So this text here, while loop is done. Well, how you can do it is you can add an additional line break manually. How would you do that? Well, you do a \n here. This \n is not going to be interpreted as an n and as a string, but it's just going to say, or it's going to be interpreted as a code, so to speak, and it's going to create a line break. So as you can see, it's also orange. It's not green as the string is. And that's generally what the \/ does. It escapes the character. So that's the keyword here. It says escape. So it escapes the n, which means that it will be ignored as a string, but it will be used as code, so to speak. So if we run that again, then while loop is done will be on the next line of code, or on the next line in this case of our console. You can also see that this empty space here is also over here. So you can even get rid of this empty space and it will still work. So there we are. Now there is no empty space at the start of the line anymore. So now a little challenge for you. Write a while loop which only prints every second value descending from 100. So it's going to print 98, 96, 94, and so forth. All right, so please go ahead and try that. All right, I hope you tried it. So we start at 100 and we go down to 0. And then instead of plus plus, we say minus equal to. All right, now it's going to print the value and it's going to go down by 2 each time. And maybe we even start at, well, in this case 100 will be included. Otherwise, what we could do is go from 99 here, but I said going from 100, so let's just see what it's going to print. And there we are, 100, 98, 96, 94, 92, 90, 88, and so forth. So it goes all the way down to 4, 2, and 0. So in these examples, it's a very basic type of code that is executed. It's really just printing something on the screen. But this can be super useful in many different applications when writing code. So while loops are not only useful for what you can see here, where we just print a value onto the screen, but they're really useful to just execute a code multiple times. And yeah, that's something that we're going to do quite often in the future. And we're going to use different loop types. So not just the while loop, but also the for loop or even the do while loop. And of course, also the for each loop. So I'd say let's just go to the next video where we're going to look at the next loop type, and we're going to look through all of them step by step in this course. Welcome back. In this video, we are going to look at do while loops. And do while loops are very similar to the while loops, and they just differ in a small detail or small difference, which means that they don't check before they execute at least once. So what does that even mean? Well, let's have a look at this. Let's say we have this variable, again, this variable x, and let's say we start at 1, and then we do the following. So we do, and we only do while, but we do at least once. All right, so I'm just going to write down the syntax before we do anything else. So I'm going to use this x again. Actually, let me set that to 1 here. It was 100 here. So let's leave it like this. All right, so we have this variable x, and then we have this do keyword, curly brackets, and then we have this while keyword. In those curly brackets, it's important that we get to a situation where this while statement is not true at one point anymore. And it's done by incrementing x in our case. So in this case, this do while loop will be run 10 times. It will go from 1 to 10. So let's print something here. I'm just going to print x here. So nothing too fancy again. And I'm just going to say print do while loop is done. So there we are. It says do while loop is done. Let's scroll up. 1, 2, 3, 4, 5, and so forth. And then the do while loop is done. So how is that different to the while loop? Well, the difference is that, let's say our x is not 1, but it's 15. Then this condition is not true because 15 is not less or equal 10. It's higher than 10. But the code will still be executed at least once. Let's just see what that really means and how that looks like. And there we are. It says 15 and do while loop is done. So it printed 15, but it didn't do the rest of the iteration. So it didn't run 10 times or however many times. It really just ran once because the condition is not met. But still, it ran once. And that's something that is really important sometimes. So when would you use a do while instead of a while? Well, there are multiple applications, but let's say you want to run an execution on multiple users of a list. But you need to get that list from a server. So what you would do is you would try to establish the connection to the server, and only as long as the connection to the server works, you want to print the names of that list, or you want to work through that list. And that's something that you would do first, and then you could check, okay, is the connection established? And if it's established, then run through the list or do the execution. Of course, there are multiple more applications for this, but we will see throughout the course when it makes sense to use do while. So I'd say let's just check out for loops in the next video to see the third type of loop, which is very similar to a while loop. So see you there. Welcome back. Before we go to the for loop, I wanted to show you another application of the while loop because it will make it a little more clear what the difference is and when to use what. So for example, the for loop is really there to iterate through ranges, arrays, and so forth. And we will see what that means in the next video. But before we do so, we will have to look at while loops, which are great to execute a block of code repeatedly as long as a condition is met, as we saw earlier. So let's have an example where we don't look at numbers, because so far we only looked at numbers. We said, okay, var x, as long as x is y, then do something. But now, let's say we have the situation where we have a variable called felt temperature, and that one will be cold. So let's say we are in a room and it feels like it's cold. So we don't know directly what temperature it is in terms of degrees, right? In terms of degrees Celsius. So we have also a value called room temperature, which actually is that value. So let's say 10 degrees. And now we will run a while loop, which will increase the temperature, the room temperature, by 1 degree until it's warm enough so that the felt temperature is not cold anymore. So here we are just going to say, as long as felt temp is cold, please run this while loop, which will, as I said, increase the room temperature. So now, of course, we still need a situation where this condition is not met anymore. So we need to create this situation. So we can check if the room temperature is greater or equal 20, then set the felt temperature to comfy, so to comfortable, so it's not going to be cold anymore, and also print something onto the console, println, it's comfy now. So now if we execute this, it will just print it's comfy now. Why is that? What happened in this whole thing? Well, we set the felt temperature to cold, because when it's 10 degrees Celsius, then it's pretty cold and you don't want to be in the room when it's that cold. You want it to be 20 degrees Celsius, which is 68 degrees Fahrenheit. All right, so what you say is, as long as it's cold, please turn up the heat. So increase the room temperature by 1. And as soon as the room temperature hits 20 degrees, then set the felt temperature to comfy. So now in the room, we feel like, all right, it's comfy. It's a good temperature. We can maybe even get rid of our jacket. And then we can print, it's comfy now. And our while loop will stop. So at that point, our while loop will not increase the room temperature anymore, and it will jump out of this whole loop and execute whatever comes afterwards. So this is just another application where you see that it doesn't have to be an integer that we're checking here. It can be whatever condition that has to be met. And as soon as this condition is not met anymore, the while loop will stop executing its block here, its body, its code block. Welcome back. In this video, we are going to check out for loops, and they are used to iterate through ranges, arrays, collections, or anything that provides an iterator. And you'll learn about iterators, arrays, ranges, and collections in the future lectures. So no worries there. But basically, it's just a set of values that are stored in one construct or in one type of data type. All right, as we've seen, there are multiple different data types, such as ints, doubles, strings, and so forth. But there are also data types which can store many values at once, and they're types of collections or iterators. All right, so what we can do is create for loops as well in Kotlin, and a for loop is also very similar to a while loop. So we can just go ahead and use the for keyword, and then num in 1 ... 10, and execute some code. And I'm just gonna execute, actually I'm gonna execute it in one line. I'm just gonna say print num in a string. All right, so this for loop here, which we have in 3 lines, so to say, is the same thing as our while loop that we had here, where we needed to create a variable, then we had the condition, then we did the execution of something or write something on the screen, and then we needed to take care of the condition at one point not being met anymore, and that's it. All right, but now we sum everything up, so it's a lot shorter. So here it just says, for the number which is in this range of 1 to 10, please execute the code in the block. And in our case, we just do something simple where we just say, okay, print the number that you're currently looking at. So if we run this, we can see that it just prints 1, 2, 3, 4, and so forth, up to the point where it's 10. So where the value is 10. All right. So this is just one way of writing a for loop. There are other ways as well. You can also, instead of saying num in so and so, you can say I in 1 until 10. So that will pretty much give us the same result, where we, for example, just print I, and I'm going to add an empty space here. Let's run this. And we can see that it printed the 1, 2, 3, 4, 4 and so forth from before, from this for loop. And then we have this 1 empty space, 2 empty space, and so forth from this for loop. So here we just use this until keyword, where we just say, I want to have I in a range. So this here is a range, where it says start at 1 and go up until 10. Now it goes the other way around as well. You have seen the keyword down to, so please now go ahead and try to build a for loop which goes from 10 down to 1. Okay, I hope you tried it, because we just used this keyword already, so I thought it would be a great idea to use it in here as a little challenge. So for I in 10 down to 1. All right, and I'm just gonna say that there should be a line in between so that we see that this is the down to approach here that we had. And there we are, 10, 9, 8, and so forth. So what can you do if you want to have steps of not 1, but let's say steps of 2? Well, you can simply add the keyword step in here and then say how big the steps should be. So down to 1 with the steps of 2. If we run this, then we will see 10, 8, 6, 4, 2, and nothing else. That's it. So there's another way of writing this, what we have here. So this down to approach, and in general for the for loops. So this is pretty much the same as doing the following, as if we had this line here, dot step 2. Okay, so either you write the for loop like this, or you can also write the for loop like that, where we just use this slightly different approach. All right, but you can of course do the same thing for our other for loops up there as well. So for the second one where we said I in 1 until 10, we can also say for I in 1 dot until 10. Internally, the same thing will happen. Alrighty, so these are some examples for for loops. We're going to use them extensively, especially as soon as we have collections, lists, arrays, and all those kind of cool type of collections. So see you in the next video. Welcome back. In this video, I would like to introduce the break and continue keywords. Those two keywords are super useful when it comes to for loops or loops in general, because they allow us to get out of the current iteration or get out of the for loop entirely if a certain condition is met. So here I have this for loop. Let's just use a print statement here where I'm just going to print I. So this will print all the way up to 19. So from 1 to 19. Let's look at it and we can see 1 to 19. So that's cool and all. So now let's look at what we can do with the break keyword. So what I'm going to say is, let's divide I by 2 and then check if that is going to be 5. So basically at 10 that will be the case, and in that case break out. So just break, which means that finish this for loop or don't iterate through the for loop anymore. Basically continuing the code down here. So print done with the loop. Okay, let's run it again. You can see it's running all the way to 10 and then it breaks out. So let's run it again, and then you will see that it says done with the loop. Okay, so that's cool. So basically what happens here is, once break is executed, it gets out of this entire loop. So this for loop is done and it continues the code down here. So after the for loop. Now, this is very useful if you get this data from an external source, or if this is dependent on the user input, for example, or something like that. In our case, it's rather unuseful, you could say, because, well, why not just say until 11 here? That would do the same thing and you wouldn't have to work with breaks. But this is not the point here. The point is really that you can use the break keyword in order to jump out of a for loop or a when expression when a certain condition is met. And that would usually be a condition that you have no control over, that is either random or has to do with data that you get or something else. Okay, so that's the break keyword. Now let's look at the continue keyword. And therefore I will need to push this print statement further down. And now let's use continue, like so. Okay, let's run it again and see what's gonna happen. So you see 1 to 9 is there. There's no 10, there's no 11, and then it goes from 12 to 19 and it's done with the loop. So what happened here? The thing is 10 divided by 2 is going to be 5, right? So 10 divided by 2 is 5. So this if statement is true. So it goes into this continue. What continue then does is it says, okay, stop with the current iteration and go to the next iteration. So skip the code that is inside of this for loop and then go to the next step. So it goes from 1 to 2 to 3, and this is never met, right? This condition. But then at the point when it's 10, this condition is met, and it just says, okay, skip the current iteration, go to the 11th step. Okay, then it's checking 11 divided by 2 is equal 5, and it says true, because 11 divided by 2 is 5.5, but because we're working with integers here, it doesn't save the 0.5, so it just saves 5 in there. So it is 5 equals 5, so it's met as well when I is equal 11. So then it just says continue, so skip the current iteration, don't execute this code anymore, and go back to the next iteration. Okay, so that's basically what's happening here. It's super interesting, but yeah, that's really here. So 10 divided by 2 is 5, and then 11 divided by 2 is 5.5, which is 5 in terms of an int, because integers cannot store this 0.5 thingy, right? So it just cuts off whatever comes after the dot, it cuts it off, and that's why the 11 is not appearing here either. So just continue through it, basically skipping this part where the value is actually being printed onto the console. All right, and that's pretty much it for the break and continue keywords. Welcome back. In this video, we are going to look at functions, and functions are something that we have used already. For example, the main function, and now we're going to see how we can create our own functions, which we then can use to reuse code very easily. And in order to do so, I'm going to clean up this whole main function now, because it's going to be a lot clearer if we have everything on one screen. So we have this main function, and as you know, this is the entry point of our program, and that's where everything begins. So if no code is in here, then nothing will happen if we start the program. So that's important to know, and you know that already. So the next thing we can do is we can create code outside of this function and then call it within this function. And in order to do so, you can just go ahead and create a new function with the keyword fun, and then you give this a name, and I'm just going to call this one my function. And this is generally the structure that you have. So you have this keyword fun, then you have a name for the function, you have rounded brackets, and then you have curly brackets. And within the rounded brackets, you can put all your parameters, and within the curly brackets, you can add the code block that should be executed once this function is called. So what do all of these terms mean? Well, we will see in a second. So let's get started first with something very basic. So I'm just going to use print here, and I'm just going to say called from my function. All right. So now let's just call this my function. How do we call a function? Well, we call it by just using the name of the function and then the brackets here. And if we have any arguments that we want to pass, then we need to pass them as well. So let's run this code just to see if this is working. And once you run it, you will see that it's going to say called from my function. All right, so this print statement that was within my function, so within the function that we called my function, was called once we called this function here. So if we decide to call this function twice, then it's going to display called from my function twice here. And there we are, called from my function, and again called from my function. And as we are using a print statement, they are directly after another. So there's no space in between or no line break either. So this is our very basic function called my function. Now we can extend functions. And in order to do so, I'm going to create a new function. So we can make functions a lot more complex. For example, I can call one add up, and I'm just going to have two variables here. I'm going to have one variable which is of type int and another variable which is also of type int, and it should return a variable of type int. So what do all of these things do? Well, first of all, we have two parameters here. So this is parameter 1, which is called a, which is of type integer. And then we have another parameter which is called b, and it's also of type integer. So now the keyword here is parameter. All right, so we have two parameters here. Then after the colon, we say of which type the return type should be. So in this case, our function add up is going to return something once we call it. So instead of just executing some code in there, it's also going to return something. So it's going to give us something back that we can then reuse. Okay, so the idea here is that we need to use the return keyword. As you can see, it's complaining here. So now it's complaining about the returns. So let's say I always return 0. Then this add up would always return 0 no matter what I put into it. So let's change that a little bit. Let's say I want to actually add up those two values, so a and b. So what we would do is we would return a plus b in this case, because we want to return whatever a and b are added up. Now it's going to return whatever is the result of a plus b. So our parameters is the definition of the input that we want to have. And then we have an output, and it's also of type int. So whatever we return will be our output, and it should be of the type that we have defined here. Parameter input, and then return type is our output. Okay, so now we can go ahead and use this function add up in our main function. So I'm going to get rid of my function calls here. I'm just going to call add up, and I'm going to add up with 5 and 3. So this should return 8. Now the thing is, it will return 8, but we have no way of knowing that it returns 8 except for, let's say, we store it in a variable or we use our debugging tools. But I'm just going to store it in a variable, which I'm going to call result. And it's going to be the result of whatever add up is going to come up with. And it's going to store it in result. So now what I'm going to do is I'm just going to use result is and concatenation here result. So very basic. And of course, we're getting the template request here. So this is the alternative way. All right, so result is result. And now we can go ahead and test what we're actually going to get. So there we are. It says result is 8. As you can see, it worked. So the input was 5 and 3, and the output was 8. And that is what we saw as the result. Now, there is something to say about the terms here, because here, what we are using is called parameters, right? So we are using parameter A and parameter B. Now, when we pass a value to our function called add up, this is an argument, and this is also an argument. So the term here is argument. All right, you're not having an argument here, but we are using arguments. Okay, so the idea is that there are two different terms, and this is something that people mix up all the time. And yeah, in some cases, they really just ignore the whole concept of parameter and argument, or distinguishing between the two. So either parameter or argument is going to be fine when you use it in combination with functions, okay? But be aware that there is a difference between the term argument and parameter. So I might even mix the terms sometimes when talking about functions, so please be forgiving. Then there is another thing about functions, and you probably heard the term, or maybe heard the term, methods. So there is this called method, and a method is a function within a class. So that's the only difference between the two. Otherwise, they're the same. So in some programming languages, which are not object-oriented programming languages, then it's always going to be a function. But in programming languages which are object-oriented, it's going to be most of the cases a method, because it is defined within a class. In our case here, however, we are not having a class, so it's not like in our main activity. For example, in our class main activity, there we have a function called onCreate. But to be more precise, this is a method because it is within a class, so it is a method here. There are a bunch of other words that come up in programming languages, right? And what it really helps is a dictionary sometimes. So Kotlin Programmer Dictionary, you can find it under blog.kotlin-academy.com. So they wrote a little dictionary with the main words here. So function versus procedure, then function versus method, and so forth. So here are a bunch more. Field versus property, what's the difference here? Parameter versus argument, that's something that we have seen before, and so forth. So if you want to really dig deep into all of the different terms and terminology, then check out this article here. Alrighty, so coming back to our Kotlin basics, a little challenge for you. Please write another function which will not add up, but which will build the average of two values. So here you have to be careful with the data type, and yeah, just please try to build that function by yourself. All right, so let's go ahead. I hope you tried it. So here I'm just gonna use the func keyword, and then I'm gonna call this one AVG, standing for average. And I need two values. One of them will be a double, and the other one should also be a double. So the thing about those is that the return of an average usually is not a whole number. So that's why I'm using doubles here. And it's going to be a double as a return type as well here. And then we can return A plus B divided by 2. That's going to be it. So now, of course, we can see what the result is. So let's call this one average instead. And we're going to not call the add up function, but we're going to call the average function. And I'm just going to say, okay, what's the average of 5 and 13? And then in order to be precise, we need to make those doubles. So 5.3 and 13.37. And now let's run this. And there we are. It says result is 9.334 or 335. Alrighty. So these are the basics of functions. So what's the whole point of functions? Well, there are multiple advantages of functions. So one of them is that you can reuse code. Another one is, for example, that you can work with a partner. So you take care of one piece of code and he takes care of another piece of code, or she takes care of it. And then you can just combine them by having functions that you can then reuse. So you can write your own functions, and then you can both use the functions of the other person. And then another thing is that you can use functions that are pre-built, and you can just use the functionality of them. So that's the whole idea of functions. They add functionality to your program, and you can simply use them for whatever purpose you built them, or for whatever purpose they were built. And there are gazillions of functions out there that you can reuse just by using this import feature here. As you can see here, import Android OS bundle. Well, in there are a bunch of functions that we can reuse. So if you open up the bundle class, for example, you can see that in there you have a bunch of constructors, but then we have a maybe prefill has FDS function. Then we have another function called for pair, which is going to return a bundle. Well, you might wonder what all of these public static bundle keywords mean. Well, the thing is, this is Java code, so this is not Kotlin code. And in Java, the structure of a function is slightly different than it is in Kotlin. All right, but the basic idea is the same. It has a return type, then it has a name, and then it has a bunch of parameters here. Just the order is a little different, but in the end, what it does, it has a bunch of code that you can then reuse. So no worries if you don't understand the stuff that is going on in here, because for one, it's not Kotlin code, and the second thing is you don't need to understand everything behind the function in order to use the function. Sometimes you just need to have the output, right? And that is really powerful. It's like driving a car. You don't have to be a mechanic in order to drive a car, or you don't need to be able to repair a car in order to drive a car. You can just sit in there and be happy about all of the features that were added to the car and that you can now use. All right, so these are the basics of functions, and yeah, let's check out the next video where we're going to look at nullables. So see you there. Welcome back. In this video, I would like to start with a little history lesson in order to get to nullables, because nullables are a type that is only necessary because of a decision of Tony Huer, which was made in 1965 as part of his Algol W language development. So he invented this language, and then he also invented this null reference, which now finally results in a lot of null reference exceptions or null pointer exceptions. So errors that come up quite often in programming, and they are called by himself as a billion-dollar mistake, or his billion-dollar mistake. So it was the invention of the null reference in 1965. At the time, I was designing the first comprehensive type system for references in an object-oriented language, Algol W. My goal was to ensure that all use of references should be absolutely safe, with checking performed automatically by the compiler. But I couldn't resist the temptation to put in a null reference, simply because it was so easy to implement. This has led to innumerable errors, vulnerabilities, and system crashes, which have probably caused $1 billion of pain and damage in the last 40 years. And I believe that is quite a lot more than just $1 billion, because it takes so much time very often to figure out what the problem is. And now it's a lot easier than it was in the past, so I can imagine it was really a pain back in the day. And yeah, now there are a bunch of cool tools which make life so much easier when it comes to null pointers or null references. So we're going to look at one of them, which are nullables in Kotlin. And if you come from a programming language like Swift, then you know this term as a optional. So in Swift it's called optional. Here it's called the nullable. So the idea is just that it's a null type, or a type that allows to be a null type. So just a type that allows variables to have a null as its value. So not a zero, but a null. And in some programming languages, it's called nil, in Objective-C, for example. But in Java and in Kotlin, it's called null. So let's go back to our code. And here I cleaned up again. So I have only my main function. So Kotlin supports nullability as part of its type system. That means that you have the ability to declare whether a variable can hold a null value or not. And by supporting nullability in the type system, the compiler can detect possible null pointer exception errors at compile time and reduce the possibility of having them thrown at runtime. And that is super useful because you can see null pointer exceptions before they happen, so to speak. So before they happen on your phone, for example, when developing apps. All right, so let's see how we can even create such situations. So first of all, I'm going to create a new variable, and I'm going to call this one name, and it's going to have the value of Dennis. And I'm going to explicitly state that this is going to be a string. And it will make a little more sense once we go to the nullable types. So what I can do is I can assign a new value here. So instead of Dennis, I could rename myself, and my name would be Adam. But what I cannot do is I cannot assign null to my name variable. Why is that? Well, because as you can see here, null cannot be a value of a non-null type string. So if you create a variable, as we've done in the past, then it's a non-null type. And it doesn't accept to be empty, so it has to have a value. So what can we do if we want to have a variable that accepts null as a value? Well, we can make it a nullable value. So I'm just gonna call this one nullable name, and it doesn't have to have this nullable at the beginning. So this is just a name that I give it, and I explicitly say again that it's a string, but now I'm adding a question mark. So this question mark now allows me to assign an empty value there. So I can go ahead and say nullable name is going to be null. So here I don't get a compilation error, and it totally accepts it. That's because I said, okay, this will be of type string nullable, or of type nullable string. So we have this new variable, and I call this one nullable name, and it gets a value at the beginning, and then I assign null to it. But of course I could have also assigned null to it straight from the get-go. Okay, that could have been an option as well. So now I have a nullable, and let's have a look at the difference between the two. So what is really the idea behind all of that? Now let's say I want to go ahead and get the length of my name. Well, I can very easily do so by using name.length. Now if I go ahead and do the same thing with my nullable name, I suddenly get an error because it says only safe or non-null asserted calls are allowed on a nullable receiver of type string. So how can we fix that? Well, there is one way and there is another way. So let's go ahead with the first way, which is the old-fashioned way. So this is how you would have done it in the past if you hadn't, or when you didn't have the option to use nullables. So what you could do is you could check if nullable name is not equal null. Only then go ahead and do that, and otherwise just return null. So that would be an option to do it. Okay, so you can see we can now access the length if the nullable name is not null. Otherwise it will return null. Alright, so that's the old-fashioned way, and this is not necessary in Kotlin because we have a much shorter approach to this. So instead of doing all of that here, what we can do is we can go ahead and create this variable len2 as nullable name dot length, but now we add a question mark here. Okay, so this line here is the same as this line over here. Now the problem of course is that our nullable name here is in fact null. So now I will get rid of this here, and as you can see now it's not null anymore. So we can even get rid of this whole line, but I'm just gonna comment it out. Okay, so this is a lot of work. You need to put in a lot of work. You need to write all of this code, right? Or you can just add a question mark to the nullable variable that you have here, and it does the same thing for you. So it says, okay, either it's going to work, and if it works, then give it the length. So if the nullable name is in fact not null, so if there is a value in there, like in our case, it's Dennis, then just store the result in len2, and otherwise store null in len2. All right, like here. Now you can go ahead and not only get properties of nullable variables, but also you can use methods on them. So in this case, I'm using the toLowerCase method on my nullable name, and if I run this, then what it will return, if it's empty, it will just return null. So otherwise it's going to return the name Dennis in my case. So there we are, it says Dennis, but let's say we make it null, so I uncomment this line here and I run it again, then, well, it's not even accepting it, so I can't even run the code. It's even not even printing it. So that's the thing about nullable variables and using the question mark here, which is the safe call operator. So now let's say we only want to do something or print something if the variable is in fact not null. What we can then do, we can use the safe call operator with let. So let me show you that real quick. So here I'm just going to use the nullable name again, then the question mark. So I need to use the save call operator, dot let, and then in curly brackets the code that I want to execute only if it's not null. So only if there is a value in there, I want to execute something. So this is a very short way of doing another if-else statement here. Okay, so let me run it again. And there we are. It says 5 because the length of my name is 5. So now let's say it's null. Let's test it. And there we are. There's nothing. So it says nothing. It didn't do anything because our nullable name in fact was null. Alright, so that's the first part of nullables. In the next video we are going to look at the else operator and the not null assertion operator. So yeah, let's just check those out, because then we have a rather full understanding of what those nullables do and how we can use them. So see you in the next video. Welcome back. In this video we are going to look at the else operator and the not null assertion operator. And in order to do so, I first of all start by commenting out a name here, because we used it and we saw how it works, right? But now what I want to do, I want to assign our nullable name to a non-nullable variable. So this value here should be a non-nullable, right? But I have a nullable variable here called nullable name, and I need to assign it to this variable. So sometimes you have this situation and you can't get around it. So what you can do is you can use the else operator in order to either assign the value that is within that nullable name variable. So let's say the variable has a name in there, and otherwise it's just going to have this default value. So you use question mark colon in order to say, okay, if nullable is empty, then please use my default value that I have here. Otherwise, use the value that is in the nullable name. So now if we print that name, we will see that it should say, in this case, Dennis, because the nullable name is in fact not null. So there we are, name is Dennis. But now let's say we make nullable name null and we run this again. Then we see name is guest. Okay, so if the value is null, then it's going to take the default value. So this one, this question mark colon here that we're using is the else operator. All right, the next thing that I want to use is the not null assertion operator, which is the double exclamation mark operator that converts a nullable type to a non-null type and throws a null pointer exception if the nullable type holds a null value. This is risky and you should only use it if you are 100% certain that there will be a value in the variable. So let's use it here. I'm going to say nullable name double exclamation mark dot to lowercase. Okay, so there's this method called to lowercase and it's going to put everything to a lowercase value. So instead of guest, it's going to say guest, for example. All right. So this here, in our case, will create a null pointer exception because we are really forcing it. And it's our own mistake because we didn't make sure that nullable name is in fact not null. So if you can see here, I'm getting a Kotlin null pointer exception in line 17. So in this line here. And this has to do with nullable name being null. So here you can see it is null at this line, so that's why we get this error. So now if it's not null, because it was assigned Dennis here, and we never changed it to null. So if it's not null, it's going to print Dennis in lowercase. And there we are, name is Dennis. So now if we print that, nullable name, and we get rid of this print statement that we had before. Now it should just print Dennis with a lowercase. So there we are, Dennis. All right, so now you have seen how null pointer exception works and how you can force one. You also have seen how nullables work in Kotlin, And there is one last thing that I want to show you, but it will not make sense to you now. It will make more sense once we get into objects and variables. But I just want to very quickly show you that you can use the save call operator in a chain. So here we are using a chain save call, so to speak. So let's say we have a class called user and we create an object of it. There is a wife, so the user can have a wife, which is also of a class or of a type. And then this wife has an age. So what we can do is we can use a chain save call here. For example, checking if the user is empty, and then also checking if the user's wife is empty. So if it's null or not. Okay, so if that's the case, then assign a value of 0. So as I said, this only makes sense once you understand the concept of object-oriented programming. But if you come from another programming language, that will make now sense already. But otherwise, I think it makes sense to go into object-oriented programming, which we will do in the next video. So the next thing that we're going to look at is actually classes and objects. And this is a little much for now, but I just wanted to show you this in order to complete this section or this lecture for nullables in Kotlin. All right, so I'd say let's go to the next video where we're going to check out object-oriented programming and how to create our own classes.
Okay, so we're done with the second chapter. Now you've seen the first fundamentals of the Kotlin programming language. And we of course have a bunch more fundamentals to learn, object-oriented programming, but on more advanced stuff as well. So in this chapter, what we have looked at are variables, so how we can store data. Then we saw that there are different data types that we need to be careful with. Then we looked at if statements and when statements, so code that will only be executed if a specific condition is met, and then also loops, so code that will be rerun multiple times depending on conditions and also on how many times you want it to run, or maybe even how many times it's supposed to run based on values that it has, based on its state. And then we looked at functions which allow us to sum up code to be reused. And this is super important and useful. And it will come in even more useful when we get back to object-oriented programming. All right, so then we also looked at nullables, so how to use variables which have a null value, which are pretty much empty, and what you need to consider when using them. All right, so that's it for this chapter. I hope you also ran through the exercises and you finished them. And yeah, let's get right into the next chapter where we're going to look at object-oriented programming. All right, so see you in the next chapter. Welcome back. In this chapter, we are going to look at object-oriented programming. So we're going to see the importance of object-oriented programming, why it is used, and then we're going to look into how to use it. So we're going to see how to use the different members, what members are. Then we're going to also see what inheritance is and why inheritance is so useful, because we can reuse quite a bit of code. We can extend functionality, and that is super powerful. Very useful when it comes to more complex applications, when it comes to in general working together with other programmers, or even using code that you can find online from third-party libraries. All right, so this is just the beginning of object-oriented programming. We're going to see what classes and objects are, how to use interfaces, what scope is, and we're also going to look at data classes and a lot more. So I hope you enjoyed this chapter, and then we're going to have one final chapter in which we're going to look at some more advanced Kotlin basics, so to speak, and then we can finally get back to developing Android apps. So then we can finally use all of the knowledge and get started with it. Okay, so just work yourself through it, and then we are going to build some cool apps. So see you in the next video.
Welcome back. In this chapter, you are going to learn the basics of Kotlin. But before we go into that, we will check out the basic concepts of any OOP language. And OOP here stands for Object-Oriented Programming. And there are multiple different languages which are OOP languages, such as Java, C#, and of course Kotlin. There are plenty others as well. So the 5 basic concepts are variables and types, control flows, functions, collections, and classes. And hereby also objects, which of course also includes inheritance. But generally, these are the 5 basic concepts, and you can find them in any object-oriented programming language. And we're going to cover those throughout this chapter. We're going to dig deeper into every single one of those concepts with many different examples. And first of all, we are going to look at variables. Now, what are variables? Well, a variable is a location in memory. So when you create a variable, it's stored on your computer somewhere. And in order to indicate the storage area, each variable should be given a unique name. So once you create a variable, you have to give it a unique name, which is also called identifier. And you can access the data behind that point in the memory by using this name. Now let's have a look at this. So we can see here fun main, which is the main function. Don't be confused by this. This is really just the entry point. If you create a Kotlin application or a Kotlin program, then you have an entry point of your program, and that is your main function. So this is just something that you will see every time when you create a Kotlin program. So we have fun main, and then we use this keyword called var, and then the name of the variable, which is called age in this case, and then we can assign a value. And in this case, I assigned the value of 15, and if I print that now, it will print 15. Println stands for print line, so it's just going to print a line where it says 15 because that's the value of the variable that I passed to this function called printLine. Again, don't be bothered by this. This is really just an overview video. We're going to dig deeper into this once we go into practice mode. Then we have control flows, and control flows allow us to do something conditionally, so only execute code if a certain condition is met, and do stuff repeatedly, so repeatedly run code as long as a condition is met. And this is very, very useful because there are multiple situations where you actually want to execute a certain code onto something multiple times. Here we have a quick example for a control flow. So we can see we have a variable again called age, and it's set as 17. And then the statement "you may vote now" will only be printed if the age is greater than 21 or equal 21. So this is the statement that we have here with the if keyword and then in brackets the condition. So if this condition is met, then execute the code, otherwise don't do it. And in this case, it will not execute the code because the age is not greater than 21 and it's not equal to 21. Then we have functions, and functions enable us to separate code and to run code blocks when needed. The cool thing is we can separate our code very easily with this, and we can keep our code very clean, and this helps us to reuse code a lot. So we don't have to type as much, which is great. So for example, we have again our main function, which is the entry point of our program, and then we call my function. Now what is my function? Well, my function is this function called my function that we created at the bottom here, which is just going to print a line which is going to say my function was called. So nothing too fancy, and don't worry if you don't understand everything here. I'm not going to go into details in this video. It's really just to give you a very short overview of what you're going to learn in this chapter. We will of course see what all of those brackets mean and how to name functions and how to call function and what calling functions even means and so forth. So this is really just a short example of a function. Then we have collections, and collections enable us to store multiple elements in one place and iterate through multiple elements with the help of control flows. So if you want to store multiple values at one place, so to speak, so let's say you have a school class with all of the pupils in there or students, and you want to store all of their names at one place, then you would use a collection. Then we have classes, and they allow us to create our own data types, keep the data members and methods together in one place, and this allows us to write more readable and maintainable code, which again helps us to work better in a team and to just keep working on our project, because the bigger the project gets, the more complicated code will get, and the more important it is that we keep things tidy and clean so that we still understand what we're doing. And a very important aspect of that is to use classes, and that's really the major idea of object-oriented programming, so that everything is a class to a certain degree. And we're going to see what that means in the future, because this is a very advanced concept, so to speak. So of course it's still the basics, but it's rather advanced in comparison to the other stuff. So I really only want to dig deeper into classes once you understood all of the other things that we talked about in this video. So classes are going to be the ending portion of this chapter. So I hope this gave you a little overview of what we're going to learn, and we're going to dig deeper into all of the topics now. So let's go to the next video where we start with variables. Welcome back. In this video, I would like to introduce you to classes and objects, and they are a very important aspect of object-oriented programming. We've seen classes before. For example, our main activity class is one of those classes, and a class is, so to say, a blueprint of an object. So let's have a look at a specific example. So let's say I have this very beautiful car here, and this car is gonna be our class that and this car has certain properties, so props, and those properties would be, for example, its maximum speed. Then it could be the amount of tires it has. So max speed, tires, then the amount of windows maybe even, or doors. So there are cars with 2 doors, there are cars with 3 doors, and so forth. So doors would be another property. And then this car has a bunch of skills. For example, it can drive. So I'm just going to call this one skills, and they will be drive. Then what can the car else do? Well, it can brake, hopefully, because otherwise we might be screwed. So it drives, it brakes, it has a bunch of other skills or capabilities. In a class, these properties could be variables, and those skills could be methods. So these are things that we have seen already. Now the only thing we need to do is we need to create our own class. So now, as I said, a class is a blueprint. So when I create a class, I create a blueprint for car objects. So now I can go ahead and create a car with a max speed of, let's say, 200 miles per hour. I can say this car is going to have 4 tires, and it's going to have 2 doors because it doesn't need any more. And it's going to have the skill of driving, and of course it's also going to have the skill of braking, but it's going to also have a turbo boost mode. Then it's going to have the steering capability and so forth. All right. And now, of course, this will be my object here. So this will be another car that I just created, this super fast turbo car that I've just created. And as I said, it just has this one big door here. Doesn't need more, right? Or one door on one side and one door on the other side. Now, the trick question here is, what is the front of this car? Is it here or is it there? Well, it doesn't really matter. I'm just joking. So that's one object, but now I can go ahead and create a bunch of these objects. So now I can go ahead and create a bunch of cars, and they all look a little different, and they all have different colors. So another property could be the color, for example. That's a good one. Wheel size could be another one, and so forth. So you can see you can have all of these different properties. And now this is the difference between classes and objects. A class is just a blueprint where we define all of these values, such as properties and skills. And then the objects are the individual cars that are produced, for example. And this can be used for pretty much anything, right? You could say a human. So what are the properties of humans? Well, we have a certain age, and that age changes. Then we have a name. We have eye colors, hair colors, and so forth. So all of these things would be our properties. And then we have skills such as breathe or sleep or walk, jump. All of these things would be our skills. And those skills would be our methods that we would create. All right, so this is just a quick introduction to classes, and we're going to see how we can use classes, how we can build our own classes, give them those properties and those skills or methods, and how we can create objects of those. All right, so I'd say let's dive right into it because it's a lot more fun in practice. So see you there. Welcome back. In this video we are going to look into classes. So let's go ahead and create our own class. And therefore we can have a quick look at classes that we have seen already. And we've seen this class called main activity, which has this app compat activity here, which just means that this is going to be the class that our class is inheriting from. So this is a concept called inheritance, which we will look at later on. But basically what we see is that we have this class keyword and then we have a class name which starts with a capital letter. So let's go ahead and create our own class, and I'm going to call this class person. So this by itself is valid code already. So we have this class person. And of course this class doesn't have any properties, it doesn't have any methods, none of that. But this is a valid class. Now of course we can extend that. We can go ahead and say that it should have a constructor. So a constructor allows us to add values to our objects when we create an object of our class. And these values could be something like the name, and let's just start with the first name here, and the last name. So we could just go ahead and have these two variables here as the variables of the constructor. So these are the parameters of the constructor, so to say. And then in curly brackets, that's where the class body starts, or where it is. So here it starts and that's where it ends. So in here we have our class body, and we can do all of the defining of our blueprint. So here we can go ahead and create all of the different properties and methods and those kind of things. So now this constructor here, as you've seen here, it wasn't even there. So there's no constructor there. And that is because it is not mandatory if we don't want to define the constructor specifically. So if we don't want to go ahead and make this one private, for example, or if we don't want to make this public or whatever. So we can just get rid of the constructor and make this code even easier to read. So we have class person, and then we have these two values that need to be passed once we create an object of our class person. So how do we create an object of a class, or how do we create an instance of a class? That's another way of saying it. Therefore, we just go ahead and use the name of our class. So in our case, person, and then in brackets, that's where we want to go ahead and add the two values here. So you can see first name and last name. So I could do something like Dennis Panyuta. All right, that's me. So I have this object of class person, which contains those two values, which are first name and last name. So if I now go ahead and create a variable called Dennis, it's going to be a variable of a type called person. So I could, of course, state that specifically here. I could say Dennis is going to be of type person, but as you know, Kotlin does the job for us because it understands, okay, if I create an object here after the equal sign of a specific class, then it will be of that class. So of that type, so to speak. So by creating a class, we created our own type. All right, such as we have seen in the past already. So we used a bunch of different types, and now we are using our own type. So instead of using ints and strings and those kind of things, we use our own type, which is called person. Whenever we create a class, we can also have an init there. So this is the initializer, which is called once an object is created. So as soon as we run this code, it will automatically run this initializer. So we can just go ahead and write something like person created. And now if we run this code, we will see that person created is printed to our console. All right, so this is the initializer, and you can use it in order to initialize your object, which pretty much means prepare your object. Another way of saying person created would be initialized a new person object. So that's another way what we could, or another thing that we could state here. So what we can also say is what person we created. So for example, that we create a person with a specific first and last name. So I'm just going to paste the code in here. So we say here, initialize a new person with first name, then we use the first name of our person, and last name, then we use the last name of our person. So you can see it's like us creating variables here when we use them in our constructor up there. All right, so if we run that, now we should see that the person that we created is Dennis Panyuta. So let me run it again. Initialize the new person object with first name Dennis and last name Panyuta. If you want to define default values for your first and last name, for example, you can do so as well. So for example, I'm going to use John Doe here as default values. So John Doe. And now if I go ahead and create a new object, and I'm just going to call this one John, then this will automatically be John Doe, this person, even though we didn't specifically say that this person should be called John Doe when creating this object. Okay, so when creating the instance of this class person. And here, this is because we defined those default values. So if we run this, we can see initialize the new person object with first name John, last name Doe. Let's say we only have the last name. So I'm just going to call this person John Peterson. Is going to be a new person. And here I just say that I want to define the last name as being Peterson. So if we run this now, then we will have 3 people that were created, or 3 instances of our class that were created. And the last one will have the last name Peterson and the first name John. So there we are, initialized a new person object with first name John and last name Peterson. All right, so this is just one example of how to create classes. There are multiple different ones that you can use. And in the next video, we are going to see how properties work and also how methods work. So how we can create functions within classes. So see you there. Before we go back to classes, I would like to talk about something called scope. And scope is an important concept that you need to understand in order for us to move forward with classes. So scope is the following. So let's say I'm creating a function here, and I'm going to call this one my function. And here I pass a value a, which is of type int. Okay, so if I now try to assign a value to my variable a, it doesn't work because it's not really a variable. This is a parameter. So you cannot assign a value to a parameter within the function. You can only pass an argument when calling the function. So here I can, for example, pass 5 as the a. All right. So you cannot reassign a value to it. Now, let's say I create a variable called a in here. What's happening here now? Well, this variable a is actually a variable. A is a variable. And now here, this a is a parameter. Now there are multiple things that we need to look at. One thing is that this variable a, as I said, is not the same as this parameter a. So what I can do is I can say var a is going to be a. So now this a here, our parameter, whatever value it has, will be passed to our variable called a, which is this variable here. And now we can go ahead and print it. So a is and a. Now, which of the a's will now be printed? Will it be the parameter or will it be the variable? Well, it will be the variable. We can see it if we just assign a value of 4 here, for example. So I'm going to assign a value of 4 to my a variable. And if I run it, you will see that a is 4, even though we passed 5 as the a to it. So there we are, it says a is 4. So now you might wonder why Kotlin allows to declare variable with the same name as a parameter inside the method. Well, somebody else had the same question, and here's an answer that was considered correct. This is called shadowing, and it is useful for decoupling your code from other parts of the system. It is possible because names are bound to the current scope. So here we see this keyword scope again. Now you can of course pause the video and read through all of this, but I personally like to go to the recommendations directly, which is number 1, your code becomes hard to read as 2 different things have the same name, which leads to confusion, which already happened. So I think it's already confusing what we have there. And another disadvantage is once shadowed, you can no longer access the original variable within a scope. So if we look back here, we have no way of accessing this variable anymore, except for if we actually assign it to our var a and then use it. But then we could have gotten rid of all this whole thing from the get-go. So this would work already, or even without this var a equals a. Okay, so this is just one part of scope. Another part of scope is the fact that, and I'm just going to create a different variable here. I'm going to call this one b. Our variable b that we create here, we can use it easily within our function, right? Because it's within scope. That's where it was created, so that's where we can use it. But we cannot use it outside of this function. So I cannot go ahead and say b is equal to 3, for example. This doesn't work because it doesn't find this b. Unresolved reference is what it says. Okay, so if I create a local variable in here called b, this variable b is going to be a very different variable than this variable b here. So they are all only visible within the scope of themselves, which is within the scope of their own function, or if it's within a class, then within the whole class. So if I create a variable b here and I want to use it in here, so let's say I want to assign variable b here and like this here, this is going to work because this variable is created outside of functions. So it's available within the same file. So in our case, within the same Kotlin file. So it's available for our main function, but also for our myFunction function. Okay, so this is the whole idea of scope, and I hope this will make things a lot clearer as we move on. Next, we're going to look at members of classes, and there are multiple different types of members. The simplest one are member variables. So member variable, let's call them properties alternatively. So you can either call them member variable or properties. What would be an example property for a person or a useful property? Well, there are plenty, but for example, age would be a very useful one. So let's say we have the age and it can be null. Okay, so why would I create a variable called age that can be null for a person? Well, the thing is that let's say we have the data of a bunch of people, so a bunch of users in our database, and for most of them we don't have the age. For some of them we do have the age, but we have for all of them the first name and the last name. So we want our program to run no matter if we have the age or not. It should still work. But if we have the age, then we maybe want to do something special. We either want to display it on the app or on the website, or we could even go so far and to say happy birthday or whatever if we don't have just the age but the actual birth date, for example. All right, so this is an example of a member variable, and we can have more of those. So let's say I have a hobby here as well, which I'm going to define as watch Netflix. So this is going to be the default value, and this is an example for member variables. Now let's have a look at member functions. So there is something called member functions. You can also call them methods. All right. And a member function is a function within a class, as a member variable is a variable within a class. Okay, so the member function that I'm going to create is just going to be a very simple one, which is going to state the hobby of someone. Okay, so the only thing that it should say is print line my hobby is, and then the hobby. All right, so now the cool thing is we can go ahead and do the following. So let's say Dennis.stateHobby. So let's see what will be printed onto our console. So there we are. Initialized a new person, object first name Dennis, last name Panuta, my hobby is Netflix, or is watch Netflix. Okay, so that is cool, but now the problem is the hobby is the same for everyone. So how can I change it? Well, you can change it the following way. You can go ahead and say Dennis.hobby should be something different, such as skateboard. All right, so maybe Dennis likes to skateboard. And then if we run this code again, we will see that now my hobby is skateboard. Maybe we should add something like to skateboard in here or something like that. But yeah, overall, the logic is the same. Okay, so what we now can do is, and that is pretty cool, we can have an individual hobby for every single person, because every single person already has something that is unique to them or individual to them. Unique is a little difficult to say because probably there are other John Does in the world, but what we can say now is that the hobby of John should be something else, such as play video games. All right, so John Doe likes to play video games, and now we can state his hobbies here as well. So I'm just gonna say John dot state hobbies. Now if we run this, then we will see that John's hobby is to play video games. So this is just an example for why object orientation is so powerful, or object-oriented programming, because we can now create blueprints, our classes, for our own data types or objects that we can then go ahead and use. So I create an object here, which is a variable. So a variable is an object if it is of a type, which is a class. Okay, so in Kotlin, pretty much everything is an object. Even the basic and generic data types such as ints and strings are classes, so to say. And you can see that when you enter the int keyword, you can see that this is a C, which means that this is a class. Okay. So we create our own data types here. We can change their properties, and we can use their methods, which we can define ourselves as well. So we can go ahead and create as many methods as we want. In the last video, we looked at scope. Why would we do that? Because we're not using scope here, and I said that we needed scope in here. Well, because we are using first name here, right? So in our init, in our initializer block, we use this variable name first name. And where does it come from? Well, it comes from our constructor here. So this is our primary constructor. And now, in order to understand that, we need to create another constructor. So what I'm going to do is I'm going to create a constructor here. And a constructor is also a member constructor. To be more precise, this is a secondary constructor. All right. So what I can do is I can now say what kind of variables I would like to have when somebody is creating an object of type person. We did that already here, but I can have a secondary constructor where I say want also to have the age. So whenever somebody creates an object of person, they can also pass in the age, and we will then use it. All right, so I can go ahead and say, okay, give me the first name, give me the last name, but also give me the age, which will be of type int. Now what we need to do here is we also need to add a colon and then this first name, last name, because we are using the two. Okay, so I'm just going to put that in the second line here. So this is our new constructor that we created, our secondary constructor. And now we can go ahead and say that our age that we have there should be the age that is passed to us. So I'm using this keyword here twice. So you might wonder, what is this? Well, this is a little easier to understand. So what I'm saying is that the age that is given to the constructor when the object is created should be assigned to the age of this class, which means that it's going to be this one here, this age that we created here at the top. So to the member variable or to the property, it should be assigned to the property. So that's what I'm saying with this. Okay. Now this here, it says that the first name and last name that we're using here in our secondary constructor should be the ones coming from our primary constructor. So they should be the first name that is passed here, John, and the second name that is passed here, which is last name. So what we can do now is we can go ahead and give some more information. So let's say I create a person which is called Dennis, and now I also pass the age. So I don't only pass the first name and last name, but I also pass in the age. So Dennis will now have an age. So if I go ahead and say Dennis.age is equal to 32, then the initial age that was set will be overwritten. So now if I want to print it, I can just do that, print Dennis.age. And maybe I should add a little more information. Dennis is Dennis.age old. And here we need to use brackets. Years old. So now let's run this again. And there we are. So we can see initialized a new person, last name Dennis Panuta, and then Dennis is 32 years old. And yeah, has a hobby of skateboarding. All right, so now the cool thing is we can write an own println statement when this other initializer is called. So here I'm just going to say initialize the new person object with first name, last name, and then and age. So let's run this again. So now it initialized the first constructor, so our primary constructor here, which was run by this initializer block, as we saw earlier. And then it ran the constructor, which is our secondary constructor, and added this and age here. All right. So now another thing about the first name. So let's say I want to extend my state hobby here. I want to say whose hobby it is. So here it just says my hobby, but we don't know who my is, because of course here we know that it's John, but that's because we programmed it. But what if we only see the output? So we will never know which person's hobby it is. All right. So in order to change that, I want to go ahead and finally come back to where I started with this whole thing. I want to use first name here. And I want to use it like this. Now the problem is this doesn't work. Why does it not work? Well, because the first name isn't a variable that is visible, because it's only visible within this primary constructor here. And it's also visible within our secondary constructor now that we have done that. So what I did with the age is what I can now do with the first name as well. So please go ahead and try that. Create a new variable. You can call it a little different just to avoid confusion, and then use it in your state hobby as well. All right, so I hope you tried it, and maybe the exercise wasn't 100% clear. I'm sorry for that. But the idea is that we're creating a new first name here, which should be of type string. And it couldn't be null, so it can be empty. And then we go ahead and in our init, so in our initializer, we assign to this first name, we assign the first name. So we do what we did here. So we take this first name and we store it within the member variable. So now we can go ahead and use it in our state hobby. So here I can go ahead and first name and I'm going to use a backslash apostrophe here and S, just to say, for example, Dennis's hobby is hobby. So let's run this again. And now we see Dennis's hobby is to skateboard. John's hobby is play video games. So now we have a lot more knowledge about which object we have manipulated and which object does what. All right, so I think this is enough for this video. Enough of different concepts that we're using. I told you that the class can have multiple members, and the ones that we saw are not the only ones. Classes can contain multiple members here, constructors and initializer blocks, functions, properties, nested and inner classes, and object declarations. And we're going to see what those different things are later on. But for now, just know that there are multiple members that a class can have. Welcome back. In this video, I would like to show you the functionality called late init, and then also how setters and getters work. So let's create a variable called owner, and it's going to be of type string. Now, if you create such a variable, as you can see, you always need to initialize it. And an alternative hereby is to use late init. What you say with this is that you will initialize it later on. So you don't want to initialize it in here, but you will initialize it later, for example, in the init function. But there is something that you have to be very careful about when you do something like that. Because if I now create an object of type car, so here var my car is going to be of type car, and now I want to access the owner, I'll get an error. To be more precise, you can see I'm getting a uninitialized property access exception. So that's because of this late init property owner has not been initialized. And that is of course because we use late init and we're trying to access something that is empty, but is not nullable, so we're not catching it. So what we will need to do is to use the init, so the initializer of our car, and in here we can set the owner to, for example, Frank. And now to be more precise, you can even say this.owner because we're talking about this property here. So if we run this again, then we will see there is no error. So it doesn't display anything because we don't have any print statements, but as you can see, it doesn't create an error anymore. So this is fine, this works. Only be careful that you don't use the variable before you have initialized it when you make it late init. All right, the next thing I would like to show you is, let's say we have a brand for a car. So it's going to be a val, my brand, and it's going to be of type string, and let's say I assign BMW to it. Okay. Now I'm going to create a custom getter. So I'm going to use get, and then I create a getter here, which will just return field.toLowerCase. So what that will do is, whenever somebody is trying to access my brand, so this variable here, what they will get is the lowercase version of BMW. So let's have a look at this. Let's actually use it here. So here, not the owner, but I want to have my brand. And let's, in this case, print it. Print line. Brand is, and then my car dot brand. Now you can see brand is BMW, and BMW is written in lowercase. Now what did we do here? Well, what we created is a custom getter. By default, let's say we have a variable called max speed. So this time it's not a val, it's a var. Var max speed is going to be of type int, and I'm gonna say it's going to be 250 kilometers per hour. And by default, what happens is that Kotlin creates the following code for us. So it says value field equals value. Okay, so this is the default that is generated in the background. So when we create this variable here, this code here is automatically generated. We don't need to write it ourselves. So we can just get rid of it, because as you saw, when we wanted to use something, or as we can see here, so let me print a line, max speed is, and then we use my car max speed. As you can see, we can access it. So we are getting the value. We could even go ahead and set the value to 200. But we would need to do that before. So let me do that real quick. My car dot max speed is going to be 200. So now we set it. This is where we set the value. And in this line, we get the value. So we are retrieving it. So there we are. Max speed is 200, even though it was 250 here by default. So bringing this back, this get and set, what you can do is you can customize it. And we did that with this getter here for our BMW. So we did it here. We created this custom getter, and we can do the same thing with the setters. So if anyone tries to set our maximum speed, we can check if the maximum speed is at least positive. So we could even run an error here. So we can say field, if value is greater 0, then use value. Otherwise, throw an illegal argument exception. And we're just gonna say max speed cannot be less than 0. All right. So what we have here is an if and else statement just in one line. But of course, you could do that in multiple lines. But basically what we're saying here is that if someone tries to set the maximum speed and they try to set it to a lower value than 0, then throw an illegal argument exception, which is just going to say max speed cannot be less than 0. Okay, as you can see here, this get field, this is not a custom field, so it just says redundant getter because we're just using the default getter here. So of course we could get rid of this whole line here. All right, so let's try it. Let's set the max speed to -5 just to get this error. So I'm running it, and as you can see, I'm getting an illegal argument exception. Max speed cannot be less than 0. So it's basically the text that I defined here for our illegal argument exception. What happens if we set the positive value here? Let's say 240. Then we see the max speed is 240. All right, so this is what you need to know about setters and getters. There's one more thing that I would like to show you though, and that is, for example, if you have a model. So I'm going to create another variable here, var my model is going to be of type string, and I'm going to assign m5 to it. Okay, so of course this would be redundant. We don't need that, but I'm just going to keep it there. So what I can do here is I can make the setter private. So we have seen this private keyword before, but we have not used it. What does private do? Well, private says that something is only available within the same class. Okay, so in this case, it will only be available within the car. So if I try to access my model and try to set it somewhere else, it's not going to work. So let's just try it. Let's go up there in our main function and go to my car and then try to set my model to something like M3. So as you can see, we're getting an error here. Cannot assign to my model. The setter is private in car. The getter, however, is not private. So if we want to print the car model, print ln model is, and then we use my car model. And here you can see I don't get an error here because the getter is not private. Only the setter is private. So what I did here is I said, okay, you can only change the value of my model within the same class. So for example, in our init. So here I could say this, my model is going to be an M3 instead. So this will work, and if I run this, I will be able to get my model, and it will now be an M3 instead of an M5. So there we are, model is M3. All right, one little thing that you might have questions around is what this field and this value are. Well, field is a backing field which helps you to refer to properties inside the getter and setter methods. This is required because if you use the property directly inside the getter or setter, then you'll run into a recursive call which will generate a stack overflow. So this is just a syntax that you need to use when it comes to fields. And value is the value that is given to the variable when you set it. So here for max speed, for example, this 240 is the value. So whatever is after the equal sign is going to be the value that is set. So you can do something like double check what the value is that is given to you, and then you can adjust accordingly. And then whatever is the result of this will be then set back to the field, which means just back to the variable itself. All right. So that's setters and getters and also late init. And in the next video, we're going to see a little more about object-oriented programming. So see you there. Welcome back. In this video, I would like to talk about a specific type of a class, which is a data class. So let's create a data class real quick. In order to create a data class, you can just go ahead and use the keyword data. And then you already see data class. So it's inside of the class here, Kotlin basics. That's at least how it's going to be called directly, but I want to call this one user. And in here, I have to at least add one parameter. And I'm going to add, for example, the ID, which is going to be a long ID, and a name, which is going to be a string. Now I can use this data class in order to create objects of it. So let's do that real quick here. User, and it's going to be a user1, or the ID is going to be 1, and the name is going to be Dennis. So that's already a user object. Of course, we can call this one user1 in order to be more precise. So that's how we create an object of a data class. Now, when creating data classes, there are things that you need to consider. So the primary constructor must have at least one parameter. So you can see if I get rid of that, then we get an error here because we don't have any parameter in there. But as I said, one is the minimum. Then you need to assign them either as var or val. So both is fine. And data classes cannot be abstract, open, sealed, or inner classes. So none of these things work. So you cannot go ahead and use open here in front of it. So as you can see, it's not going to accept that. In order to now access a property, we can simply go ahead and use it like this. We can just say user1.name, for example, and that will give us the name. In this case, it will give us Dennis. So we can, of course, check that, print line name. So let's check it. And there we are, it says Dennis. Okay, so that's how you can do it. Now let's say you want to assign a new value. So instead of having the ID 1, you want to assign the value 2. Well, the problem is that won't work because it's a val, right? So when you hover over it, val cannot be reassigned. And you shouldn't reassign an ID, but maybe you want to be able to reassign a name. So you want to change the name of a specific user, then you can of course do so and replace that with, for example, Michael. All right, so that's going to be now Michael user1 is not going to be Dennis anymore, but it's going to be Michael now. And then, of course, you can create new users anytime, and you can also compare them. So let's say we have user2. So we create a new user here. Val user2 is going to be a user object, which I give the ID of 1 and also the name of Michael. All right, because what I want to show you is that you can compare them. So you can go ahead and compare user1 equals user2. All right, so because every object is of type any at one point, so inherits from any, that's why we can use the equals function here, and alternatively, you can replace it with a double equal sign. So both versions are fine, and this will print true. We can of course test that and see if that's actually the case. And there you are, it says true. Because both have the same content, right? So in both cases, the user ID is 1 and the name is Michael. Okay, so of course here we can follow the instruction and just use a double equal sign, which will result in true as well. Data classes also have a toString method, so the same as other classes as well. So user details colon and then user. So just using this is gonna work totally fine because our data class has a toString method underlying it, because every class is inheriting any at one point, and that's why it's available in there as well. Another cool function is the copy function. So if you want to copy one object to another, you can do that easily. So let's say we have this updated user object, which will be of type user. And here I'm just saying, okay, I want to copy user1. So you can just go ahead and do it like this, or you can copy its contents except for the variables that you want to change. So let's say I want to change that name to Dennis Panyuta. So user1 will still be Michael, but now our updated user will be Dennis Panyuta. But we'll also have the ID of 1, even though IDs usually should be unique, but I think in this case it's gonna be fine. So let's print our updated user and let's see what we get there. And by the way, we should maybe also print our user1 just to see the difference between the two. All right, so there we are. It says Dennis from the top there, then we had true, this was this comparison that we had, and then user details, that's this one here where it says user ID1, name Michael, and then we have one user, which is our user1, which has the ID of 1 and the name of Michael, and the other user, which is our updated user, which has the same ID and a different name. Now in this case, it might be redundant. It might seem stupid to do that, but not all data classes are as basic as we have it here with just 2 variables or 2 parameters. Imagine a data class with, let's say, 7 different variables or parameters here. Then it's already a very different story, because then it might really make sense to just change one thing and then copy the rest. Okay, so let's look at our updated user. The updated user has an ID and a name. Now what we can do is we can get its components. So we can go ahead and get component number 1. So user1 dot, or in this case it was updated user dot component 1 will give us the first component, so to speak. This one will print ID1, and then print line updated user component 2 will print Dennis Panyuta. Okay, so this is the feature that you can use. Another cool thing is that we can use deconstruction. So let's look at deconstruction. So I have this ID and the name variable. So I have these 2 variables that I want to make dependent on our updated user. So what will happen now is that is going to take the ID and the name from updated user, and it's going to store them in separate variables. So it's the same thing as going ahead and saying ID is equal to updated user dot ID, and while here name is updated user dot name. Now of course in our case it's complaining because name already existed up here. So let's get rid of this. And now we can use this functionality. So now we can go ahead and create variables out of the different attributes that are within an object. And now we can of course go ahead and print those. So ID is going to be ID and name is going to be name. All right, so this will print ID is 1 and name is going to be Dennis Panyuta. So let's test that. And there we are. So it says ID is 1 and name is Dennis Panyuta. All right, so this was just a little introduction into data classes, and we're going to use data classes because they're just very powerful, very basic classes which are very limited in their functionality, but that is exactly what we need sometimes. We just don't want to have all of this overhead and all of this additional code, and we just want to have a clean and simple object type, and therefore data classes are amazing. All right, so see you in the next video. Welcome back. In this video I would like to cover inheritance, and inheritance is one of the main concepts of object-oriented programming, and it allows a class to inherit features such as properties and methods from another class and reuse them. So the structure is the following: you have a subclass and then you have a superclass. Alternatively, you can call the subclass child class or derived class, and the superclass can be called parent class or base class. Now let's have a look at those in action. So let's create a new class called vehicle. Now this class might have some properties and some methods. Okay, and now we can go ahead and take this class and inherit from it. So this means that we will take its properties and methods and we will make them reusable. So let's go ahead and create a new class called car, which is of type vehicle, or which inherits from vehicle. If you do that, you need to make this class open. So vehicle needs to be an open class, otherwise I cannot use inheritance here. And that is because all classes in Kotlin are final by default, which means they are non-inheritable by default. So you need to use the open keyword to make a class inheritable. And that's what we're doing here. So we're using open class vehicle. Now let's say I want to have another class which inherits from car. So class electric car that should inherit from car. Now the problem is car is not open, so I would need to make it open as well. All right, so if you want to make sure that a class cannot be inherited, you can use the sealed keyword, then this would not work. So you cannot inherit from a sealed class. And you can even see that convert sealed subclass to an object. And I'm just gonna get rid of that because I want to make it open so that we can reuse it. Now, this here, our vehicle is the superclass or parent class or base class. So you can use either of those terms. Each of them is fine. Now this here, our car, is the subclass of the vehicle class. And of course, it's also not just the subclass, but also the child or derived class. Okay, so it's just different terms, but whenever you come across those terms, you should know what they are, right? And then at the same time, our car is the superclass, parent class, base class of vehicle. And of course, in that case, the electric car is the subclass or child class or derived class of the car class. Okay, so let's get rid of vehicle now because I want to only work with car and electric car for now. So let's say we have some properties in here, and let's also say that our car has a primary constructor. So we want to have some more values in here. Val name will be a string. Val brand will also be a string. So this car has a name and a brand. And then here, electric car, suddenly we have an error here. So we need to add a constructor parameter name. As you can see here, name is now required and something else is missing. The constructor parameter brand is missing. So you can see this is how Kotlin expects it. So you need then to use the same parameters that were used for the car for your electric car as well. So this is the constructor that we're using here, the primary constructor. Now, of course, the electric car can be extended, so you can add more features to it. It has to have at least the features of the class that it inherits from, but it can extend features. So it can have additional features such as, for example, battery life. So an electric car would have battery life, which is of type, let's say, double. So that is the base structure when working with constructors, so with primary constructors. Now let's say we have a range in here in our car. So let's create this class car first. Here range is going to be of type double, and it's going to have a value of 0.0, just as an example here. Then it has a function in here, fun extend range, which will be the amount, which will be of type double. And if the amount is positive, so greater 0, then I want to increase the range by the amount. Okay, so if we go to the fuel station and we fuel up our car, then the range will be extended. So we extend the range. And then finally, I want to have another function here, fun drive. So distance should be double, and I will just print here drove for distance, kilometers. Okay, now I have this class car, and of course our electric car inherits from it. So that means that if we now go ahead and create a fun main, so our main function, and in here I create an object of car, so var my car is of type car. Now of course I need to add a string, so I'm going to give it a name, for example A3, which is of the brand Audi. And then I create a electric car, so my e-car, so I'm going to call it, is going to be an electric car. And here it's going to be Tesla S, or maybe S, model of type Tesla. And then it of course needs also to have a battery life, so I'm going to give it 85.0, which means 85 kilowatt hours. All right, and the cool thing now is, let's go ahead and use my car dot drive, and we will see that it needs a distance. So let's say drive for 200 kilometers. And here, of course, it needs a double, so 200.2. And now let's do the same thing with my eCar dot drive and use also 200 kilometers. All right, so if we run that now, you can see it doesn't complain, even though there is no drive method inside of my electric car. There's actually nothing in my electric car class. It's using nothing. The only thing it does is it inherits from the car class. So let's run it and test what the result will be. And we can see that it says drove for 200 kilometers and drove for 200 kilometers. So in both cases, it drove for 200 kilometers, even though electric car never implemented a function called drive. All right, but it can still use it because it extends the functionality of its parent class. So it has all of the features of its parent class. It has also this feature called extend. So we can also go ahead, maybe we should rename those. So this is going to be this Tesla S and Audi A3. And let's reuse those names because I think it's more telling to use those names. Now you can see that our Tesla can drive for 200, but our Audi can also drive for 200. Now let's extend our duration or the range of our Tesla S. So Tesla S dot, you can see it has extend range, it has name, range, brand, to string, all of those. So it has several functions which we have never created. For example, hash code, equals, and to string. And these are the ones that are always available. These are always available. Why are they always available? Because any class inherits from the any class. So I say it again, any class inherits from the any class. So there's a class called any, and we can use this type any as we've seen before. So for example, I can create an object, var object 1 is of type any. Okay, so any is a class in Kotlin. Let's see it. It's an open class. the root of Kotlin class hierarchy. Every Kotlin class has any as a superclass. And that's why we can always use the function or the method equals, hashcode, and toString. And we can override them as well. We can create our own types of those. But now let's go back and use the extend range here. So let's extend the range by 200. So now we extended the potential distance that our Tesla S can drive by 200 kilometers. And that is because we have this fun extend range in our car class. Now let's go ahead and let's say we want to override the range functionality and we want to override the drive functionality. So what we can do in our class electric car, we can just go ahead and say override var range is battery life multiplied with 6. So let's say we have 85 watt hours and we can drive something around 510 kilometers or so with this range. So it's more or less realistic. I think maybe it's just 5, but something around that, 5 or 6 times the battery life in kilowatt hours is what a Tesla can drive. So now we are overriding the range property. Now, of course, it's complaining. It says, okay, you cannot override range because the range is not open. So you can make a property open as well. So here we can use open for this property called range. We can use the same feature for a function. So now we made this drive function open as well. So now we can go ahead and override that functionality. So we can say, for example, in our electric car that we drove, so override fun drive, and we say we drove a certain distance, but we also print line say something like drove distance on electricity. But that by itself wouldn't be as interesting as doing the following. So we can confuse the whole thing. Let's go ahead and say drive, and now we just print something like drove range kilometers on electricity. So now what we have is we have a drive function which we override from our parent class, and we have a drive function which we created inside of our inheritance, which we created inside of our subclass. This might not always be a good idea because it might end up being confusing, but in the end, now you can go ahead and say Tesla S.drive, and you can see you have two options here. So you can either drive or you can drive a distance. So let's say we drive. So before we used the distance feature, and now we just drive because we want to know how far a Tesla can drive. And if we run that again, then we should be able to see the maximum range of our Tesla S. And we can see that we get 710 kilometers on electricity here. So we have created an overriding function. So we are overriding the functionality of our superclass. So we change whatever was written in here, and then we create another function which is now specific to our electric car, which has the same name, but it uses different features. Of course, we can have a bunch of other variables in here as well. So we cannot just have the variables that are used in our superclass here for the electric car, but we can also have a charger type. For example, let's say different electric cars have different charger types or something like that. And we can say, okay, this car has a charger type of 1. And if you want to change that, we can of course do so for every single Tesla S dot charger type, and let's say it has a type 2 charger. All right, and there's one thing that I should say, that what we're doing here with these two, so let me put that a little further down. What we're doing here is called polymorphism. At least that's part of polymorphism. Polymorphism is the ability to treat objects with similar traits in a common way, which we are doing right here, because a Tesla has common traits because it's inheriting, or it's of type electric car, and it's inheriting from car. And this of course only works because electric car is a subclass of car that would alternatively also work if it was a subclass of car which was an interface. Okay, so if car was an interface, that would work as well. But what interfaces are is something that we're going to look at in another lecture. All right, so that was a little introduction into inheritance, and let's see some more examples of that, for example, with interfaces in the next video. Welcome back. In this video, we are going to look into interfaces, and interfaces are a feature which allow us to extend the functionality of classes. So for example, our car class could extend the functionality of an interface that has certain features, and let's go ahead and just create such an interface. So I have this interface prepared here, which is called drivable. It has one value, which is a double value called max speed. Then it has a function called drive of type string, so it's going to return a string, but there is no implementation of the function, so it just doesn't have a function body. It only has the head of the function. And then we have a break function which actually has a function body as well. So an interface may provide a default implementation of some or all of its properties and functions, but it doesn't have to. And if a property or function has a default implementation, the class that uses this interface may choose to override it. What does that mean? Well, let's say we have this interface drivable, right? In there we have these functions and this property. Now, if our class car decides to extend the functionality of the drivable interface, then it needs to implement the property that is created in the interface but is not implemented. So here we need to go ahead and say val max speed of type double should be in there. And because we are overriding something, so we are overriding the max speed from here, we need to add the keyword override. That by itself doesn't make our class happy yet, as you can see. It's still not happy, it's still complaining, something is still missing. And that is because we haven't implemented the member called drive. So here's this drive function, and because it doesn't have a function body, we need to create one in the class that extends the interface. So we need to go ahead and create a drive function. So you can see we are already creating a drive function. Why is it still complaining? Well, this drive function doesn't follow the same structure. So you can see the head of the function doesn't return a string. So let's go ahead and actually do that. So override fun drive, and once again fun drive, and you can see it gives me some help here, the IDE, but it requires me to implement something. So I need to add a return statement here. So I can of course go ahead and return driving the interface drive. Okay, so that's just going to be the text that I return. Alternatively, what you could have done is you could have done it in a shorter way. For example, just saying that it's going to return whatever the string is. Okay, so both of them are fine. You can see this version is also fine. It's just a shorter version of this here. All right, so now we have multiple drive functions, and that is already starting to become confusing maybe, but no worries. The one drive that we have here is actually the drive that comes from our interface that we are extending. Okay, so you can see here this drive, we implemented it, and suddenly our car is not complaining anymore. Then going back to our other drive that we have created, it's an open function drive, which is, so to speak, new. So this is the lowest level in which it's defined, and that is in our class car. So this is another drive, which we of course can override from other classes that inherit our car. Now, if electric car wants to inherit from car, it also has to follow the structure of our interface here. So let's also add a max speed here, and let's use it here as well. Now, of course, our function drive that we had in our electric car that we created doesn't work anymore, because now this drive is trying to override. So it thinks that we're trying to override the drive function, which comes from here, this one. Okay, so we also need to follow the structure of drive. Now let's add the override keyword, but then we also need to return the string type. And of course here, return, and we can use the same structure that we had before, or at least the same string that we are returning here. So what is an interface? Well, an interface is essentially a contract that a class may choose to sign. If it does, the class is obliged to provide implementations of the properties and functions of the interface. Okay, so we see that here because our class car is extending the interface drivable. It's now obliged to implement its variables and functions, or its properties and functions. The properties, we did that by using it in the primary constructor, and the function, well, we implemented it directly here. You can also see, because our break had already an implementation, we never had to use it. But we can of course use it. We can even use it in the subclass here. So in the subclass of our car, in the electric car, we can still go ahead and implement break. So you can see override break, and here you can see the super keyword. And that is to call the break function of the superclass. And because our superclass, which is our car, didn't implement the functionality for break, it will use the one from the interface. So it will just use this break here. So now, if I go ahead and call break, and by the way, now of course we are missing things when creating those Audi A3 and so forth, and I think it was max speed, right? So 200 kilometers, it says the top speed here, and 240 is going to be the top speed of the electric car, and now the arrows disappear. But now, which drive will be called when we call this drive? Well, if we look at it, one requires a distance, the other one doesn't. So it's going to call this drive. And then this here is, of course, going to require the distance, so it's going to call this drive here. All right, now let's say we want to call the break function here. All right, let's just test it. Let's go ahead and use Tesla s.break, and let's use Audi a3.break, and here of course it's break. So I'm going to get rid of the other calls here just to keep it simple, and let's actually run it here. And we will see that it says the drivable is breaking in both cases. So the case for Tesla and Audi A3, even though our Audi A3, which is of type car, never actually implemented this break function. Okay, so it has it because it automatically inherits it from break. Now, what if we implement something here? Let's say print line break inside of the electric car. Let's test it again. So you can see the drivable is braking, and that is our Tesla. And then it says brake inside of electric car is also our Tesla. And then we have this drivable is braking, that's our Audi that brakes. So what is happening? Well, when using override fun break, super break, what happens is that the super function break, so whatever was implemented for break in the interface or in the super class, will be used or will be executed. And then on top of that, our own code that we add afterwards will also be executed. Okay, so that is what this super dot method name does. By the way, subclasses of a class that implement an interface, in this case our electric car, are also considered to be implementing the interface. Okay, I said it in a certain way, but I never said it specifically like that. Okay, so just so you know, our electric car is also implementing the interface called drivable. Another side note, an interface can inherit from another interface. So yeah, in case you want to create your own interfaces that inherit from other interfaces, you can do so. So why would you even use interfaces? Well, interfaces are super useful when you have certain functions in mind that you definitely want to be implemented later on, and also already know the properties of a class that you want to then have implemented, but you don't want to implement them directly. You just want to prepare everything, and you don't want to, for example, create a specific body already for a function. All right, so this is the introduction to interfaces, and in the next video we are going to look at abstract classes, which are similar in a certain way to interfaces, but they have some differences in the nuances as well. So let's have a look at those. Welcome back. In this video, we are going to cover abstract classes. And abstract classes are a little bit similar to interfaces, but they are still different. So let's look at them. An abstract class cannot be instantiated. That's the same for interfaces. You cannot create an object of an interface. However, you can inherit subclasses from an abstract class. And the members, so properties and the methods of an abstract class, are non-abstract unless you explicitly use the abstract keyword to make them abstract. So let's have a look at an example here. So I have this abstract class memo here, which has a constructor here, a primary constructor with a name, an origin, and a weight. And these are concrete, non-abstract properties. All right, so the three that we created here, name, origin, and weight, they are non-abstract. But this one here is. So I create a property called max speed, which is abstract. So it must be overridden by its subclass. So if a class inherits from memo, then it will need to implement those. So it needs to override those. The same goes for these methods. You can see we can create methods without a body. So we just add the abstract keyword, abstract fun, and make run an abstract function. The same goes for a breathe here. And then we can also create concrete, so non-abstract methods in such an abstract class. So we're not limited to abstract methods. We can also just create a method such as display details that we have here, which will just display the name, origin, weight, and speed of the mammal that we're creating. So now let's look at this class that inherits from mammal. It has also the origin, the weight, and the max speed. It has also the name, the origin, the weight, but it also overrides the max speed. So this abstract property that we created here. So now our human class will override that. Then we also override the run function. So we implement the run function with our own code for our human. We do the same for breathe. And then we have another class called elephant, which does the same thing. So it overrides the max speed and it implements its own code for run and its own code for breathe. Of course, they could both have a bunch of more functions and a bunch more properties, but I'm going to keep it super simple in this example. All right, and now we can go to our function main, where we create an object of human, which is called Dennis, was born in Russia, has a weight of 70 kilos and a max speed of 28 kilometers per hour, even though I'm not sure whether that is true. So then we have the elephant, which is called Rosie. It's from India. It weighs 5,400 kilos and it has a max speed of 25 kilometers per hour. So as it seems, I could outrun Rosie, but depends on how long I can do that. So then if we call human run, it's gonna execute the run functionality for the human. It says runs on 2 legs. And if we call the same for the elephant, it will say runs on 4 legs. So let's just test that. By the way, we can also see that we are breathing. So the human calls breathe and the elephant calls breathe. So there we are. We see it says runs on 2 legs, runs on 4 legs, breathe through mouth or nose, breathe through the trunk. So I'm not saying breathes here because it just needs to breathe. So I force it to breathe. All right. Grammatically still correct. All right. And that is already the major part about abstract. And let's have a try to create a mammal here. Mammal. And I'm gonna say Dennis is a mammal. So here, Dennis, Russia, then weight of 70.7, and finally a speed of 28.0. So trying to do that, you can see, cannot create an instance of an abstract class. So you cannot do that. You can, however, of course, do that with classes that inherited from it. So our human and our elephant, which are both classes that inherit from our abstract class called mammal. All right, so what is the difference between an abstract class and an interface? Because you might say, all right, they must be pretty much the same, right? Or they're very similar to each other. Well, the thing is that an interface cannot hold state, and we can implement multiple interfaces, but only one class. So when implementing an interface, as we have done in the last example here, where we implemented drivable, we could implement multiple interfaces here. We're not limited to just one interface, but we can only inherit from one class. Also, classes have constructors, so even an abstract class has a constructor. You can see that our interface doesn't have a constructor here. And interfaces cannot hold fields. So basically, abstract classes can have everything that interfaces can, and additionally they can have fields and constructors. Therefore, we can properly hold state in an abstract class. All right, so in the next video, we are going to check out typecasting. So see you there. Welcome back. In this video, I would like to talk about typecasting and very quickly look at lists. So I have this function main here and this typecasting file in which I create a new variable called string list, and it is a list of strings. So that is the syntax that you can use. And when you want to create a list, then you can use list of, for example. So I'm creating a list of Dennis, Frank, Michael, and Gary. So this is a list which can only contain strings. But you can also create a list which has a mixed types. For example, using the any keyword here. We say that we accept any type of object in our list. So here we can use strings, then we can use integers, but also doubles and any other data type that is available. So let's look at this for loop here. We have value in mixed type list. So what we do is we go through this mixed type list with this for loop. And for every single value in that mixed type list, we want to run this if else block. So we check if the value is of type integer. So we use this is keyword here. Is it an int? If it's an int, then please print integer and then the value. Otherwise, if it's of type double, please write double, then the value with the floor value. So we floor the value to its next lower full number. And otherwise, if it is a string, then please write the string and also write the length of the string. So just write this print statement. And in any other case, so in this else block, I just say it's an unknown type. So I have no idea of what type it is. All right. So this is a for loop. Alternatively, we could have done it with this for loop here, where instead of using if and else if, we use when. And it works pretty much the same way, only the syntax is different. So you can see we use when, the value, and then in brackets, we say is integer, then execute this code. So what we have here is a bunch of lambda expressions. And you can also see once you hover over this if statement that it wants you to use when instead. So it's pretty much doing the same thing as we have done here in this alternative way. So both ways are fine, but Kotlin prefers this when approach. Now let's look at smart casts. A smart cast is what you can see here. So I'm creating this value, which I call object1. It's a variable which is of type any, and it says I have a dream. All right, so I store a string in there. Then I check, is object1 a string? And I'm using this exclamation mark here. So this means, is it not a string? So is object1 not a string? Then I'm gonna say println not a string. Otherwise, I know that it's a string, so object is automatically cast to a string in this scope. So I'm saying found a string of length object.length. So it already knows, okay, because it is a string, we can use its string functionality, such as getting the length of the variable. Then there is something called explicit unsafe casting using the as keyword. This can go wrong, by the way. So we have this other variable called str1, which is of type string. And what it tries to do is it tries to use object1 as a string. So this will only work if object1 is in fact a string. If not, then this will go wrong. So what we're doing is we're using it as a string, we're storing it in str1, and then we print the length. Then we have this other object here, which is of type any again, and we're storing this time an integer in there. And what we're trying is val string object as string. So what we're trying to do is to make a string out of this object too. And then we're printing it. As I said, this is unsafe casting. This can go wrong. And then we can also use explicit safe casting using the as question mark keyword. So here, object3, any, again, the same value. And in this case, we say, okay, it's a string nullable, and object3 as a string. So does it work or does it not work? Well, in this case, it will work. So if we use that, it will print null. What will happen here? Well, let's find out. We can just run the code and see. So I'm getting an error here. Exception in main thread. Typecast KT47. So in this line here, where I'm saying object2 as string, why does it go wrong? Well, because object2 is of type any, and what is behind it is not a string. It's an integer. That's why this call doesn't work. If I, for example, would go ahead and add a question mark here, well, now it's not working because the string is not a nullable string. So I would have to make this also a nullable string, and suddenly it would work. But that's exactly what we did in this case down here. All right. So let's get rid of this line here because it doesn't add any value. And let's run it again. And there we are. So now things work. Let's start from the top. We say here at the very top, string Dennis of length 5. Okay, so we had this mixed type list. So we go through every single element. Then the next element is an integer 31. Then it's an integer 5, a string bday with the length of 4, then a double 70.5 with the floor value of 70, and then string weighs of length 6, string kilogram of length 2. And then again the same with this second for loop, so exactly the same stuff. And then we are at this point here where we smart cast. So it says found a string of length 14. And that is this else block, because we are saying here that I have a dream is not a string. So we go into this else block and we print this statement out here. Then we have this statement where it says object as a string and its length is 14. So object 1, what is object 1? Well, it's I have a dream. So of course its length will be 14. And then finally we have null. And where does this null come from? Well, it comes from here, where we are trying to save casts and we use nullables. So our str3 is a nullable, so it can be null. And we're trying to cast when we are not sure whether it's going to work or not. And in this case, we were wise to do so, because otherwise we would have created an error, as we have done in the example with object 2. All right, so this is a little introduction to typecasting. Thanks a lot for your attention.
All right, so now we're done with the object-oriented programming chapter. In this chapter, you have seen what object-oriented programming is, how classes and objects work, how to create objects of classes, how to create instances pretty much of classes, then what members of classes are. Then we have seen how to use interfaces, how to use inheritance, how to also use data classes, and what scope is. All right, so these are going to be very important fundamentals that you will need throughout the next chapter. So we are going to use all of them at one point or at many points, depending on which specific topic we're looking at. And many of the things that we have learned are going to happen in the background. So many of the functionality that we have seen is actually used already quite a bit by Android itself, or better said, by the different classes that there are already when it comes to Android development. And we are using quite some of them. So we're constantly already using inheritance because we are using the app compat activity in our main activity. So we're inheriting from it. Okay. And you will recognize more and more of those things once we get to developing more complex applications. Okay. So thanks a lot for being with me. And let's get to the next chapter. See you there. Welcome back. In this chapter, we are going to look at the Kotlin fundamentals part 3, so to speak. So we are going to start with array lists. Then we're going to look at lambda expressions. Then we're going to see how the visibility modifiers work, because we have used them already quite a bit, but we haven't really looked into them. So we haven't really touched them too much. And that's what we will look at in this chapter. Then we are also going to see how to use nested and inner classes, because we've seen how classes work and how object-oriented programming works, but there is a thing called nested and inner class, and we're going to see how to use that. Then we're going to see how to use the save and unsafe cast operator, and then finally we're going to look into exception handling. So what should happen if we get an error, or what can we do in order to catch the error and not make our application suffer by that error. All right, so it often really depends on what kind of error we have, but many errors we can just catch them, we can just do something else, or we can just not do anything, and it will at least not crash the application, even though the application might not exactly do what we wanted it to do. But at least it's not going to be suffering in terms of crashing. And when that happens and a user has your application and it crashes, he might accept it once, but he's not going to accept it multiple times. So that's why it's super important to look into that topic as well. Okay, so let's get started with this chapter in the next video. So see you there.
Welcome back. In the next couple of videos, we are going to look at collections. And collections are simply a group of the same type of data or different type of data. So in Kotlin, there are two categories of collections: classes that can only hold one type of element of a particular data type, and then classes that can hold both one type of element or a different type of element. So each data type in Kotlin has a class for holding its element. Int array is specifically for holding integers. Boolean array is used for holding true or false values. Double array is used for holding double types. Then we have byte array for holding byte values, and accordingly then long and short array. While float array is specifically for holding float. So now you must be asking, what about a string, for example? Well, there we have the array of, which is a class that can hold all previously mentioned types, including strings and custom types, or even classes, and can even hold different types together. So there are other classes like list or list of, then we have set or set of, and finally we have map and map of, where a key is connected to a value. So these classes are not mutable, which means you can only read the values but cannot write to it. List is similar to an array of, but with more helper methods for performing operations on its values, and the size can be easily increased when needed. Set is a class that ensures there are no duplicate values in a group, and map is arranged as a key value pair where each value has a key you can use to identify it. So here, for example, the key 1 could be associated to Sunday, key 2 for Monday, and so forth. There are special classes for both reading and writing into list, set, and map collections. This way you can easily separate elements that need to be publicly modifiable from those that need to be private. Alright, so now let's write some code and see how to use all of those different list and collection types. Welcome back. In this video we are going to look at arrays, and arrays, as we saw earlier, allow us to store multiple pieces of data in one variable, so to speak. So let's create our first array for the integer type and also see the different ways we can create an array. So first of all, I'm going to use the keyword val, and I'm going to call this variable numbers, and it will be of type int array. Okay, so using int array, and then I need to use this method called int array of, where I can then assign values. So int values and multiple ones. So var arg elements of type int, which means I can just go ahead and just add a couple of numbers separated with a comma. So I have these values here, 1 to 6. So that's one way of creating it. But then because of type inference, we can just go ahead and use a simpler approach where we can get rid of this int array here entirely. So let me copy that, and here we can get rid of this part. Therefore I need to comment this out. So because we are using int array of, numbers knows that it should be an array of integers. So that's type inference here. We don't need to specifically state that it's going to be of type int array. So by the way, there is an even simpler way of doing it. So another way of using type inference, and I'm going to again copy the line of code, comment the other way out, and by the way, all of them are valid, right? These are just more descriptive, so they are really showing to the point what's going on here. And then we have this one where we don't even need to say that it's an int array, we just say that it's an array of. So now let's go ahead and print an array. We can just go ahead and say print numbers, and let's run this real quick. Then we will see that it just prints this information for us. So we would have expected to get the numbers here, right? But what we're getting is actually this here. So we are getting the address of the array, which is where it is stored in memory. This is because we cannot just print arrays with the print method. We will need to use a utility method provided in Kotlin for that purpose. So what we can do is we can use numbers, and that's a cool thing of the array of here. So this is an array now, and we can just go ahead and use a method called content to string. So what that will do is it will transfer the content into a string, convert it for us, and then we can now display the numbers. And you can see now it just says, okay, this is an array, and that's why we have those squared brackets here, 1, 2, 3, 4, 5, 6. Okay, so now we can see the values in the right format. So now let's traverse through an array, meaning go through the items of the array and print them individually. So that would be a different approach. Let's look at it. And I'm going to simplify the code here. And the easiest way to do it is to use a for loop, where I'm just going to say an element inside of numbers. And this element is just a variable name. You could have called it I or whatever you wanted. And I'm just going to say the element in numbers is what I want to print. So let's print element here. So what's happening now is that it goes through this numbers array, and for every single item starting from the first, it will store that in element in the first iteration. In the second iteration, it will store the 2 in element. In the third iteration, it will store the 3 in element, and so forth. So it's going to go through all the numbers inside of this numbers array, and we'll store them in element and then print them out, and then go to the next number, print it out, go to the next number, and so forth. So here we're just printing, but you could do whatever you wanted to with that particular element. You could modify it and store it somewhere else. You could display it, and so forth. So we're just going to display it on the console using a print statement. You can see 1, 2, 3, 4, 5, and 6. So all the numbers that are inside of numbers are now being displayed. So now let's actually do a modification here. So I'm just going to go ahead and add an empty space here and add 2 to it. So here +2, for example. Now if I run that, I will see that it will just display 1 + 2, 2 + 2, and so forth. It's not doing the actual calculation. Do you recall how to actually do the calculation here when we were using string manipulation here? Well, we need to add the curly brackets around it. So let's run it again. And now it will add the number to the element. But that by itself will not change the numbers itself. Okay, so if we were to now do the same thing once again after that, and we print out numbers without adding the 2 to it, therefore we don't need to have those brackets. Let's run this code, and you will see that our numbers are not actually impacted. So 3, 4, 5, 6, 7, 8, but the actual numbers are still 1, 2, 3, 4, 5. So we didn't change the value itself, we just displayed it. So we didn't override it. So now let's modify a value in the array. And since arrays are indexed based on starts counting from 0, it means the position of 1 in our array is going to be 0, the index of 2 or the position of 2 will be 1, and so forth. It's a little confusing, but let's look at it in order to understand it a little better. So I'm going to get rid of this for loop here. I'm going to print numbers, and now if I want to access a particular item inside of the numbers array, I just need to use the squared brackets here. So if I, for example, want to access index 0, this will give me 1. Let's test this. And you will see that it displays 1 in fact, because it starts at index 0, but the first entry that we have is 1 at this position. So now let's use index 3, for example, and that will give us the 4. Let's run it again. And here you see 4. So this has nothing to do with the actual numbers that are in here. It just has to do with the position that we're looking at. So the index of that array. So here, let's say I'm entering 5 and I get the number at position 0. Now it will give me the 5 instead of the 1, because that's what is stored at position 0. Okay, let me go back to 1 here. So now let's modify our arrays a little bit. So now let's modify the array a little bit. I want to store a different value at position 0, for example. In order to achieve that, I just use the name of the variable, which is numbers. Then I use the squared brackets with the index, which I want to change. And then I assign the value that I want to assign. So in this case, let's say at position 0, I want to use the number 6. And at position 1, I want to use the number 5. And then for index 4, I'm going to use the number 2. And finally, for index 5, I'm going to use the 1. Okay, so let's now look at what happened. So first of all, I'm going to print the initial value of my numbers, and I'm going to call this one initial values, and then use the squared or the $sign with the rounded brackets surrounding it, like so. And then I'm going to print it with the changed values. So with a new line, by the way, therefore I'm using the \n, and then I'm going to call it final values. Okay, so let's run this and see how this has impacted our array here. can see initial values were 1, 2, 3, 4, 5, 6, and the final values were 6, 5, 3, 4, 2, 1. So now, since arrays have a fixed size, we cannot increase the size or try to add a new index. Since we have 6 values and the index starts from 0 to 5, if we try to add something to numbers at the index 7, for example, this would not work. So we can get into a out of bounds exception doing that. So let's say I want to assign 2 to position 7. Let's run this. And you see we get an error here. It says exception in thread main, array index out of bounds exception. So index 7 out of bounds for length 6. So we try to access an index that doesn't exist. So the same would even go for index 6 because we only have 6 entries and it starts at 0 and goes all the way to 5. So here exception thread main index 6 out of bounds for length 6. Okay, because it starts at 0, that's why 6 is already out of bounds. Now we can use the same with the double array. So numbers D, for example, this would be our double array, just using the double array keyword, double array of. And of course, you could have simplified this the same way. And here I'm going to override double array like so. But then you have to specifically use double numbers, which means you have to add the floating point value to them. Otherwise, it wouldn't work. So you cannot assign an integer to a double array. You could see that directly here because we got an error here otherwise. Or you can go ahead and use an array of for days. So let's go ahead and use that here. So val days will be an array of, and you just use Sunday, for example, then Monday. And you see, you separate the entries, even if you're using strings, each time with a comma. So each entry is added like this inside of our brackets. So then if you want to display it, you would do the same thing as we saw earlier with content to string. So here I have all of the days of the week, and now I'm printing them, and this will have not any impact here. Let's also get rid of this statement here. And let's just display the days of the week. And you see Sunday, Monday, Tuesday, Wednesday, and so forth. We can even go as far as to store entire objects inside of an array. So therefore, I'm going to create a small data class outside of this function, also outside of our main function here at the bottom. And I'm going to call this one fruit. And this fruit will need a name. So val name of type string. And it will need a price, for example, of type double. Okay, so that's how the structure of our data class will be. And now we can just go ahead and create a fruits list, which will be an array of the different fruits. So here we can now create fruit objects. So fruit object 1 will be an apple, and it has a price of, let's say, kilo price of $2.5, so euros. And then we create another fruit, which will be, for example, grape, and that will then cost 3.5 euros per kilo, just as an example. And we can print the fruits in the same way as we would with the days. So here, let's just print fruits with content to string, and let's run it real quick. And we can see here we have the fruit name apple, price 2.5, and the other fruit grape, and so forth. This will be super useful, and we're going to use that quite a bit in the future. Now, you can also access individual items of that fruit and print it. Instead of printing all the fruits content, you can just go ahead and just display the fruit's name. Okay, so I can just go ahead and say where the fruit is, at which index. So here, let me use the quotation marks rounding. Basically, I'm saying fruits, give me the index as well. And in order to get the index, we of course need to use a for loop. So for index in fruits, and then indices. This gives me the indexes, like so. And then inside I want just to print the index. So this doesn't give me the fruit itself, but it gives me the index, so the position of the fruit. So here I want to get the name of the fruit at a particular index. That would be a way. And let me add the quotation here as well. This is one way to get the indexes, but if you just want to get the fruits, there is an easier way. You can just use a for loop where you go through each individual fruit inside of fruits, and you just print the fruit name. So here you can just go ahead and say fruit.name. This will give you the fruit name. So let's run it, and you will see that we now get the fruit names. And let me actually get rid of the days here so we can see it a little better. And we can see apple and grape, and then apple is at index 0, grape is in index 1. So this was apple and grape, and this was the indices. By the way, you can also have an array which uses multiple different types of data. So here, let's use this days, for example, and instead of days, now we have this little mix-up where we use Tuesday, and then we just assign numbers, like so. It's just a new number, and then here we also have a fruit object, so we can just go ahead and say fruit apple with a 2.5 price. So and this would be not days but mix, and then let's print those as well. So here mix.content to string, and therefore let me comment those other parts out, and let's run our code. So you see we have Sunday, Monday, Tuesday, 1, 2, 3 fruit with the name apple and price of 2.5. So the beauty about array of is really that it can hold different types of data. And we saw earlier that there are these double arrays, for example, they can only hold doubles, and int arrays, they can only hold ints. They will be more efficient as well as safer. So why would you use an int array if you can just go ahead and use an array of? Well, the idea is that int arrays are super on point and they can only hold numbers. So imagine you get the data from somewhere else, and for some reason the database gave you an integer at the position where you would have expected an int, and then your code would directly figure it out, and you could get a way around it. Except you could add an exception that will then manage that problem and go about it. Okay, and that wouldn't be recognized if you have such a mixed array that doesn't care what kind of data it has. Okay, so that's pretty much it for this video. See you in the next one. Welcome back. In this video, we're going to look at lists. And lists can be used to hold both single data types and custom objects or classes. They can be resized to grow as new values are added. There are mutable types which can be written to, and there are immutable types that you cannot write into, but only read from. And let's look at those. So first of all, let's create a list of months. So well, months, which will be a list of, you just use this method here, and then you add the elements. So for example, January, then February, and then, for example, March, and so forth. Okay, I'm not going to go over all of the months. The cool thing of list of that it can contain any type of list item. So val any types, for example, is going to be a list of, and then you have a number, well, a bunch of numbers here, like so 1, 2, 3, and then you have the boolean value true or false, and then you have the string, you know, like it accepts all types of data. So in order to print the amount of items that you have in an item, you can just go ahead and use print any types dot size. So let's run this and actually see something in action. And this will just tell me that there are 6 items in here. So 1, 2, 3, 4, 5, and 6. You can also access items of a given list by using the index. So for example, if I want to get February, I would use months with the index of 1. And let me comment this line out here and run it again. And now it will say February. You can also loop through it in a similar fashion as we've seen before, right? So you have a for loop with the month in months, and then you just print each month in a new line with the month, like so. Okay, so let's check that out. Comment this line out here and get all of the months that we have in there. So January, February, March. Okay, so now let's look at what we can do with such a list of list. Okay, so we can just go ahead and use months dot and then see what our IDE offers us. And you can see it has a bunch of methods to offer. Well, it doesn't allow me to do it properly now. It's complaining because of the errors that we're creating here, but you can see that there are a bunch of methods that you can use from. It's going to allow you to select one of those. In my case, my IDE just doesn't seem to like it right now, but generally speaking, you can just go ahead and check. So here, for example, with any types dot, and you can see list index of, then we have the list iterator size. So it has a bunch of properties as well as methods that we can use. And you can just play around with those if you want to. Now, the problem here is that these lists are immutable, so we cannot add new items to them. Of course, when we change the code here, but we cannot add a new item to months, for example. So for example, there is no add method here, so we cannot add new items to it. And in order to make a list that is going to be mutable, we can convert our existing list into a mutable list and then add items. So let's convert months into an additional months list, and we're going to use months dot to mutable list, like so. And now this additional months is going to be a list now, which will be a list, but it will be changeable, so we can add new items to it. So let's create a new months list, which will in this case be an array of, and I'm just going to add April, then I'm going to add May and June, for example, right? And now what I can do is I can combine them. So I can use additional months dot add all. So I want to add all items from my new months array. Okay, and now let's print the additional months like so. Let's see what's gonna be displayed for us, and we can see January, February, March, April, May, June. So we added those months and that worked. So the months itself will only have those 3 months in them, but then we have this additional months list, which is a mutable list that we can mutate, meaning we can change. Now, if you want not to add all months at once and you don't want to create a separate array of or whatever, you can just go ahead and use additional months.add, and you can add, for example, July here. Okay, let's run the code again, and this will now add another month to our list. You can see here. So now you can use it as a little challenge to add the other months that are still missing. So pause the video and add the other months either with this approach or with the approach that you saw earlier with the array of different months. Now, if you want to create a mutable list of a particular type, you can also go ahead and just say mutable list of, and then you need to define the type. So here I'm going to define that it's going to be a type of string, and here I have the different days. So for example, Monday, Tuesday, Wednesday. Okay, and now we can add to our days because it's a mutable list, right? We can use add and add the Thursday to it, and then for example print the days like so. And let me not print that anymore. Let's run it real quick here, and we can see it prints the days for us. So that's how you add items. What if you want to override items in a given list? Well, you can just go ahead and say that at the position of days 2, for example, which would be Wednesday, I'm just going to change that to Sunday. And now let's run it again. You can see now we have Monday, Tuesday, Sunday, Thursday. And now if you want to remove a given item, you can just use the remove add method. So remove add, and then you need to pass the index, or you could remove all items, or you could remove a filter of items and so forth. But we're going to keep it simple. Let's say I want to remove the item at index 3, which in this case would be Thursday. So let's run again. And we can see it just says Monday, Tuesday, Sunday. So this Thursday that I added earlier now was deleted. So now instead let's delete index 1, which will delete the Tuesday from it. So Monday, Sunday, Thursday. Okay, That is how you can remove a particular item. What if you want to remove all? Well, you can just go ahead and say days dot remove all. And here you need to say which kind of list you want to remove. So let's say you just want to remove a filter of it. You can create another list, val remove list, and this will remove day list, or however you want to call it. This will be a mutable list of strings as well, but it will just contain mon and wed. Okay, so now you could go ahead and only remove particular items by using the remove list, like so, and run it again, and you will see that Monday and Wednesday are not going to be a part of the list anymore. So Tuesday, Sunday, Thursday, because we deleted the other list that we created. But you can also just use days, which is also a mutable list, right? So here, let me do the same thing with days dot remove all, and here I'm just going to pass days. This will remove all of the items. So you see, print days just gives me an empty list. So that's really how you can delete the entire thing. Basically, you are passing the filter that you want to apply. I am passing all days that I want to delete, so it just removes all for me. So I would really recommend to just go ahead and use the dot operator to then just get some ideas of what you can do with it. You know, you can replace all, you can add, and so forth. There are a bunch of items that you have there. Like you can get the size, you can set things, and so forth. Just play around with the methods there, and you should be good. Well, welcome back. So let's look at one more collection, and that is going to be the set. So set is a type of collection that eliminates duplicate data. This collection is unordered, which means the elements are not sorted. The immutable class is set off, while the mutable types are mutable set off. And then there's also hash set off. So let's look at an example here. So first I'm going to create this fruits example, which will be a set of, for example, orange, then you have apple, grape, and finally another apple while we're at it. So now let's go ahead and print the size of the fruits set. So here print size, like so. Let's run it, and you will see that it displays 3. So what's up here? Well, that is because our orange, our apple, and our grape are the only unique items inside of the set. It ignores this apple. Now let's add mango in here, for example, as well. And I'm going to put that right there. Mango. Very tasty. So we have orange, apple, mango, grape, and another apple. Now you could go as far as to add another orange. And what you will see is that you still get, this time you get 4 because we added the mango. But the apple and orange, the duplicates, so to speak, they are ignored. They're not taken into consideration. Now the cool thing is we can sort this list. So we can of course also display fruits. So let's run this real quick. We'll see orange, apple, mango, grape. So it ignored all of the additional details. And now we can also sort it by using toSorted set. So that's a very cool feature. So let's do that. And you see apple, grape, mango, orange. So it sorted it alphabetically. Now the problem with this set is that it's not mutable. So let's go ahead and create a mutable list. So I'm going to call this one new fruits, and it will be a fruits to mutable list. So now this time we are converting our fruits into a mutable list of fruits. And now we can go ahead and use new fruits in order to add items to it. So for example, a watermelon would be a very good addition to this. And then let's add another beautiful fruit. That would be a pear, like so. Okay, and then let's print those. So print new fruits, and let's see what we're gonna get. And we see we have apple, grape, mango, orange. This is the first entry. This is this print statement. So let me get rid of it in order to make this look a little smoother. We see orange, apple, mango, grape, watermelon, pear. Okay, so it added those entries for us. you want to access a particular fruit in your list, you can go ahead and just use the element add and then the number that you want to have. So new fruits, element add 4. Let's see what's going to happen there. And we see we get the watermelon, because the watermelon at this point is at the index 4, which means it's the 5th fruit, because we have orange, apple, mango, and grape, and then we have the watermelon, and that's index 4. Because orange is at 0, apple at 1, mango at 2, grape at 3, watermelon at 4, and pear at 5. Okay, now let's look at maps. Okay, and we're not going to look at Google Maps or so, but we're going to create a map of, or a map list kind of collection. So map is a type of collection that holds data in the form of a key value pair, and the map keys are unique and hold only one value for each key. So let's look at that. So we have days of the week, for example, and this time we're going to use a map of here. So this will be a map of 1 to Monday, for example. That's how you can map. Very easy way, pretty cool. And here you need to have the empty spaces. So 1 to Monday, then 2 to, for example, Tuesday, and 3 to Wednesday. So I have now connected the numbers to the days. And that means that this key, this is the key, is connected to the value of Wednesday. The key 1 is connected to the value of Monday. So this key can only be existing once. Each key only exists once. So this is a map, but in other languages, this is also called a hash map or a dictionary. So depending on which programming language you're looking at, it just has different names. Okay, and then we can now go ahead and, for example, access a particular item. So print days of week at position 2, for example, would give us Tuesday. Okay, so here we're not talking about the index, but the actual key. Okay, it gets the key value and not the index. So let's run this and we will get the Tuesday entry because it is connected to the key of 2. If you want to loop through your items inside of a map, you can just go ahead and use a for loop again, saying key in days of week dot keys. So now we're going through the individual keys, and let's print the key is 2 and then the days of week dot, well, in this case, the squared brackets key. And what this will give us, it will tell us what the key is, and it will tell us the item that it is connected to. So this is the value that it's connected to. And here I'm using numbers to strings, but this could also be strings to, for example, objects. So you're not limited here. It gives you a lot of freedom here. So let's run this and see. 1 is to Monday, 2 is to Tuesday, and 3 is to Wednesday. So just a quick example of using our fruit data again. So here data class fruit, which contains the value of name, which will be a string, and then price, which will be a double. Okay, so we have this beautiful fruit now, this fruit class, and now we could go ahead and say fruits is going to be a map of, and this will be fruits map. Let's call it like this. So that is unique, map of, and then I connect, for example, 1 to my fruit, which is going to be grape and has the price of 2.5. And then we have 2 assigned to fruit that will be, and actually here you could even go ahead and use not grape, but favorite fruit, something like this, favorite. And this would be okay. And here the fruit would be apple, even though I love apples. And it has the price of €1, 1.0 euro in order to be precise. Okay, so that will be our map of, and let me find a good point to set the break. So here you see we have this fruits map of where our key this time is a string and the value is an object. In our simple example here, our key was a number and the value was a string. So you can make whatever connections you want to have here, which is why maps are so powerful. Now, if you want to make changes, you need to make it a mutable list. So here I can just go ahead and change that to val new days of week or new day of week, and that will be days of the week. Okay, and I'm going to make it a mutable map. So to mutable map, and now I can use the new days of the week to assign, for example, at position 4, I can add Thursday, and then at position 5, I could add Friday, and so forth. Okay, and you can now sort a map by using the toSortedMap method. So here, print new days of week dot toSortedMap. Now this will sort the map for us. Let's run this real quick, and we can see we have the sorted map, and actually we have another print statement somewhere, which makes this a little more difficult to read, I believe. This one. So let's get rid of this and run it again. And we can see now it's sorted. It's Monday, Tuesday, Wednesday, Thursday, Friday, and it's sorted by its key. So just like other collections, maps also have a bunch of different methods that you can play around with. So I would really recommend that you just go ahead and use the dot operator and just give yourself some hints. Okay, so what you can do here, for example, it doesn't have an add method, but it has other methods. So here, if you press the dot key, you can see there are a bunch of methods. In my case, the IDE seems to be broken, so I'm going to fix that. Okay, so that's it for this video. See you in the next one. Welcome back. In this video, we are going to look at array lists, and we're going to use array lists quite a bit in our future project. So it's important to see how they are used and understand them. So they're used to create dynamic arrays, and arrays are types of collections. So we are going to use collections hereby. So why should you use an array lists? Well, array lists are used to create a dynamic array, which means the size of an array list can be increased or decreased according to your requirement. So it's not limited to a specific size, which is pretty cool. The ArrayList class provides both read and write functionality. Then the ArrayList follows the sequence of insertion order, so it matters when you put something in there. And an ArrayList is non-synchronized, and it may contain duplicate elements. So it's not going to be limited to one entry of the same thing, so to speak. The constructor of an ArrayList looks like this. So either it is used to create an empty array list, so that's the basic constructor. Then you have another constructor where you can actually pass in the capacity, so you can say what the maximum amount of elements that can fit into this array list should be. And then you can create an array list based on a collection, so you can fill it with the elements of a collection and use it then as you need it. Examples of functions of array lists are, for example, the add function used to add the specific element into the collection. Then the clear function is used to remove all elements from a collection. The get function allows you to get an element as the specified index. So for example, if you want to have the 5th entry, you could enter index 4 in there and you would get that. And then the remove function is used to remove a single instance of the specific element from the current collection if it's available. And hereby I say a single instance. So let's say you have the value 5 multiple times in there, only the first 5 would be removed if you call this remove function with the value of 5. Then there are of course many more functions in the ArrayList class, and we're going to use multiple of them, but these are the most important ones. All right, let's have a look at an actual array list. So you can see we create an array list and we create it via the val keyword. So we're not using var here because even though the array list might be a val, so an immutable array list, it's still adjustable. So we cannot replace the array list object, but we can replace the content of this array list object. In this case, it's an array list object of type string, so we only can add strings in there. For example, the array list add1 and then array list add2. So I'm adding 1 and 2 to this array list, meaning the written words, and then we can print this array list by using the for in loop here. So for I in array list, we print I, and that will output 1 and 2. The array list using collections, let's have a look at that. We can see we have again the function main, and then we create an array list. This time we set this array list as being limited to 5 entries. So this is the one example where you can limit an array list to a certain amount of values. So here, this one. And then we have a list, which is a mutable list of strings. And we put values in there. And then we add all of those values to our array list. Then we use an array list iterator called itr in our case. And we say as long as this iterator has something, so as long as our array list has another entry in there, we want to run this while loop. So we're just printing itr next. So the next entry in our itr, which in this case means in the array list iterator, which pretty much means in the array list itself. And then we can also see that we can get the size of an array list by using its size property. So that will give us the following output: 1, 2, and then of course the size of array list is 2 because there are only 2 entries in there. Now let's look at the get function. So you can see we have this main function here again with. So then let's look at the get function. You can see again we have a main function here using an array list of strings, and then we add 1 and 2, and then we loop through it with this for loop. But we also use the get function here in order to see what we will get. So if I use get1, I will get 2. So this is a little confusing, but that has to do with the counting starting at 0. So the first entry here is going to be at index 0. The second entry will be at index 1. And what we're doing here is we are accessing index 1, which means we get the 2. And that's why the output is 2 in this case. All right, this was just a little introduction to array lists. We're going to use them quite a bit and then they will become natural as usual. So no worries there. It's like learning a new word in a foreign language. The more context you see this word in, the more it makes sense and the better of an understanding you get for this word. So see you in the next video. Welcome back. In this video, we're going to look at lambda expressions. And lambda expressions are a pretty cool feature. They allow us to write super concise and short code that does quite some advanced things. So let's have a look at that. What is a lambda expression? A lambda or a lambda expression, both is fine, is a function which has no name. But a lambda expression is not the same as an anonymous function, which also has no name. So there's a little distinction there. We're going to focus on lambda expressions for now though, because these are the ones that we're going to use and that we already have used when we used the onClick event. So lambda expressions and anonymous functions are function literals. For example, functions that are not declared but passed immediately as an expression. So a lambda is defined with curly braces, which takes variables as a parameter, if any, and a body of a function. So it can take variables as a parameter, but it doesn't have to. Okay, so it's not a requirement. The body of a function is written after the variable, if any, followed by the arrow operator. So this is the lambda operator, so to speak. So this is a dash with an arrow. And the syntax is variable or variables, lambda expression, body of lambda. And all of that is surrounded by curly brackets. So let's look at a normal function, addition of two numbers, where we create a function, add numbers, or add number passing two arguments a and b, add number 5, 10, are the two values that we pass. So a is 5 and b is 10. And the function looks like this. Fun add number, a int, b int, and then we have the val add is a plus b, and then we print, in this case, just add, and that's it. So this is what our function does, very basic. Now the thing is, we can have this output of 15, but we can really shorten this. Now let's see how we can do that with a lambda expression. So we will write the same example using lambda expressions. So here we have val sum int int, it's going to return an int. So what we're saying is that we're creating a lambda expression called sum, and we take two parameters, int and int, or of type int, and we return an int. So what we are now saying that the lambda expression itself should be a of type int, b of type int shall return a plus b. Okay, so this is what we do here. So what is after the lambda expression is what is going to be returned because we defined it here. Okay, but it's possible to do this even shorter. Of course, we had this println there in order to display something. So we are calling this sum lambda expression, we're passing the two values, and we're printing it because we also wanted to print the value, right? But we can do this even shorter. So we can have val sum a of type int, b of type int is already part of the lambda expression, and then we just println a plus b. So now if we call sum, we pass the two values, it will already print 15. So it will directly print the result. So we just had two lines. It's not exactly the same. As you can see, in one of the two examples, we're actually returning. So in this case, we're returning the value first, and then we use it in a print line statement in order to print the return statement. And then in this case, we directly added to the print line here in order to display whatever is here. So if you wanted to return it, then you would get rid of this print line and then do the same print line sum as you had here at the top. Okay, so both versions are fine, but what you cannot do is use print line in here because you're saying that you return an integer. Okay, so you still have to follow the structure of whatever you're trying to return, it has to be returned. Okay, so whatever you're defining that will be returned, in this case an integer, has to be returned here as a return statement. All right, so this is an example of a lambda expression, and we're going to use lambda expressions, but more importantly, we're going to see lambda expressions in action when we work, for example, with events, such as click events and in other cases as well. So it's more important for you to understand the concept behind it and not be surprised when we see them, rather than having to use lambda expressions yourself all the time, because they are a little more advanced than the other ways of creating functions, so feel free to use either of them. Now let's look at something that is called visibility modifier or access modifier. So in Kotlin they are called visibility modifiers, and they are the keyword which is used to restrict the use of classes, interfaces, methods, and properties in Kotlin. So what is a visibility modifier? Well, visibility modifiers are the keywords which are used to restrict the use of classes, interfaces, methods, and properties in Kotlin. And these modifiers are used at multiple places, such as the class header or the method body. And visibility modifiers are categorized into 4 different types, which are public, private, protected, and internal. The most common ones are public and private, and you probably have used them already, or at least have seen them already. So let's start with a public modifier. A public modified element is accessible from everywhere in the project. The public modifier is the default modifier in Kotlin. So if any class, interface, etc. is not specified with any access or visibility modifier, then that class or interface or and so forth is used in a public scope. So if you add nothing, then that element is automatically public. All public declarations can be placed at the top of the file. If a member of a class is not specified, then it is by default public. So here the same goes as for interfaces and classes and so forth. So let's have a look at the syntax of public modifiers. As you can see, you can make a class public by adding the public keyword, or it is automatically public if you don't add it, but that's generally what you can do. You can add the public keyword to specifically state that a class or a method or a value even, or a field, variable, however, is public. Then the private modifier, and that's where things become a little more interesting. A private modifier allows the element to be accessible only within the block in which properties, fields, etc. are declared. So if something is private, then it's only accessible where it is declared. All right. So the private modifier declaration does not allow access outside of the scope, and a private package can be accessible within that specific file. So if you have multiple packages and you make one package, for example, private, then this one will not be accessible in other files. So for example, if you have multiple classes and you have a package in one class and you make this package private, then you cannot use it in other classes which are in other files. All right. So the syntax for a private modifier, well, you can have a class that is private, then you can have its properties to be private by just adding this private keyword, then the methods to be private. And in this above example, you can see that val x and the function do something are declared as private. The class example is accessible from the same source file. Val x and fun do something are only accessible within the example class. So if we now create an object of this class example, we cannot access the variable x and we cannot access the method do something. Okay, so they're really only available within that same class, and this class is only available within that same file. So if we use another file, this class will not be accessible and we cannot create objects of it. Then the internal modifier is a feature in Kotlin which is not available in Java, and the internal modifier makes the field visible only inside the module in which it is implemented. So all fields are declared as internal, which are accessible only inside the module in which they are implemented. All right. So another example here, and we can see the syntax for internal modifiers. So you can use this internal keyword for a class, for a property, and also for methods, and even for global variables, as you can see here. So then there is a keyword called open, and we need to talk about it real quick in order to understand the next concept. So in Kotlin, all classes are final by default, so they can't be inherited by default. Okay, that's different to other programming languages. For example, in Java, it's the opposite, that you have to make your class final explicitly because all classes can be inherited from. So if you want to use inheritance, then you need to make the class that you want to inherit from open. So to make a class inheritable to other classes, you must mark it with the open keyword. And otherwise you get an error here, type is final, so can't be inherited. All right, so then there is the protected modifier with a class or an interface allows visibility to its class or subclass. A protected declaration, when overridden in its subclass, is also protected unless it is explicitly changed. So we're going to look at that in a bit. And the protected modifier cannot be declared at the top level. So packages cannot be protected. You can use other visibility modifiers, but you cannot use the protected modifier on packages. So here's an example. You can see here we're using the open keyword, open class base, where we use this protected val I, which we set to 0. So now we have this class which derives from base, so which is our derived class, and there we have this function getValue, or this method to be precise, and it returns an integer. And there we now return I. So we return the variable that was created in the base class. Because we are inheriting from it, we can use it. But if we weren't inheriting from it, so if we're in another class, let's call this class C, then we could not use this val I. Then another example, overriding of protected types. So here we have an open protected value. So now it allows us to override that value. Okay, so now we can override it. We cannot just only use it, but actually override it. So you can see we have another class which also inherits from base, so different to the one that we had before. As you can see, this was class derived, and now we have this class called another. It derives from base. It also has a function called getValue, and then it returns I. But on top of that, it overrides the value I. So here you can see if you want to be able to override something, you need to add the open keywords to it. So in this case, you need to open the value that we use there, the variable. All right, now we have another example here of the visibility modifier. So we have this open class base. We make it open so that we can inherit from it. Our other classes, like our derived class there at the bottom, can inherit from it. So var a that we define is automatically public because it's public by default, right? We didn't specifically state that it's public, but it is by default public. Then we create this other variable called b, and that one is private. So it's private to the base class. Then we have this protected variable c, and we make it open. So this one is visible to the base and the derived class, which means that the derived class, in this case it's called derived, but this is the case for all classes that are deriving, it's visible there and it's usable there. Then we have this internal val d, which is visible inside the same module, which means that it is visible inside of the same file pretty much. And then we have this protected fun e, which is our function, and it's visible to the base and the derived class. So because it's protected, it's not only visible or usable in our base class, but also in our derived class, but not inside of our fun main. All right, in there it's not visible. So here we have our derived class. A, C, D, and E of the base class are visible. B is not visible. Why is that? Well, because it's private, so it's only available in the base class itself. Protected, internal, and public variables, however, are visible in the derived class. And then we can even override the value C because it's protected, so it can be used in the derived class, but it's also open, so we can override it. Okay, C is protected, but we can override it with the override keyword. Then we have our function main, and in there we have a base object, so we create an object of our base class, and we create an object of our derived class. All right, so when we try to access A and D, we can access them because A is public and D is internal, so it's visible in the same module, and we are in the same module in this example. And then we have base B, C, and E, which are all not visible because they are protected, so they are only visible in the same class or in a deriving class. All right, so B is a private one, so it's not going to be visible anywhere else, right? Except, of course, for the base class. Then we have the value C, which is protected, so it's not visible outside of classes that are deriving and the class itself. And then we have the same for E for our function. All right, and then we have the val derived object, and here we're trying to access C, but C is not visible. Why is that? Well, because we are inheriting our value C, we're overriding that value C, but it's still going to be protected. So C is not visible. So this is a little bit much to digest, I can imagine. So no worries, but we're going to use this quite a bit. So we're going to use all of these visibility modifiers when we need them. And most of them we are going to use very sparingly, very rarely. So for example, protected and internal are not used as often as, for example, the private keyword. So we're going to use that one, and step by step they all will become natural. So no worries if that was a little bit much all at once. But I wanted to keep it all together in one video so you can see the different rules there. Now let's look at two more concepts, nested class and inner class, and we're going to need them later on. So let's look at the concepts here. A class which is created inside another class, and a class which is created inside another class with the keyword inner. So this is the difference between the two, but there are a little more differences that we need to look at. So let's look at the nested class first. A nested class is such a class which is created inside another class. In Kotlin, a nested class is by default static. So its data members and member functions can be accessed without creating an object of the class. So without having to create an object of this nested class, you can go ahead and use the functions and members. Then the nested class cannot access the data members of the outer class. So it's a one-way relationship. So only the outer class can access the members of the nested class. but not the other way around. So let's look at this. We have a class called outer class, and then inside of this class we create another class called nested class. Okay, and usually you should create classes which are separated, so each having their own file, but sometimes it just makes sense to have a nested class. For example, if you really just need its functionality within the outer class that we're using here. And nested class example that we see here is that we have this outer class, and there we have a variable called name, and it's set to Mr. X. And then we have this nested class, which has a description, and then it has an ID, which is of type int, and a function called foo, which just prints the name and the ID. And then we go to our main function, where we try to access the description. So in order to access the description, we go to our outer class, and then inside of that, we go to the nested class. So we're accessing the property here. And then we create an object of the nested class, and we access the function. So the member function of that nested class. So the output is code inside the nested class, and ID is 101. So now let's look at the inner class concept. An inner class is a class which is created inside another class with the keyword inner. In other words, we can say that a nested class which is marked as inner is called an inner class. So it's still a nested class, but it has this additional keyword, right? But the difference now is an inner class cannot be declared inside interfaces or non-inner nested classes. And the advantage of inner classes is that they are able to access members of its outer class even though they are private. So this is the huge difference, right? So the inner class keeps a reference to an object of its outer class. So if we look at this example here, this is the syntax of an inner class. So we have the outer class, inside we have this nested class, but we add the inner keyword. So inner just before the class keyword. All right, and then if we look at this example that we had before, the only difference now is that we add the inner keyword here to our inner class, and that we now can access name and ID. We could, of course, beforehand access the ID anyways, but we couldn't access the name. So you can see here the name that we're using is from the outer class. So here where we have this private keyword even. So we say, okay, this is private, so it should only be available within this class. But with the inner classes, you actually have access to even private class members of the outer class. Okay, so that's the huge difference. In a nested class without this inner keyword, this wouldn't be possible. So sometimes it just makes sense, and sometimes you just need this functionality, and then you make it an inner class and you can use it. So going back to our function main, here we have our outer class, inner class description. So we can access the property as we did before, and we can also access the object foo. So we create an object of the inner class, which is inside of our outer class, and then we can go ahead and use its member functions. So the output here is code inside inner class, name is Mr. X, and ID is 101. So we didn't have this name is Mr. X before. All right, so that's it for now. Let's get back to coding, where we are actually going to use this functionality, and then it will make a lot more sense because it's a little bit abstract to look at it that way. So let's get into coding. Welcome back. Now we're going to look at unsafe and safe cast operators, and they are useful because sometimes you just need to cast something, right? So you have something in a specific type and you need to cast it in another type, and that's where the as keyword comes in. And this is an unsafe cast operator. Sometimes it is not possible to cast a variable and it throws an exception, and this is called an unsafe cast. The unsafe cast is performed by the infix operator as, and let's have a look at an example here. A nullable string with a question mark here cannot be cast to a non-nullable string. So a string without the question mark, because this then throws an exception. So let's look at this function main here. We have this value object of a type any nullable, which is null. And then we have this value string or str, which is of type string. And what we try to do is we try to cast object as string, and then print that string that we created. So the problem is that we get an error here, an exception to be precise. It says exception in thread main Kotlin type cast exception. Null cannot be cast to non-null type in Kotlin string. So here, of course, this doesn't work because the object of type any nullable is actually null. So it's empty. But this throws an error. So this really crashes our software, our program. And we want to avoid that at all costs, right? So what can we do? Well, let's have a look in a second. But first, it generates a class cast exception. Trying to cast an integer value of the any type into a string type leads to a class cast exception. So here we have object of type any, 1, 2, 3, and we try to cast that to a string. So we say val string or str of type string should be object as string. This throws a class cast exception because any could be any type, right? It's just interprets whatever data it gets, and it interprets in this case that 123 is an integer. So it's going to say that integer cannot be cast to a string. We need to use another approach here, right? We cannot cast. We would need to use type conversion or parsing here. All right. So now let's look at an example where this actually works. So the source and the target variable need to be nullables for casting to work. So here we have the object any, which is of type nullable. So we have this question mark and has a string in there. So a string is hidden, so to speak, in the any object. And then we have a string which is also a nullable. So what we can do is we can say object should be cast into a string. So it should be of type string nullable. So this will output the string unsafe cast. There is an operator, however, which makes our life even easier. So there is something called safe cast operator. And the as question mark, so the safe cast operator, provides a safe cast operation to safely cast to a type. It returns a null if casting is not possible, rather than throwing a class cast exception. Okay, so this is very good because then our program will not crash. If it doesn't work, it will just return null. All right, so here, example of safe cast operation. So we have a location which is of type any, and it actually is a string, right? So in the background there's a string, and as you can see, it's not nullable any. Then we have a safe string, which is a string that is a nullable, and what it tries to do, it tries to get the location as a string. So it uses the safe cast operation here. Then we have a safe int, which is an integer nullable, and it tries the same thing. So it tries to get the location as an integer. But of course, a text cannot be an integer, right? Or at least a word, as we see here, Kotlin, cannot be of type integer, not even integer nullable. It will just be null, right? So the output here is Kotlin and null. All right, Kotlin for the safe string and null for the safe int, because it wasn't able to convert it, because Kotlin is not convertible or castable, so to speak. It's not castable into an integer. All right, so that's it for unsafe and safe casting operators for now. And yeah, further in the course, we will use it, and then it will make a lot more sense, because here the examples, of course, are very abstract and they are very purpose driven, but later on we will see how it actually is going to work. All right, so see you in the next video. Welcome back. In this video, we are going to check out exception handling, which means the handling of runtime problems which occur in the program and would otherwise lead to program termination. So this is the case for not only apps, but for all programs. So what is an exception? An exception is a runtime problem which occurs in the program and leads to program termination, which on the phone means that the app is not going to respond. Now, that is a very, very bad behavior. So you should at all costs try to avoid exceptions to not be handled. So to just run. So examples would be running out of memory, array out of bound, condition like divide by 0. And to handle this type of problem during program execution, the technique of exception handling is used. And exception handling is a technique which handles the runtime problems and maintains the flow of the program execution. So when you use exception handling, the exceptions may still arise, but they will not make your program crash, and your program will still work, even though it might not do the things as intended. For example, if you try to access the internet and you don't handle the exception that the internet connection doesn't work, then you would run into an error. So you would get an exception because you can't connect to the internet. And that could break your app if you don't handle this exception. That's why it's super important to handle those kind of exceptions and still make your program work. So even if the internet doesn't work, then you will just display something to the user, please turn on your internet or get an internet connection or something like that. All right, so there is the throwable class, which allows us to throw an exception. So this throws an exception if we use this throw keyword and then the name of the exception. I called this exception my exception, because we can create our own types of exceptions, which will then do whatever we want to do in those cases. There are 4 different keywords used in exception handling, and these are try, catch, finally, and throw. So these are the main keywords, and we're going to check those keywords out. So keywords used in exception handling, let's look at the try keyword. The try block contains a set of statements which might generate an exception. It must be followed by either catch or finally or both. All right, so this is the code that can break, that can make create an error, create an exception, such as connecting to the internet or running through an array. So there can be a lot of issues that come up. Then the catch block is used to catch the exception thrown from the try block. So if there is an exception in the try block, the catch block should execute. Otherwise, it will not execute. So if there's no problem in the try block, so if the code works perfectly fine, for example, back to our internet problem, let's say we have internet and we try to exit the connection, then we will not have a problem. The try block will work. The catch block will not execute. But if the internet connection is not there, then of course the catch block should run. Then we have finally. The finally block allows execution whether exception is handled or not. So it's used to execute important code statements like closing buffers. For example, closing a buffer which takes care of the connection to the internet, or a buffer that takes care of storing data on the phone. So these are things that need to be closed after they have been opened, and that is usually done in finally. So after the try block has been executed or after the catch block has executed if there was an error. And then we have this throw keyword, which allows us to throw an exception explicitly. So we ourselves write this in order to throw an exception, in order to cause an error. And this is especially useful when testing to see where an error occurs, and we create our own exceptions or throws so that we know, okay, this is something that we just wrote. All right, and then there you are sitting in front of your code and suddenly an exception arises. Well, the thing is that usually happens when you have unchecked exceptions. So an unchecked exception is the exception which is thrown due to mistakes in our code. So our code for some reason doesn't work, and there are multiple different exceptions, and the exceptions then run during runtime or execute during runtime are runtime exceptions, and they extend from this runtime exception class. And the unchecked exception is checked at runtime, which means when our app is running, and not during compile time, meaning when we compile our app and press, for example, the run button. Examples of unchecked exceptions are arithmetic exceptions thrown when we divide a number by 0, for example. Then the array index out of bound exception is thrown when an array has been tried to access with incorrect index value. So let's say the array only has 5 values, but you're trying to access the 6th or 7th value, then you get this error. You can very easily try that and force this kind of an error, and you probably have seen this already. And then the security exception thrown by the security manager to indicate that we have a security violation. So for example, we're trying to access GPS, but we don't have the rights to access GPS because the user didn't give us the rights to use the GPS functionality. And then the very common null pointer exception thrown when invoking a method or property on a null object. So when we try to access an object which is empty, which is null, then we get this null pointer exception. And that is something that I have already talked about when we looked at nullables. Then checked exceptions. Well, they are exceptions which are checked at compile time. So pretty much in our code, we write this ourselves. This exception type extends the throwable class. So there's a class called throwable, which takes care of the exception functionality. And examples of checked exceptions would be the input-output exception, so IO exception, or the SQL exception, and there are a bunch more. Now let's look at the try-catch block, which is used for exception handling in the code. The syntax of try with catch block looks like this. So we have this try, then code that may throw the exception, and then we have this catch, for example, some exception. So this could be the IO exception if it's an input-output exception, or it could be just a generic exception. So we would just use the generic exception class name here. And then we have our code that handles the exception. And of course, we need to close the bracket here. All right, examples without exception handling. So in this case, we have an exception handling written ourselves, so try and catch, but the exception is never arising because the problem doesn't appear. So here, for example, we use value string get number. So we use this function get number, and we have a value of 10 there. So the variable string is getting the int value of 10 and then making a string out of it. So we're trying to integer parse int. So we're trying to parse that value into a string. So it's an integer, right? 10, but we're making a string out of it. And if something goes wrong, for example, an arithmetic exception appears, then we want to output 0. All right, so if we run println string now, we get the output of 10. All right, now let's look at the exception handling when it's actually running. So when we actually do have an exception handling running, and that is the case, for example, if we try to have a parsing here with a value of 10.5. So in this case, we're trying to parse a double as an integer, and that doesn't work. So we have to be careful with the type here, of course, and that creates an error. So our try block does actually create an arithmetic exception. So the output is 0. So whatever we have in our catch block here. All right. So that is something that we, of course, have to be careful with. Then we can have multiple catch blocks. So we can use multiple catch blocks in our code, and they are used when we can have different types of operations or different types of operation errors in a try block, which may cause different exceptions in the try block. So here an example, we have this function where we try to get the value a out of an int array, which is 5, so which has 5 elements in there. And now we're saying a at position 5, or at index 5, which means at its 6th position, should be 10 divided by 0. So there are a bunch of problems that we create here. One of them being that 10 cannot be, or anything cannot be divided by 0. So we get an arithmetic exception here, trying to divide by 0. Not good, doesn't work, creates an error. And then we're trying to access an array at a position which doesn't exist. So the array just has 5 values, but we're trying to access its 6th value. So we're creating this problem here. So here, this is where the problem arises. All right. So we have 2 errors that can appear here. And then we have the arithmetic exception, which takes care of arithmetics, or then we'll just print arithmetic exception catch. So for example, trying to divide by 0. Then we have an array index out of bounds exception, which will be run because of this a accessing index 5. And then we have a generic exception, which is the parent exception class. So it's just the name exception. So you can see in catch, we always have this e colon and then the name of the exception that we want to use. And by the way, you can get information about the error, so a little more information, or pretty much a lot of information, when you just print the stack trace of e. All right, so we can see that the output here will be an arithmetic exception catch, and then we have the code after the try catch. So we can also have nested try catch blocks, and that is sometimes required, but the requirement of nested try catch blocks arises when a block of code generates an exception, and within that block another code statement also generates an exception. So that is the exception inception, so to speak. All right, syntax of nested try blocks. Let's look at this. So we have a try code block, and then we have another try code block, and then we have the catch block for the first try, and then some exception code that we have, and then we have another exception that we catch. So as you can see, the try has to be followed by a catch, but when you have a try inside of a try, that try has to be followed by a catch. Okay, so these two are connected with each other, and this try here is connected to that catch down there. All right, so this is an example for that. Then we have the finally block, and you saw the keyword finally before. And the finally block is such a block which is always executed whether exception is handled or not. So it is used to execute important code statements. For example, as I said earlier, code that should be run when all of the other code is done, for example, closing the connection. Okay, so we have this function main here where we try to divide 10 by 5 and then we print the data. So our catch that we have here is a null pointer exception catch. So we have this exception that we pointed here because data could be empty, for example. And then we have this finally block here, which always executes. And then we have print line below code just to see what's executed. And if we run this code, we will see that 2, then finally block always executes, and below code are printed onto our console. And that has to do with, first of all, 10 divided by 5 is 2. So this print statement is printed. Then here you see we print the E, so the null pointer exception. So if that would arise, we would print the whole exception. And then we have this finally block, which is executed no matter if try is running without an error or if it's run with an error. So the catch block will be run as well. So either way, we run our finally. So our print finally block always is executed. And of course, our below code is also executed. Then we have this throw keyword, and the throw keyword is used to throw an explicit exception. It is used to throw a custom exception. For example, to throw an exception object, we will use the throw exception. So the syntax of the throw keyword is throw some exception. And let's have a look at this. So we have this func main where we use this validate function and we add a value of 15 in there, or we pass a value of 15 and we print some code after the validation check, or pretty much after the validate function. So in the validate function, we check if the age is below 18, and if that's the case, then we throw an arithmetic exception where we say under age. And if the age is not under 18, then we say eligible for drive. So this is not the case for the US, but it's the case for many other countries where you have to be 18 in order to drive. So the output here is exception in thread main java.length.arithmetic exception colon underage. So after the colon comes whatever we have entered in those brackets. Okay, so in our case, underage. So this is something that comes in handy when you actually want to make sure that you check your code correctly. And yeah, you just want to throw these kind of errors in order to break your code, in order to understand where the problems arise. So in this case, it wouldn't make sense because it's a dumb example, so to speak, but in real life, it would make a lot more sense when you, for example, need to check your app for potential incorrect entries that users can make, or for potential problems that arise when you get data from the web and stuff like that. And you don't want to publish the app with a lot of throw statements or a lot of errors, okay? Because a throw statement actually makes your app crash. All right, now let's get back to coding. This was a super long example of the whole concepts of try and catch blocks, but now you know pretty much everything about it and we can use it in our code. And all of this might look a little intimidating, but it will really become your second nature once you use it and you see what the advantages of all of those things are. So I'd say let's get back to coding and see you in the next video.
Alrighty, so now we're done with the fundamentals of Kotlin. So the chapter is done and now we can finally get into the app development and we can finally build our own applications. But we of course are going to learn quite some other fundamentals when it comes to Kotlin throughout the course. So it's not done with the fundamentals. It's just that I think at this point we have enough fundamentals to get started developing some real applications. All right. And what you have learned in this chapter is, of course, how to use array lists, because we are going to use array lists a lot. Then we looked at lambda expressions, and lambda expressions are something that is used built in quite a bit. So Android is using it quite a bit, and we're going therefore also use it, even though you might not build your own lambda expressions as such. Then we have seen how visibility modifiers work, so how you can make sure that a variable or a function is only usable at a specific context. And we've seen how nested and inner classes work, what the difference is and what we need to take care of, and how safe and unsafe operators work. And then finally, we have, of course, looked into try and catch or exception handling with those keywords. And now you know how you can make sure that your application doesn't crash if an error occurs that you at least expected to potentially happen. All right. So that's it for this chapter. Let's get started with building Android applications. See you in the next video. Welcome to the age in minutes application. So we're going to build a very basic application which allows us to calculate the age in minutes. So we just enter our birthday and then it will give us how many minutes old we are. Of course, it's not going to be precise by the minute, but at least it's going to be precise by the day, so to speak. So whatever day we chose, that's how precise it will be. Okay, and then we will see how to create a UI, so how we can build our own user interface so that it looks like we want it to look. Then we will look at using text views and buttons, of course, which are part of the UI. So how we can display text, how we can press buttons, then also how to use dialogue, so to create our own dialogue, so to speak, which we can then use in order to select the date. So we're going to use the date picker dialog, and we can then get that date and do calculations with it. And then finally, we will display the result of those calculations. All right, so we're going to use a bunch of built-in classes, which is really helpful because we don't want to write all of the code ourselves. We want to keep it as simple as possible, and that's exactly what we will do. Okay, so I hope you enjoyed this chapter. It's really just the beginning, but at least it's something cool that you can already share with your friends and you can play around with, and it's your first steps towards becoming a real Android developer. All right, so see you in the next video.
Welcome back. In this and the next few videos, we are going to build the age calculator in minutes. So this little app that allows us to calculate our age in minutes. So instead of having the age in years, we will see how old we are in minutes. And in my case, I'm this old, as you can see. So 16,583,100 minutes old. That's how old I am. And yeah, you can select the date here, and depending on what you enter, the tool will calculate how old you are in minutes. Of course, it's not going to take into consideration at which hour you were born and at which minute, but a rough estimate, because even if the minute right now is not precise by, I don't know, 1,000, it's still going to be good enough, I think. So this is the UI that we will have, and you can of course go ahead and try to build that UI. You know how to drag in elements into your UI, and all of these except for this button are just simple text views. So you can just drag in text views into your UI and then try to build that. But of course you can also follow along, and I will show you every single thing that I'm gonna build in here. This app is not really super useful, but it's a funny idea, I think, and it shows you how to build the UI, and it also shows you how to use buttons. We've seen that a little bit already, but what's more important, it's going to show you how to use date pickers and how listeners work. Even though we already saw how a on-click listener works, it's going to be even more important to see how listeners in general work, and that's something that you will see step by step by adding more listeners to your knowledge base and just by practicing. All right, so I'd say let's just start. Let's create a new empty activity or a new project with an empty activity. And this one will be called age in minutes. Of course, you can change the save location, which I did. So here we're going to use API 16, Android 4.1 Jelly Bean, which will run on pretty much all devices. Only a fraction of devices are still online, which use older versions. All right, then let's click finish in order to create the project. Once the project is created, we have the main activity as we had before, and we have the activity underscore main XML, which are the two main files that we're going to work in. So the main activity is our code in the front, which pretty much is our logic. And then our activity main is the appearance of our application. And it will take a little while until it's loaded, so give it some time. All right, now in order to create the UI, I'm going to close this project tab, and it's going to be a little more visible what we have here on the screen. So this text view that I had here, this hello world text view, I'm going to drag it all the way up, and I'm going to change some of its properties. So for example, we can change the layout width. Well, wrap content sounds pretty good because we only want it to take as much space as it really requires. Then the text can be, instead of hello world, something like calculate your, and I'm gonna press enter. Now you can see that it took this value. Next, I want to change the text appearance a little bit. So for example, the text size should be a little bigger, something like 25 SP should be a little better because it should take a little more space. Next, I want to make the text bold. So here on the right hand side, under the common attributes, you can change the text style to being bold. And we can add a little margin towards the top. So whatever is at the top, we want to have some space in between our text view and the other element that will be on top of it, which in our case really is just the bar here at the top, as you can see. This is the app bar that we have, and then we have some space in between here, and that's the space that we can get via adding a margin. So we can do it by going down here in all attributes and scroll all the way out down to layout margin, and here we can set the layout margin for the top value, for the bottom value, and so forth. Even though it's not as visible here, as you can see, you have to make some space for it. So layout margin top, that's where I want to have 15 density pixels. As you can see now, it adjusted this line that we had before with a straight line. So it was a zigzag line, now it's a straight line. It just says, okay, I want to have 15 pixels distance or density pixels distance between the top element and this text that we have here. As you also saw, there is another text color, right? So how do we change the text color? Well, we can, of course, search for color, and that's the easiest way probably. We can see here that currently it's using the secondary color here. And where is that coming from? Well, it comes from color/secondary text color, and we can find it in our resources. So here in the res folder, you have a bunch of resources. For example, drawables, which can be images but can also be XML files. Then the layout, which is our XML file, which is the layout of our app, which is what we are currently editing. Then the mipmap, which contains the images that are used for the app icon on the Android device once you install it. And then we have values. So here in the values, that's where we can add all our values and store them. For example, colors. So there's this colors XML where we can store colors. For example, color primary dark, and color accent. As you can see, they have a value here, which is a hexadecimal value, and it's the value that represents a color. So 62 is the red value, 00 the green value, and EE the blue value. So what is an EE? Why is it not a number? Well, hexadecimal numbers, they go from 0 to F. So instead of our system that we have where everything is just going from 0 to 10, or actually from 0 to 9 to be precise, it just keeps on going all the way to F. All right, so it's 16 numbers instead of just 10 numbers, as we have it in the decimal system. I would like to have different colors here. So instead of having the RGB colors that were populated by default, I want to have my own, which are the following. So I'm just going to paste them in here. You can use your own colors if you want. You can of course use the same colors as I do. So you can see it's this yellow orange color and then this purple color. So these are the colors that I want to use. So the color primary is your primary color. Primary dark is a darker version of your color. It doesn't have to be. In my case, it's the same. And color accent is an accent color which fits well with your primary color. Now, of course, you could go ahead and make it a little darker. So make your primary color a little darker. But for now, I'm just going to keep those colors. So in order to create a new color that you can then reuse, you can just enter color name equals, and then you give it a name. And I'm just going to call it text color. And it's going to be this value here. So this darkish color. All right. So now we can go ahead and use this color in our activity main. So we can change the text color to add color / text color. Now if we look at it, we can see that it is the same color as we had in our app. All right, there we are. So this is the text color that I'm using here. All right, so now let's add this age text here. As you can see, it's a white text and it has a blue background, light blue. So let's add another text view. And what I'm going to do is I'm just going to copy this text view that we have here and duplicate it. And instead of doing that by dragging in a text view in and adding all of the values once again, I'm just going to go ahead and copy this text view. Now, before I do so, I'm going to get rid of all of these constraints. So it created those constraints automatically for me because I just dragged it in there, and that's just how Android handles it. And I'm just going to create it my own way. So you see, I got rid of all of that, but now I get an error here. So now it's complaining and it just moved the text all the way up to the top left. Why does it do that? Well, it does so because it doesn't know where it has to be. So it says, okay, difference of 15 density pixels or distance towards the top, which is this margin top, but it doesn't know whether it should be centered or where it should be in its parent. And its parent is going to be this constraint layout that we have here at the top. Now, the constraint layout expected all of the additional information that we had in here. So all of this constraint bottom and so forth. But I want to use another version of layout. So what I'm going to do is I'm going to change the name here at the top. And therefore, maybe it's better if I go to the code. So instead of using a constraint layout, I'm going to use a linear layout. So let's mark all of that and enter linear layout. Now, if I do so, you can see here at the bottom, it also changed to linear layout. If it doesn't for you, then also enter linear layout here at the bottom, because it's important that the opening tag and the closing tag are of the same type. All right, because everything else is within our linear layout. And you can also see that the linear layout bracket is starting here and it's not ending until here. And these are all the details of that linear layout. So all of the properties of that linear layout. Now, what's inside of the linear layout is for now our text view. Now you can see the error disappeared, so the text view doesn't complain anymore. Let's have a look at what our UI looks like. So you can see, all right, calculate viewer is now distance to the top. So it has this little margin of 15 density pixels, but it doesn't have the center. So it's not centered, so to speak. And in order to change that, we are going to do the following. We're going to adjust our linear layout. So I'm just going to add some more attributes to my linear layout here. And instead of doing it in my UI, I'm just going to do it in the code. So I can enter Android : gravity equals, and then center horizontal. This will center my elements, as you can see, horizontally, which means now it's in the center of my screen, not in the overall center, but of course you can also just do center and it will go from the center itself. So center horizontally will center it on a horizontal level. Center vertically will center it, as you can see here, now vertically in the middle of the screen. Another way of adjusting a property is, instead of just typing Android : and so, we can also directly access the property that we want to change. So in this case, the orientation. So I can just go ahead and say, I want this orientation to be vertical. So now my phone, even if we turn it around, will still display this information on the same way that we can see here. So on a vertical level. Next, I want to change the background color. So I'm just gonna enter background, and now I can choose a color. And as you can see, I can either choose the colors that we had in our colors XML, or I can manually type it in there. But I'm just gonna create a new color here. So color name is going to be background color, and I'm just gonna use this value here. Now let's use this value for our activity main XML. Here we can just enter add color / and then select our background color. Now we have this a little warmer white color. All right, so you can see we only created the text here at the top and a bunch of new colors, but what's more important, we looked into the structure and we created our own structure. We said, okay, we don't want to use the constraint layout. We want to use a linear layout where things are positioned linearly to each other and not based on constraints. For example, the constraints towards the left-hand side, towards the top, towards the right and the bottom, as we had before. But we just say, okay, we want to position things on top of each other. And yeah, that's what we're doing here. All right, so I think we should make a break here. And in the next video, we are going to finalize the UI, because it was important to, first of all, teach you all of the different details around the properties of the text views and so forth. And in the next video, we are going to create all of the rest. So see you there. Welcome back. In this video, we are going to add a little more UI elements to our UI. And before we go any further, I want to very quickly state something that I didn't say in the last video specifically, but I hope it was clear. The XML file is actually this file that we have here. It is of type XML. So this is the language, so to say, which is used, which is a language that allows us to write something that is rather understandable for us humans, but which is also understandable for our application or our phone, which then has to render all of that. We have this representation of it that you can see here on the right hand side. And if we drag something in here from the palette, the only thing it does is it creates XML code for us. So for example, if I drag in a button here, you can see here at the bottom, it created this button. So it just created a new button in there. And if I get rid of this, and let me clean the palette off or turn it off. And if I get rid of this button, you can see it's also gone in the UI. Okay, so it's interlinked with each other. And you can work with the split screen, but you can also work only in XML or in code, or you can only work in design. Now, working in design is fine, but it has its limitations, especially if you want to reproduce or recopy something such as the text view, for example. It's a lot easier to do it in here than to drag in a new text view and to, just enter all of the values again. Of course, you can go ahead and do copy and paste here as well in the design view. And then it will create a new text view. As you can see, it created this new text view, calculate your, and this one for now, or this one is now not centered. So there are multiple different ways of handling this. But what I'm going to do is I'm going to go with the next step. As you can see now, the width, it automatically changed the width. So it's not wrap content, but it's match parent. So what's the difference between those two? Well, wrap content is only taking as much space as it requires, and match parent is taking as much space as is available. So if I change the layout height from wrap content to match parent as well, can see now it takes up the whole screen, or at least the rest of what is available. As you can see, of course, our other text view still stands strong, has its space, has a little margin towards the top, and also a little distance here towards the bottom. But as you can see here, our other text view is taking up all of the rest of the space. All right, so that's the difference between wrap content and match parent. And I want to use wrap content because this will only take as much space as it requires. And in my case, wrapping the content is fine. So now you can see it also centers it again because our overarching linear layout is actually having the center horizontally gravity. All right, so it centers stuff horizontally. But it didn't do so before for our second text that we had here because the text took all of the space. So it was still centered, but it took all of the space available, at least on a horizontal level. All right, now let's change this. Let's change the text to age. And then I want to have a background here. I want to change the text color and all those kind of things. So now we can, of course, go ahead and create a new color property, or we can just enter the value here. So I want to have white text for this. And I want to have a background. So add a background. And which color are we using? Well, let's create a new color again. And I'm going to use this one, name equals age text background color. So pretty long name, but it's descriptive. And here I want to use this value here. So it's going to be hashtag C846 and so forth. So now what you see is we have even more values here. So it's not 6 letters or 6 digits anymore, but it's in fact 8 digits. So this is the alpha value then, which means the opacity. How well can you look through it, so to say. All right, so here add color, and I'm going to use the age text background color. Now, of course, you can go ahead and create another color for this one here. So color, name, and here age text color is how you could call it. So now the advantage of having all of your colors in here is that if you want to change colors in your application, you don't need to go into the XML files, but you can directly adjust it from the colors.xml file. And this is very useful, especially when you have bigger applications and when you use a certain color multiple times. If you just use a color once, then it's totally fine to just have it in your text view or in your XML file directly. You don't need to create an additional color for it. But of course, you can do so if you want to. It's just an additional step. Now let's compare this to our app that we had. And we can see that the age looks a little different. So here, if we look at it, it doesn't have that much space around it. So how do we get that? Well, we can use something called padding. All right, so padding, there's a property called padding. Padding bottom, padding end, horizontal, left, right, start, top, vertical. So there are different types of paddings. And the padding that I want to use is an overall padding, which means that I want to have paddings in all directions. And if I do so, I can just add a value in here, for example, let's say 10 density pixels. So now I get this a little distance towards the outside, so to speak. And the text now has a distance to its border. So the border is this blue line that we can see here, and we only see it when we click on it. Otherwise, it's this gray line. But this is generally the border that we have here. All right, so if I zoom in, maybe it's a little more visible. So here it is, this little gray border around it, and this padding is creating the space inside of this border. So if you want to have even more space, you could go and say you want to have 20 density pixels. Or what you can do is you can, of course, say, I want to have more padding towards the left than towards all the other directions. So here, for example, 50 density pixels. And let's get rid of this padding here. Now you can see I have a lot of padding towards the left. As you can see before, it was overriding it. So the overall padding is overriding whatever the individual paddings that you create will do. All right. So that's just an example. I will keep it with padding 10 density pixels. All right. So now we can go ahead and create this additional text that was underneath it, which said in minutes. So I'm just going to copy this text view here. I'm going to paste it below the other text view that we had. And here I'm just going to change the text to in minutes. All right, calculate your age in minutes. Then we need a button. And you can create a button by dragging it from the palette again. So open the palette, go to buttons, drag the button in there. That's one option. The other option is, of course, you create the button inside of your XML. So here, create a new button. And here it's important that you use the right casing. So button, as you can see, it needs a width and a height. So I'm just going to say the width should match its parent. So it should be a wide button, and the height should wrap its content. So it should only take as much space as it needs. Now, as you can see, the button is not really visible properly, or it is visible, but it doesn't have a text. So if you want to change that, you can, of course, add a text to it. So text. And here we're going to say select date, because once we click on this button, the user should be able to select the date. Now, here I will again add some more properties, and what's important here is that we close this button at one point. What do I mean by this? Well, we get an error here. That's because our button is never closed, our button tag. So we need this slash and the closing bracket here. All right, now let's adjust this button a little more. Let's change, for example, its margin towards the top. It should have a distance between this text and the button itself. So we can add margin top. And let's say we use 15 density pixels here. So a little distance. Then we make the text bold. So text style. Let's make it bold. Then the text size. Let's change that as well. So I'm just going to use 20 SP. As you can see, it's a lot bigger. Now, by the way, you might wonder, what is all of this DP and SP stuff? DP stands for density pixels, and SP stands for scale independent pixels. If for whatever reason I'm not explaining a term, then I either did it before or I will do it later on. So don't worry. But if I still don't do it, or if you want to know it before I explain it, and you really want to make sure you understand everything, of course you can always go ahead and Google it. That's something that I highly advise, because it will help you understand it on a deeper level with your liking, because not everyone wants to know all the details all the time. Sometimes it's a little overload of information. Sometimes you just want to get things done and want to see something on the screen, but sometimes it really makes sense to just look it up. So here, for example, if you want to know the difference between DP and SP, you can just Google it. You can see that there is a little image, and that's on Stack Overflow. So there was a question on Stack Overflow, and here it shows how those pixels are important when it comes to the UI. Here you can see the difference between a pixel, a density pixel, and a scale independent pixel. So here, these are some examples that we have here on the side. So for example, pixels directly on a small screen might look the same. So this is the default screen size that this whole pixel and density pixel stuff is based on. So for example, this is how big 15 pixels look on the screen. But if you have a bigger screen which has a lot more pixels, then the text size suddenly appears super small and you can barely read it. All right, if the screen gets even bigger, then this changes again. So as you can see, if you want to have something look the same size, you can use density pixels. And for text, you should use the scale independent pixels, which are great because What they will also take into consideration is the settings that you have when it comes to text sizes, and it will adjust it so that it looks better on the different screen sizes. All right, so if you want to know more about it, check out the Stack Overflow article. What's the difference between PXD, IP, DP, and SP? It's very well explained. And what's important hereby is also the screen density, of course, because the newer the screens are, the better the screen density is, which is measured in DPI, which stands for density pixel per inch. And a higher DPI, of course, means that the individual pixel is going to look smaller to a point where you can barely see a pixel. All right, coming back to the UI. So now we have the button, and what you can see, there's a little difference between the button we have here and the button there. So the color is different, and also there's a little distance here on the left-hand side. Why is that? Well, you could expect this to be a specific width. So somebody defined a specific width for this button. But actually what's the case is that I have a little distance around the corners towards all of the elements inside of my UI. And I can do so by going to my linear layout here at the top, and I can adjust its settings a little bit. So for example, I can add a little padding here, and let me actually do that here. Padding, and I'm gonna add a padding of 16 density pixels. As you can see now, I have this distance here towards the left and towards the right. So that's this padding here, which is our linear layout, which is the parent of all of the other layouts, which are inside of our UI in our case. All right, so I'd say we make a break here, and for you as a little exercise, please try to replicate the UI that you see here. You don't have to take into consideration what you have here at the top. So H2 minutes calculator, this text, and also this bar that you have here at the top. That's something that you don't need to take care of, but take care of the rest of the UI. So change the color of the button and the text, then add a new text here, another text, another text, and another text. Try to replicate what you have here, and yeah, see you in the next video. Welcome back. So I hope you tried to replicate this UI, to rebuild it with your own code. And yeah, let's look over it real quickly. So what we have is our first text view, which is our calculate your. Then we have the second one, which is this H, which also has a background color. Then we have a text view, which is in minutes. We have our button, and as you can see, it has a certain color. So this is this grayish color that we have here, 929292. And of course, you could export it to your colors XML file, but I kept it in here for now. And then below this button, we have this text view, which has an ID. So that's something that we haven't covered yet, or we haven't used yet, at least not for text views. So I'm using this ID in order to communicate with this text view from my code. So in my code from my mainexvideo.kt, I can now access this text view and adjust it. And it will be empty without me adjusting it in code. As you can see, there is no text in there. So there's also no text property in this text view, but we will add text as soon as the user enters a date or selects a date. All right, the text color is this dark red-ish color. Then we have a little margin towards the top. We have a text size of 20. And then we have our text view, which is just the select date text, which has also this gray color, and a text size of 18. And another text with an ID, select date in minutes, or selected date in minutes. So this is going to be the text that currently is also empty, but it will contain the actual result of the calculation of how old we are, or of how old the user is, or whatever many minutes have passed since the selected date. All right, then we have again the same color that we had before, and we have our text size of 35 SP. So this is going to be a bigger text. Below that, we also have a gray text here, which wraps the content and just says H in minutes, and is also a gray color. All right, so it's the same gray color. So at that point, you might say, all right, let's export it. So let's do that. Let's create a new color. Name is equal to light gray text color. So I'm going to call it. Of course, you could have another name here. And let's just enter it in there. And now we can replace this with add color and then a light gray text color. And the same goes for this one here. Add color and light gray text color. So we are reusing it, so why not also export it so that we can reuse it correctly. So now the colors will be the same, and if we decide to change the color here, it will automatically impact this color as well, because we exported it in here. And that's better design than having the colors individually, right? Okay, so now let's finally see how this is going to look like on an actual device. And as you can see, it's looking pretty good. The text here, age in minutes, something that I don't like that much, so maybe we want to change that. But overall, I think this is cool. The button seems to work, or at least it appears to be a button. Of course, we don't have this empty text and neither this empty text appearing here because it's empty text and we need to populate it via code. And that's something that we're going to do in the next videos. But for now, let's just change the title here. And that's something that we have to change in an actual value in our strings. So here under values in res, in the res folder, we have this strings XML, and in here we have the name of our app. So the app name is age in minutes, and of course we can change that. We can do something like your age in minutes. So if we save that and we make a quick refresh, we will see that it says your age in minutes. All right, so I hope you managed to create this UI similarly to what you can see here. And if it's not exactly the same, that's totally fine. It doesn't have to be, but it's just important that you have all of the elements in there. And now we can finally start with the actual code. So with the Kotlin code in our main activity. So see you there. Welcome back. Now it's finally time to implement functionality in our code so that our app is actually interactable. So we can actually press the button, for example. And in order to do so, we go to the main activity.kt. You can find it in the Java and then your package name and then the main activity folder. All right, so there is the file, main activity. That's what we're going to work with. And what we can see here is, of course, we have our class main activity. We have the package name here at the top. We have some imports that are auto-generated for us. And we have our onCreate function, which is called whenever our application is opening up this activity. And in our case, this is the only activity, and it's going to start with this activity. So this is our start activity, and an activity is just a screen. All right, so our activity main, this screen, will be displayed. Why specifically this XML file? Well, because we set it as the content view. So set content view, we say r.layout.activity_main, which is this activity main.xml file. All right, in here, what I want to implement is my button first. So let's just use the button date picker. As you can see, it finds this button directly. So button date picker. Let's open this. And we can now use methods on it. So for example, the set on click listener method. And here are two versions. So one with a view, one without a view, and I'm going to use the one with the view. And in here, I will for now just add a toast. Okay, so just so that we can test how our button works, or if our button works at all. Then we need a context, so I'm gonna add this as the context, which means my main activity is going to be the context in which the toast should be displayed. Then the text should be button works, and the length should be toast.length long. Let's just leave it there for a long time. And of course we need to show this. So show. Okay, now I'm going to put this into different lines. So now it's a little more readable. All right, so we can see toast make text will be displayed whenever we click on our button date picker. So where's this button date picker coming from? Maybe you wonder. Well, it's coming from our activity main. And if we scroll down to our button, we can see it has an ID called button date picker. So btn date picker, and whatever the ID here is, we can directly access it in Kotlin. That's a pretty cool thing, because in Java we would have to specifically create this object and stuff like that. So this is a lot easier in Kotlin. All right, now we can test it. So let's rerun it and let's click the button, and we can see button works is being displayed here at the bottom. So this is this little toast that we have here. It's always great for specifically those testing purposes to see if a button works or if the UI does what we want it to do once we interact with it. Next, I would like to implement my date picker. So I want to open up this little thingy which displays my calendar, and then I can select a date. So that's what I want to implement next. But in order to do so, I will just create a new function. So I'm going to create a function called click date picker. So fun click date picker. Now what it's going to require as the parameter is going to be a view. So I want this to be a view, and it should be called view. So I'm going to use view. And now I need to import view. And if I do so, you can see view has been imported. And a view could be something that is displayed on the screen. So it's just another type of element. And if you look at our button date picker, you can see the set on click listener also has a view here, it view. We're not using it, but it's there. All right, I cannot change it right now, but it's there. So when I call this click date picker in here, so let's say I want to call it in there, click date picker, what I can pass is the view. Now where's this view coming from? Well, it's actually coming from here. So I can directly say view is going to be what is handed to me by the set on click listener. Okay, so when we created it, so let me create another button date picker dot set. You can see that there are two versions. So one version was without the view, and the other one, you can see if you hover over it, it gets a view and then it executes something. So this is what this arrow behind it means. So we get a view and then we execute something. All right, and that's what we do here. We get the view and then we use the view, and we use it to call this method called click date picker. So we pass a view to this click date picker. Why is this important? Well, it will be important as soon as we use the date picker dialog. So there is a class called date picker dialog. This class allows us to open up a date picker. A dialog is a type of pop-up, and we just say, okay, please open this pop-up, which is a date picker. And here we can now go ahead and use different type of parameters that we can pass here. So what we will need to do is we need to pass something to it. So first of all, the context, and then we need to pass the date picker dialog dot on date, and this one is with a capital O, on date set listener. All right, so we need to give it a on date set listener, which needs, and we're going to use this one, which needs a view, a year, a month, and so forth. So as you can see, it requires all of those values: view, year, month, day of month. So where do we get those from? Well, the view, luckily enough, we get from our button date picker. So whenever set on click listener is called, we get this view, and we pass this view to our method or function that we created here. So this is the view that we got passed. So we can use it in here by using this keyword view. All right, and next we need a year, a month, and so forth. So let's create those. Let's create some variables, which are the value, and I'm going to call this one my calendar. And then this is going to be calendar dot get instance. This will give us the instance in which we open the calendar. So basically we are using this calendar class, which allows us to create calendar objects, which we then can use. So I'm creating this calendar object called my calendar, and I need to get a year, a month, and a day of a month. All right, so let's get the year, and we get that from my calendar dot get calendar dot year. This will give us the current year. Next, we need the month. So I'm going to create my calendar dot get, and here calendar dot month. So I'm creating this new value, this new variable called month, and the next one will be the day, which is again my calendar dot get calendar dot day underscore of underscore month. And here it's of course easier if you type calendar correctly. So now I have this view year, month, and day of month. And now we will pass those values that we prepared here over to this date picker dialog. And we do that behind those curly brackets. That's just the structure that they have built here. So we pass the year, we pass the month, and we pass the day. Once we do that, you can see that the error disappears and it seems to be fine. So I'm going to put those in different lines so that it's a little more readable. All right, so we have the year, the month, and day. So now whatever is behind this expression here will be executed once the date picker dialog is displayed. Now the thing is, I could directly display it here. So I could directly say dot show. All right, so I'm gonna show the date picker dialog once this line of code is executed. I would say it's a great time to test this. So let's go over to our app. Let's rerun the code and press select date, and you can see this is the date picker. And it took the current date, which is December the 11th in 2019, which is a Wednesday. And this is my date picker, and if I press OK, it's closing. And of course, I didn't implement anything that should happen once that happens. Okay, so select date, and you can see I can play around with it. I can select a different year, different month, and so forth. So we have this date picker dialog on date set listener. And as I said, this is the code which comes afterwards, after this dash greater sign, that will be executed. So in my case, in line 37, I can execute some code. And what I'm going to do is I'm just going to display another toast just to see that it's working. And it's going to say date picker works. And instead of running a toast here, I'm going to get rid of this line. I don't want to display a toast anymore once we click on the button date picker. I just want to display it once we selected a date. All right, so let me rerun this. So there we are. I press the button, the date picker still pops up. I select the date, press OK, and as you can see, date picker works. So here at the bottom it says date picker works, which means that this code here was executed. That's pretty cool. So let's implement the code that should happen once we run this. And what is the code that should happen once we selected the date? Well, what we want to do is we want to display the date in minutes. So it should do all of the calculation that is required to do so. So in here, instead of, in this case, line 32, I will have all of my logic that should be executed once the date is selected. And when is the date selected? Well, once we click on OK here. All right. So I click on OK, and then the onDate set listener is executed. So it's very similar to what we had here, set on click listener. So we had an on click listener which waited for the click to happen, and it listened, so to speak. And once the click did happen, it started its code. So it executed the code. And in our case here, on date set listener, this listener here waits for the date to be set in our date picker dialog, which is this little pop-up that we create here. If I press cancel, however, you can see that the toast is not executed because we didn't select a date. So we didn't set a date, and so this onset listener was not executed. All right, so that's it for now. In the next video, we are going to start to implement the logic behind it that we want to run. And I'd say see you in the next video. Welcome back. In this video, we are going to add the functionality that allows us to calculate how old we are in minutes. Because so far we saw that we can select a date, but the thing is that we didn't use it yet. So so far we only created this toast which said date picker works. But now instead of writing this text, let's try something like the year chosen, or the chosen year, maybe that's better. Chosen year is plus year. All right, let's just try that real quick, because this year here is going to be that year that is given from the set listener. So on date set listener. All right, we will have to look into that a little bit because it might be a little confusing. So let's select another year. Let's select 2017 and press OK. And you can see the chosen year is 2017. Now let's click on it again. Let's select this year and we see the chosen year is 2019. So year and month and day of month are going to be the values that we get from our set listener. So on date set listener, which we then can use in order to calculate which time was selected and how many minutes are passed since that moment. All right, what's important is that the year that we created here is not this year. The month that we created here is not going to be this month, and the day is not this day. But they are the variables that we use here at the bottom. So we pass them to the date set listener as the value that should be set in the moment that the date picker dialog is opened. Because if you look at it, once you open it up, it uses the current date. And we got the current date by creating those variables and we pass it there. But the ones that are the result are the ones that we get from here. So we get the year, the month, and the day of the month. So now let's make this text a little longer, where we actually write a little more. So plus, or maybe we should use string interpolation. So this is going to be the year. The month is month, and the day is day of month. Okay, so now we don't need to have this year there anymore. And of course it's day of month. All right, now if we run it again, let's see if we get the full detail. All right, let's select a date. Let's select the 10th. The year was 2019, the month was 11, the day was 10. So the day was okay, but for some reason the month was not okay. Why is that? Well, the month starts at 0. So we need to take that into consideration. For some reason, Java decided, or Kotlin in this case, decided that it would make sense to calculate the month starting from 0. So if I select January 1st, you can see the month is 0, the day is 1. All right, so that's something that we have to be careful with. All right, but now we see that we get those values and we can use them. Now, knowing all of that, maybe it makes sense to change the names here. So instead of having year here, we can call this one selected year, and this one here selected month, and selected day of month. All right, that will be a little clearer. to what is happening. All right. So now we can go ahead and calculate based on those things. So first of all, I'm going to create a new variable here, which is the selected date. So I'm going to say val selected date is equal to day or selected day of month, then slash $, and here we could say it's the selected month, but the problem is it's not really, because as we saw earlier, selected month is not the correct value. It starts from 0. So what we need to do is we need those additional brackets here, those curly brackets, and then we can do the calculation. So we can just say selected month plus 1, and then slash selected year. So of course the $sign here as well. So the structure will be day, month, year. Of course, it could be a different structure in different countries, but we will see how we can take that into consideration. So now what we can do is we can change the TV selected date. What is the TV? Is it the television? No, it's actually our text view. So now we can go ahead and set its text to our selected date. All right. So let's have a look at our activity main just to see what this TV means. So we had this selected date, but on top of that, we had this TV selected date. So this text view that was empty so far. Now I would like to access this string or this text view and adjust it. So if we run it again, we will see that it will display the selected date here. There we are. So let's select the date. I'm going to select today, and it says 11/12/2019. Now let's select that and bring it into a right format. How do we do that? Well, there is something called simple date format. So there is a class that allows us to format dates, and it's called simple date format. And what we can do is we can simply say this new object that we create, SDF, simple date format, that's what I use this shortcut for, is going to use this simple date format class, and we can use the Java version. So there are two, the Android and the Java version. I want to implement the Java one. So here at the top, it should say import Java text simple date format. And now we need to pass a pattern. So the pattern should be DD standing for day, day, MM standing for month, month, and year, year, year standing for the year with 4 digits. Now, month, month with capital M's, DD with lower caps, and Y as well with lower caps. You can, of course, use also other patterns if you want, but that's just going to be the pattern that I'm going to use. And here, you can also pass a locale. You can just say, okay, I want to use the English locale. So this is going to be an English app, so I use the English locale, which means that it will build the format of the date in a structure that is common in the English language. Now what I can do is I can use this format, the simple date format, in order to format my selected date. So I can go ahead and say val date, or let's call it the date, is sdf.parse selected date. So the selected date, as we saw earlier, is the day of the month plus 1, and the selected year. And now we parse it into a date object, which means that the date will be of type date. So of this class date. All right, so Java util, this class here. So this will be an object of type date. And we parse it, which means that we convert it from a string that we had before, because this is a string, into the format of a date object. And we use the date format, simple date format here in order to do so, because simple date format, this class, contains a method called parse. In case you ever see a class that I'm using that you don't understand and you would like to know more about it, and the explanation that I'm giving is not deep enough, then you can always check out the documentation. For me, the biggest challenge in creating such a course is always to find the right balance between going deep enough to give you enough of an understanding of what is going on and not going too deep to the point where I start to bore you with all of the information and generating an overflow in your brain. So that's really not my goal. I want to teach you everything, but it has to go with the right pace, and it's difficult to find the right pace for everyone, but I'm really trying here. And that's why I recommend to those who really want to know everything to check out the documentation in between every time. So you can see simple date format is a concrete class for formatting and parsing dates in a local sensitive manner. You can also see what the patterns are. So M stands for month in a year. This capital M. And we have D is the day of the month. But D as a capital D is the day in a year. So you can see capitalization really matters when it comes to this simple date formatter. And of course, the date class could also be interesting. So if you want to know more about the date object, and here we have two different ones, util and SQL. You can always check out the date class, and here you can see what the date class does, how it's implemented, and so forth. Generally speaking, you can see you can create objects of date with a long date, which is a long number. Then with the year, month, and date, year, month, date, hours and minutes, even seconds, and so forth. So different structures to create a date object. And that's exactly what we're creating here. So we're creating a date object based on whatever is the result of simple date format, which returns, or this parse method here returns a date object. And that's what we store in the date. All right. I'd say we make another break here because the video otherwise will get too long. So I'd say we do the final calculation, and it's really not that much left, but we do the final calculation in the next video, and there you will see how you can go ahead and display the age in minutes. Welcome back. In this video, we are going to finalize our calculation, and we will finally display the age in minutes. And therefore, we're going to use this date object that we created, and we will first of all get the date in minutes. So val selected date in minutes, and that will be the date dot time. So I want to have the time of my date. Now you can see that time is in purple, and you can press the control key and hover over it and then press on it, and it will open up this date.java file, which contains this get method, which is called getTime, which then returns the getTime implemented, which then looks at if the date is not normalized or not null, then it will normalize it and return fast time. What does all of that mean? Well, it will return it in a certain format. It will return it in milliseconds. So if you want to get seconds from milliseconds, we divide by 1000. If you want to get minutes, then we divide by 60,000. When we do so, and we hover over our date, the date, we can see that it says unsafe use of a nullable receiver of type date, which means that the date could be null and could be empty. And if that's the case and we still want to use it, we can force unwrap it. We can say, okay, the date is going to be a date object and it's going to work. So please go ahead and accept it. And we can do so by using the double exclamation mark here. This is, of course, tricky if the date is in fact not correct. So if the date is in fact empty, or parsing the selected date that we selected doesn't work, and so forth. So for example, if we made an error when entering this value here, we have to be, of course, super careful. So this is something that you should only do if you are certain that the values that you have there are correct. Otherwise, you can, of course, build a whole try and catch block around it to check if everything is fine, and only execute it in a safe environment. But we're going to keep it simple for now. We can just say, okay, we force unwrap it. We say, okay, the date is having a value and we want to get the time from it. And then we want to divide that by 60,000 in order to not get the milliseconds, but the actual minutes, which have passed from the moment 1970, 1st of January, to the moment of our date. Because if you again look at the documentation, when we use .time, the getTime method is called, and it returns the number of milliseconds since January 1st, 1970, represented by this date object. Okay, so that's what I was just talking about. All right, so this .time, as we saw earlier, calls this getTime method, which then in turn returns the time in milliseconds from 1970 to the moment of the state object, which is in my case the 12th of December, or actually the 11th of December 2019. So now that we know how much time has passed between the moment that was selected and 1970, we can also calculate how much time has passed between now, the current day, and the 1st of January 1970. Okay, so we can go ahead and get the current date. Val current date is equal to sdf.parse. And now we need to format system.current time in millisecond. So what I did here is I summed it up in one line. So here we did it before, we did it in multiple lines. So first we did get it in a certain format, and then it was transferred into the right format, which then was in turn transformed or converted into a date object. All right. So here we bring it into the right format, then we bring it into the date object type or into the date type, and we store it in current date. And now we can go ahead and calculate the current date to minutes, which is going to be the current date, which if you look at it here, by the way, current date, it says date question mark, which means that current date is an optional or a null type. So current date, here we need the double exclamation mark again, dot time divided by 60,000. And now we can go ahead and calculate the difference. So val difference in minutes is current date to minutes minus selected date in minutes. And actually, let's keep the same naming. I'm going to use date in minutes here. Selected date in minutes. And yeah, that's it. So now we have the difference in minutes, and which means we now have the value that in fact is the age in minutes. So we can use selected date in minutes, our TV, our text view, which is this text view here at the bottom. So let me scroll the way down here. This one, TV selected date in minutes, which is this text view that is bigger with 35 SP, but which currently is empty. Now we can go ahead and set its text to our difference in minutes. And of course, this has to be a string. So to string, just to make sure that it has the right format. All right. And now we can go ahead and test this. Let's just see. All right. So let's select the date. Let's say we select the 10th of December. And the age in minutes is 1440, which is 1 day. So 1 day is 1440 minutes. So let's say I select my birth date here, which is the 31st of May 1988. And I can see this is my age. All right, and that's it. That's our application. As you can see, it works fine. Now let's check what happens if I select the wrong date, for example, something in the future. Then we get a negative value. So we are minus 2,880 minutes old. That's something that you can, of course, use for countdown timers or something like that. But our app is really there to calculate the age in minutes. So doing something like that where we have negative values is not gonna cut it. That's not the right way to do it. So what we can do is we can store this whole date picker dialog in a variable. So I'm just gonna say val dpd, which stands for date picker dialog, and then instead of showing it directly here, I'm just going to first of all limit this dpd, or set a setting there. So I'm just gonna say dpd dot date picker, and here I can set the max date, and it will be date.time minus 8, 6, 4, and 5 zeros. This is just the milliseconds of one day. And in the next step, I will show the DPD. So our date picker dialog. Now let's test this again. So let's select a date in the future, and as you can see, I cannot do it. So it doesn't even offer these dates. So it's limited to the past, and I cannot use the future. And how was that possible? Well, it was made possible by setting the max date to the date.time, which is the current time, minus 1 day. So we can only select yesterday as the latest moment. All right, so that's our little app, and it took a little longer than I expected, but that's because I really went deep into depth here and I really explained very many details. And yeah, you can of course always download the application, or better said, the project. And there you will find that we have many comments which explain what's going on there and why the code is as it is. So you can just download that, and that will definitely help you to understand what's going on if something is unclear. There might be some names which are a little different. Maybe I decided to change the names while I created the recording, but overall it's pretty much the same code. I hope you take advantage of this, and of course also of the documentation, because it's super helpful to understand what's going on. All right, so I hope you enjoyed this chapter, and yeah, see you in the next one.
So there we are. We're done with our first real application, so to speak. So we built our age in minutes app. So now you can use this app and share it with your friends, show them how it works, show them how old they are or how old you are. You've seen how to use classes, you've seen how to use date pickers, how to build your own UI, how to use text views and buttons, and how you can communicate with them via code, as well as you looked at how to use a bunch of built-in code that you don't need to write yourself, but you can just reuse it, such as the date picker. So we use the date picker in order to select the date and then get the data in a format that we can use in order to calculate how old we are in minutes, and then we return that. All right, and also I hope you tried to finish the challenge where you had to just change the code so that it would now display the age in days. And now you can play around with this application however you want. And yeah, thank you very much for being part of this course, for being with me. And in the next chapter, we're going to build a more advanced application. So it's going to be more advanced now every single time. All right, so see you in the next chapter. Welcome to the calculator app. This one is probably the most boring application that we're going to build, but I still think it's an important one because it teaches you so many different things about Android development, about how to build a UI that really works the way you want it. So it's going to be a lot about creating a UI that just works, right? Just positions everything correctly. We are going to use a bunch of new features that you have not seen before that you will then reuse in other applications in the future. So it's a classic. It's rather boring, but still I think it's a good start to get used to a bunch of new features. So you will learn more about linear layouts, about the on-click event. You will play around with strings and see how you can manipulate them. Then we are going to look into mathematical operations, because basically that's what's important in calculators, right? And that is of course an important basis for our next applications. Okay, so let's get started and see you in the next video.
Welcome back. In this chapter, we are going to build a calculator. and I want to show you what the calculator can do and what it can't do. So there are some limitations here, and the idea behind this calculator is that you learn to build complex UIs, so to speak. So a complex user interface, which means the graphical user interface that we can see, all of those buttons positioned correctly with the right distance to each other and so forth. Because as you can see, they are all equally distant to each other, and the text is all the same size and so forth. So this is something that you have to take into consideration when building such a UI, that it looks good. And it's really a rather boring example, of course. Calculators are super boring in my opinion, because it's just an app that everybody has on his phone anyways, but it's a very good example for building such a UI. And it's also something that you probably get quite a lot at university. So if you ever go to university and have IT there or programming, then it's very likely that they will ask you to build a calculator, or you build a calculator at one point in university. And because this is a rather early stage in the course, we're not going to use third-party libraries for this. We're just going to use basic code, and that will also limit the functionality of our calculator, because we cannot use super large numbers and we cannot use super precise numbers either. So dividing is going to be a huge problem for our calculator. For example, if we divide a value here, you can see this is the result that we get. And now if I want to do any additional calculations afterwards, it won't work, because the application is limited to 12 values here, or to 12 digits, so to speak. All right. And if I clear and then I do some other operations, you can see I can do multiple operations after another. It's no issue. And all of them work fine. But as soon as I have a huge number or a very long entry, as you can see here, then it gets limited. So now I cannot do anything with it anymore. At that point, I have to clear my calculator. So that's just a limitation of the data types that we have as well. So for example, the double, the int, the longs, all of those data types that we're using, they are limited to a certain amount of digits, and that's what we have limited it to, just 12, to make sure that everything is still gonna work. Of course, we have to be careful. Dividing by 0 is always a problem, so we get the result of infinity. All right, so at this point, you can try to build this UI yourself. And many things could go wrong, but that's no problem. If you want, just go ahead and try to build this UI. Just an advice from my side, use linear layouts. So don't use the constraint layouts where you just drag stuff in there. Of course, you can do that and it might work as well, but it's going to be a pain to make everything equally far from each other and really well positioned. So I would really recommend to go ahead and use linear layouts. So how we're going to do it is the whole thing, the whole app is going to be within a linear layout. Then we have a text field here at the top, which takes quite some space. Then we have a linear layout for all the buttons here. So for one row, or each row will be a linear layout, which contains the individual buttons. And then we have a linear layout, which contains all of the different rows. So that's pretty much it. In order to get the double width here for a button, what you can do is you can use a functionality called weight. So layout underscore weight. That's the property that you have to work with. So for example, the 0 button has a layout weight of 2. All of the individual buttons, they have a layout weight of 1, and the equal sign. You could think that it has a layout weight of 4, but it actually also has a layout weight of 1 because it's the only element in that row. Here we can see there are 3 elements. So the 0 has a weight of 2 and each of those buttons has a weight of 1. So the 0 will be as thick as or as wide as 2 other buttons. The same goes for the individual rows. So each row is equally high. So they all have a layout weight of 1. So they are equally tall or equally high. All right. So this is just a little side note. If you want, you can go ahead and try it yourself. If you do, then good luck. And if you don't want to do it, if you just want to watch the videos, then of course you can do so as well. And in the next video, I'm going to show you how to build that. Or I will show you one way of building it. Of course, there are multiple different ways of building this UI, and maybe you have a even nicer version or something like that. So I hope you enjoyed this little exercise and this little app, and see you in the next video. Welcome back. In this video, we are going to add a little functionality to our calculator. For example, I would like the text to be displayed here in this text view, which currently is empty, once we click something. Because for now, it just says button works, which is what we had in here, this toast. But we're not going to need this toast anymore because we know that this button works. And how did we implement this functionality? Well, we went to our individual buttons, and then we gave them this onClick property and assigned a value here. And the cool thing is it will automatically know, okay, once I click on this button, I should run this onClick event, which is called onDigit. Now the thing is, it will automatically run this onDigit function, which needs a view. And this is generally the structure how we can implement those functions, which need to be run with buttons. So the view is going to be the button itself. So it's gonna know what kind of button was pressed. And how is that important? Well, it's important because I would like to know what button was pressed. So I would like to have the value that is inside of that button. All right. So for example, the text that we see there, for example, 1 or 2 or 3. And in order to get them and to display them on the TV input, which is our text view that we created at the very top here, this text view, and had this ID TV input, I would like to set its text dot text. So that would be one way. The thing is, I want to actually not only set the text, but I want to append something to that text once we click on it, a button. All right, once this onDigit function is called. So I'm just gonna append a text here. So let's just say we append test to it, or I'm just gonna say 1. All right, just for now to keep it simple. Now this TV input is causing an error. It says I need to import it. Well, in my case, I had to import it because it comes from my activity_main. So in case that's required for you, you can just go ahead and do so. Now we can test if this is actually going to run, because now the only difference really is that once we click any of the buttons that has onDigit implemented, and I think is all of them except for the equal sign, then the button should, or the text should have a 1 on top here. You can see there they are. So it adds ones up to the point where there are 12 values in there. Why 12? Well, because we limited it to 12. So we said max length should be 12. So now only 12 entries should be made in that text. So now instead of just appending a 1, I would like to append whatever is written inside of the button as its text. So in this case, the 7, once I click on the 7, the 8, when I click on the 8. So how would I do that? Well, the thing is, I can get the text from the view, but the view is of a different type than the button itself. So it's of a parent type. So the button is inheriting from view. So what we can do is we can cast this. So we can say view as button, and then I would like to have the text from you. So now I need to import button as well. But as you can see, now I get the text from a button doing so. We can test that real quick just to see if it's actually what I'm saying it is. So I'm going to press a bunch of buttons, and as you can see, they write whatever I enter. And of course, they're limited to 12 entries again, or 12 digits, or letters in this case. Now, the next thing that would be rather easy would be to implement the onClear functionality. So the functionality that should run once we clear, or once you click on this clear button. So please try to implement that. Just as a little hint, you need to set the text to empty, or to an empty string. All right, so I hope you tried it. I'm going to implement it, and I'm going to call this one onClear. And again, we need to pass a view here, or actually we need to get a view once we call this onClear. And that is automatically done, so we don't need to do it ourselves, but we still need to implement it here if we want to use the onClick functionality for one of our buttons. And the one that I want to use it for is the CLR. So I'm just going to click on the CLR here, and I'm going to call the onClear function here. So once onClick is called, so once we click on this clear button, onClear should be called. All right, so now here, of course, we need to set the TV input dot text to an empty string. And that's already it. So let's try this. And in my case, just running restart didn't work because we also changed the XML file. So doing a proper restart is what is required. So there we are. Let's just smash some buttons and then press clear. And as you can see, the text was fully reset. All right. So that was the first little step to our application. I'd say we check out the on decimal point functionality and the on operator functionality in the next video. So see you there. Welcome back. In this video, I would like to implement some more of the button functionality. For example, once we click a decimal point, I want this to be displayed correctly, because the problem is I cannot use a decimal point multiple times, right? At least in a calculator, you shouldn't be able to do that. So what we want to do is to display a decimal point, but only one at a time, because only one decimal point will be possible at once. In order to do so, what we will need to do is we'll need to add a bunch of helper variables, or 2 helper variables to be precise. And I'm going to create one that I'm going to call last numeric. So this one will contain the information if it's containing a numeric value or the last button that was pressed, or if it doesn't. All right, so last numeric, and I'm just going to say that it's a Boolean, even though it's not necessary, but it's going to be a little clearer what's happening here. And then last dot, which also will be a Boolean, which I'm going to set to false. But as I said, this would not be necessary, this Boolean keyword, all right, because as I'm using false here, it will know that last dot should be a Boolean. All right, next, what I want to do is I want to implement this little function. On decimal point is how I'm going to call it. So fun on decimal point. And as it should be run once we press the button, we need to have a view as its parameter. And then we want to check if the last button was numeric and not last dot, which means that we only want to run something if the value before was actually a number and was not a dot before that. All right, and then I'm going to use TV input dot append, and here I'm going to add a dot. So what's important now is that once we do that, we set last numeric to false, because now we had a decimal point that we used as last button that we pressed, and at the same time last dot is set to true, because now we actually have pressed the dot, or have created a decimal point there. So we need to set this variable to true. Now of course we need to implement this, because as you can see, this is a yellowish color and this is a gray color. This means that this functionality or this function here is never used. And that means we need to implement it somewhere, and that would be this point here, this dot. So instead of on digit, we will use on decimal point. All right, so now let's run this again. There we are. Let's try to press the dot. As you can see, nothing happens. Now let's press 5 and the dot. And nothing happens as well. Why is that? That is because we also, of course, need to set last numeric to true once we press on the digits. So here, last numeric is going to be true. So we are setting the flag of last numeric to true, and that's this Boolean that we had here, which just stores the information if we pressed a digit or another button, for example, the decimal point. All right, running it again. Let's test it again. So the dot didn't work. Let's press the 5 and then the dot. Now it works. Now let's press the dot again. As you can see, it doesn't work. So it only works once. And now, of course, when we clear, you can see now it's still not working. That's because we never said that once we clear that we reset everything. So what we need to do is on clear, we need to set everything back. So what I'm going to do here is I'm just going to say last numeric is going to be false and last dot is also going to be false, because that was the initial state that we had here at the beginning. And we also need to have the same state once we press on clear. So now if you run this again, we will see that, let's say we enter a value here, we cannot press the dot again. Let's clear and now press the dot, and as you can see it works totally fine. But here at the beginning it doesn't work. Only after I have entered a value I can add the decimal point. All right, so that's it for now. I'd say we check on operator. So once we press one of those in the next video. So see you there. Welcome back. In this video we are going to finalize our app, and you can of course do so yourself if you want. You can try and implement the rest yourself. So the only thing that we will need to do is we need to copy and paste our if statement here for the different operations. So we have this try statement where we have our if statement where we check if we have a minus at the beginning, and other than that we just do a calculation. So what I'm going to do is I'm going to add an else block here and another else, or it's else if to be precise, and then we finally have the last else if, and it can contain another value here. So let's say we have a multiplication, then I want to use an asterisk. Then if we have a addition, I want to use a plus sign. So let's replace all of those aspects with a plus. Then finally, if we have a division, then we should use a slash. So now we should have all of the calculations. Let me see. Actually, one is missing, and that's the -1. So now we have all four of them, all of the four operations. And now if we check it, it should work fine with all of the different operations. So let me check. Times 6, we can see that works. Then minus another value, that works as well. Divide by 10. Well, that seems not to work. So let's check what's wrong with the division. Do we have division here? We didn't have the slash in there. So I forgot this one slash. Let's run it again. All right, so there we are. So -3, that works. Plus 66 works. Multiplied with 6 works, and division by 10 works as well. All right, so now all the operations work fine. Now let's say we get a negative value again. All right, there we are. And now we multiply with 6, and well, there is the limitation, and that has to do with the limitation of letters that we want to display here. In our case, it's not letters, it's mainly digits, but basically this is a string, right? So all of them are characters in here. There is one more thing that I don't like about this application, and that's that it shows too many zeros after it calculates something. So here we have 34.0. So this 0.0 doesn't add any value. So how can we get rid of it? Well, I'm going to do it with a function. So I'm going to create a new function here, fun. And maybe I'm going to even make it private, because it's really just going to be required in here in our main activity. So remove 0 after dot is how I'm going to call this one. And it needs the result, which is of a type string, and it's going to return a new string. So that's the idea. It's just going to cut the old string a little bit. So first I create a new variable called value here, which is going to be our result. So we just put the result into this new variable called value, and then we check if result contains .0. If that's the case, then set the value as result dot substring. So we use the substring functionality, which allows us to have a start index and an end index. So we used substring before, but we didn't do it like this. So result dot length -2. So what I do with this is I just say, okay, use the string as it is, but get rid of the last two characters. So for example, if I have something like 99.0, the last two characters will be this one and that one. So the 0 is the first part of the string, so which is this 9, and then the 9 is the second, so the overall length is 4. So if we look at the indexes, let's do it like that, maybe it's easier. 0, 1, 2, and 3. So this is index 0, index 1, index 2, and index 3. And what we say, start at index 0, and then stop at the length, which is 4, -2. So stop at 2, excluding, which means we get rid of those two, and we just leave 0 and 1. Okay, so that's what this substring does. And now what we can do is we can just return this value. Now we can remove 0 after dot each time that we do this calculation here. So each time that we finalize this calculation, we can do it. So I'm going to do it for the whole string. So we need to have an opening bracket and a closing bracket. All right, so that's pretty much it. So I'm just going to copy and paste this for the other operations. And of course, I need to be careful with the operation itself so that it maintains the old value. So here it has to be a plus. And once again here. So why can I do that? Well, that's because we have this being a string. So we just pass a string to remove 0 after dot. If we look at our function, we can see that it requires a string, which is the result. And if we look at it, this is the result of our calculation, right? And we put it into our TV input. Okay, so one last thing is left, and that's our division here. Actually, it's not division, it should be minus here. Let me check if all of them are fine. Plus, minus, and so forth. And as it seems, I have one of those too many. So I'm going to get rid of this line of code, or this whole block, which didn't do anything because we now have 4 of them, right? So we have contains minus, contains slash, contains plus, contains multiplication with asterisk. Okay, now let's try it again and see if we have gotten rid of the unnecessary 0 there. All right, so 99 minus 66 is 33. So now we don't have this dot 0 anymore. So now one last thing is left to do, and that is to change where the text is positioned, because it's always positioned at the top left, and in the application that I showed you at the very first video of this chapter, the text was here at the bottom and it started at the bottom right, which is very common for calculators. So let's just change that real quick, and that is this text view that we need to adjust for that. And there are multiple things that I want to add. One of them is a little padding, because the text starts right at the corner. So here, right at the edge, at the left edge. So I will add a little padding. Let's say 10 pixels, or yeah, 10 density pixels should be fine. And then I will also add a gravity. So this gravity, not layout gravity, but the gravity where I actually say to which corner it should go. I want this text to gravitate towards the right, center, vertically, bottom. All right, so if I do that, now if we have text in there, it will go towards the bottom right. So the thing is, it's a lot easier if we set the text to, let's say, 0. So now you can see where it's actually going. So now let's get rid of all of those just to see how this will position. So now we'll position it at the top right. And here, if I add bottom, you can see it's positioning it at the bottom right. But then if I add center vertically, then the text will be centered vertically once we have a little more text in here. All right, so let's run it again just to see what this looks like. All right, there we are. So let's do the calculation. All right, cool. As it seems, our application works fine. And of course, if we have too long of a number, then our calculation will not work anymore because it's not adding any additional text to our text view. Because that's really the limitation of our text view, which we assigned here with max length 12. And that has to do with the data types having a limitation of how much data they can actually store or how long numbers they can store. All right, so I hope you enjoyed this chapter and I hope you tried some of the exercises yourself and built a little something. And yeah, see you in the next chapter where we're gonna build the next app. So thanks a lot for being part of this and still being around.
We're done with our calculator. So now you can build your own calculator. How awesome is that? Well, I think it's not that awesome. I think there are a bunch of cooler things that we're going to build in the next few chapters. But still, it was important to go through it. It was important to learn how to use linear layouts, how to use the features that we have used throughout this chapter. And you have seen how you can use linear layouts, how to build your own UIs and more advanced UIs, so to speak, because there was a lot going on, right? A bunch of buttons, a bunch of information that you want to display, added texts and all those kind of things. And we looked into playing with strings. We also have checked out mathematical operations because, well, it's a calculator, right? So you will need those. And we built an important fundament for our next application. So we're going to use quite a lot of what you have learned in this chapter throughout the next chapters. And it's going to be a lot cooler than what we have built yet. Okay, so thanks a lot for being with me and see you in the next video.
Welcome to this quiz chapter. In this chapter, we are going to build a little quiz app which allows us to learn a bunch of new functionality that we have not used so far. And we are also going to use very important concepts that are really generally important to understand when building any software, pretty much. So not just apps, but generally when building software. All right, we're going to start with this little screen that you can see here where you can enter your name. So I'm just going to enter my name in here. I'm going to press start and then the quiz starts. So it's going to be a very basic quiz app, but this will still teach you a lot of new features. So let's get started. You can see here what country does this flag belong to. Then we have a little image here, a progress bar here, which indicates how far we are in the process. And then we have a bunch of options here at the bottom. For example, this is Argentina, so I can submit and I get a result here, which indicates whether my answer was correct or not. Then I can press go to next question and the next image pops up with the next question, which is the same question. So in this case, I'm always using the same question just with other images and other responses or possible options here. And this is going to be a blueprint of an application that you can just build your own of. So you can just go ahead and make your own quiz app from it. And you can just create 100 questions, for example, and then just build this little app based on what you will learn in this chapter. All right, so let me select a incorrect answer here. So I'm going to say this is Austria, even though that's Australia. So I'm going to press submit. And as you can see, Austria is red because that was my initial answer and Australia is going to be correct. All right, so going through this, I will in the end have a screen which will tell me how many times I was correct with my response and so forth. Oh, that was actually Fiji, good to know. Germany, then we have Denmark, India, this should be New Zealand, and That's a tough one. So actually it was Kuwait. All right. And there we are. So you can see your score is 7 out of 10. And that is our congratulations or our result screen. And then we can press finish, which leads us back to the home screen. Now you can of course go on and try to build this yourself, at least the UI from it. And that would already be quite a good step to get started and to practice and learn. And then of course we will build this together in this chapter. So I'd say let's start with this screen in the next video. See you there. Welcome back. In this video we are going to start with the start screen or the main activity of our application of the quiz app. So let's get started with this empty activity when selecting a new template for the project. So I'm just gonna press next here and going to call this one quiz app. Everything else can stay the same. API should be 21 and then press finish. So let's test this application on our device just to directly see what we already have. So this is the app that we have right now, and let me turn it around. As you can see, it's not turning. That's great because that's exactly what I wanted. I don't want it to turn, but if you really want to make sure that it's not going to turn, you can go to your Android manifest and then add a new setting here to your activity. And when it comes to the screen orientation, you have many different options here. You can read through them in the documentation. The one that I want to use is the portrait one, so only the portrait orientation will be accepted in my application. So here, I'll just add a screen orientation setting, and I'm going to set that to portrait. Now, even though it's complaining, I'm still going to leave it as that because it's still going to work totally fine. Then I would like to assign a theme here, and the theme that I want to use is one that I will create myself because I want to have control over the style of this action bar there at the top. And how can I do that? Well, I can go to my values, and then there is this style XML file in which I can create different styles. For example, you can see there is one style already with a dark action bar, and now we can create a light action bar as well. So I'm just going to do that. I'm just going to create a new style here, which I'm going to call no action bar theme. And its parent is going to be theme.appcompat.light.no action bar. So this will be the parent theme. So we are going to pretty much use this theme here, but we're going to adjust it slightly. Okay, so the things that I want to adjust here are the colors. So as we can see here, there are 3 colors which are set in there, and I want to do the same here. Now you might wonder, why would we even do that? Well, the thing is, I would like to have no action bar in my main activity. So here, this main activity, our first screen, should not have an action bar at the top. But still, if I use this theme as I define it here, so when I now go ahead and use my no action bar theme that I just created, which is in my styles, this one here, when I use that, then it still needs the default colors. And these are the default colors. So the color primary will be used from our colors, which in there is also called color primary. Our color primary dark, which we set for this theme, will be defined in this color primary dark. So even though the names are duplicative, it's still very important to distinguish. So in this style, we can define those 3 colors, but we could choose different colors here for this particular style. Okay, but we're going to use still the same colors as we would use in a default theme that we have here, but we are going to use the parent, which is the no action bar style. Okay, and if we still want to have an action bar, then we can go back to our default theme that had a dark action bar at the top. So coming back to our manifest, you can see it's complaining here because we need to add style and then the no action bar theme, this one here that we created ourselves. And then the next thing that I need to assign here is to add the Windows soft input mode. And here I'm gonna use adjust resize. So what that will do is it will resize our UI so that when the keyboard comes in, so the soft input, which means the keyboard of Android, when that comes into play and is visible on the screen, that our UI will be resized, adjusted and resized so that it still fits on the screen and still looks good enough so that we can still see where we are actually entering a value. There are multiple options that you have here. You can see state visible, adjust resize, and so forth. So multiple different options, and what they pretty much do, how the main window of the activity interacts with the window containing on-screen soft keyboards. And the setting for this attribute affects two things: the state of the soft keyboard, whether it's hidden or visible when the activity becomes the focus of user attention, and then the adjustment made to the activity's main window, whether it is resized smaller to make more room for the soft keyboard, or whether its contents pan to make the current focus visible when part of the window is covered by the soft keyboard. Okay, because sometimes when the part of our activity that is relevant for the user to enter data, for example, a text field where he needs to enter something, so an edit text, and the soft keyboard is on top of it, then you cannot see what you're typing. And that's something that we want to avoid. All right, coming back to our project here, there's one more thing that I would like to set up for this video, and that's going to be our Gradle. So in our Gradle scripts here under build Gradle in the module app, that's where I want to add another dependency. So I want to use the dependency of Google, which is the material design. So here I'm going to add implementation apostrophe com dot google.android.material colon material colon 1.0.0. All right, so this is what we need in here. And once you enter a new dependency, what you need to do is you need to sync now. So this feature here with the dependencies is a pretty powerful tool. So we are adjusting our Gradle, and it will then download necessary dependencies and the necessary code, so to speak, that we can then reuse. So it's going to download libraries for us, which we then can use. And in this case, we're going to use the Android Material Design library. All right, so that's just the preparation for the next video, in which we are going to then set up the whole style of this activity main XML file, because currently the only thing that we see in here is this hello world text view, and I would of course like to change that and create a beautiful screen in here. All right, so see you in the next video. Welcome back. In this video we are going to build this screen that you can see here, where we have this little text here, then another text, an edit text, and a button here which is inside of a card view. So this part here, which is white, this white background, is a card view. So at this point, I think you should be able to build this UI yourself. At least try to build it. Give it a try, pause the video, and then try to build this yourself. And then, of course, you can check out the video how I have done it. All right, so I hope you tried it. Of course, you would need this background image here and the color. So that's something that you could have gotten from the project itself, or of course, you could have used another image as the background, but generally speaking, the rest should be something that we have seen already multiple times. So let's just build that inside of our activity main. So something that I didn't tell you, and that was on purpose, is that I don't want to use a constraint layout, because everything in our UI is built on top of each other. And that's why I think it is much easier to use a linear layout here. Of course, you could have used a constraint layout and drag all of the UI elements that you need inside of this view, but I personally really prefer the code because you are much preciser this way. And let's go ahead and use a linear layout here. And then, of course, we need to adjust some settings here for this linear layout. So I'm going to set the gravity to center so that everything is centered on a horizontal way. And then I'm going to set the orientation itself vertical, so that everything is on top of each other. So now if I go ahead and duplicate this text view, then I will just have two text views which are on top of each other, as you can see here. All right, so that's what we get through using a linear layout where the orientation is vertical. Now, as the background of this, I want to use a beautiful image, and you could have downloaded this image from the course. So I'm also going to just paste it into the drawable folder. All right, now let's see how it's gonna look. And actually, I haven't set that up yet. So here, that's going to be at drawable ICBG. That's the one. Now let's look at it. And we can see we have the background already. And then I want to use this quiz app text, or have this quiz app text there. So let's implement that. It's going to be a text view. It's gonna match the parents in terms of its width, wrap the content in terms of its height, and I'm going to give it an ID so that I can talk to it if necessary. So here, ID, add ID, TV underscore app underscore name. So TV standing for text view. Then I don't need to have all of these constraint elements because we're not using a constraint layout. So let's get rid of all of them. As the text, I would like to use something like quiz app. Then I want to have a little layout margin bottom, so some space towards the bottom of, let's say, 30 density pixels. As the text size, I'm going to use 25, so 25 SP. Then the text style should be bold, so you can also see that this text is pretty bold here. And as the text color, I'm going to use white. So text color is going to be at Android color / white. All right, let's look at it. Right now, it's just going to be this text here. And yes, you can see it's not centered. So I would like to center it. How do I do that? Well, I use the gravity here. So here, Android gravity center. Let's look at it again. And now the text is centered. Underneath it, I would like to have this card view. As you can see, there are multiple different elements inside of this card view. For example, welcome, please enter your name. So text view, added text and button. So let's get rid of this text view here and instead add a card view in there. And that one is from Android X widget card view. Here the width should be match parent, so it should take the whole width, and the height should be wrap content, so it should only take as much height as it requires. Then I'm gonna assign some more settings in here. So for example, I want to have a little margin towards the top, and I get that by using margin start here. I'm gonna say it should be 20 density pixels. Then also some margin towards the end, which will be 20 density pixels, so it will be towards the right hand side. And then I'm gonna set the background to a white color as well. So here, Android color / white. Now what you also can see here is that this card has rounded corners and that there is a little bit of shadow that this card creates. You can barely see it, but still, if it's not there, you will see the difference. So currently the card is empty. That's why we cannot really see it, but let's add the card corner radius in here, which I'm gonna set to 8 density pixels, and the card elevation, which will create this shadow of 5 density pixels. Now let's fill this with some values in there. So I want to have texts on top of each other, as you can see here. So I will need a linear layout with the orientation being vertical. So let's create that. Linear layout with the width of match parent, with the height of wrap content, with the orientation of vertical, and the padding, because I want to have some space inside, so a little bit of padding of 16 density pixels. Now in here I would like to have text views. So let's go ahead and create a text view here, which has a width of match parent, a height of wrap content. So you can see it's most of the times like this, wrap content, and then some more settings here. For example, the gravity should be that it's centered, so the text should be centered. The text should be something like welcome. So I'm going to set that to welcome. The text color. And here I'm going to use a color 363A43. And it will be this light gray color here, or maybe even dark gray actually, dark gray color. And the text size is going to be rather big, so 30 SP here. All right, so let's look at it. We can see this is our card. So we have a little welcome text in there, which is this dark gray. And we can unfortunately not really see the shadow that we create, and we can also not see that it is rounded. So if we test our application, then we will see it. Okay, but first let's add the other elements in there as well. So that is one of the texts, and it's not completely done. So I'm going to set the text style to bold as well here, so that it's thick and white. All right, now let's copy this text view and paste it just underneath it. It's going to be pretty much the same text view here. And then we have one minor change here to make, and that is to please enter your name and then maybe also the color. So I'm going to use a slightly different color here. I'm going to use 7A8089, which is a lighter gray, as you can see. The text size should be significantly smaller. So when we look at the example here, you can see this text is significantly smaller than the other one, and it's also not bold. So let's get rid of that as well. And now let's look at it again. You can see welcome, please enter your name. So we can see that quite well already. So the next thing we need to add is an edit text, which is this field here. Now, in order to use it in the right format and right style that I want to have, I'm going to have to use something from the material design, and that is a text input layout. So text input layout. And you can see it's the second one in my case. The width should be match parent again. The height should be wrap content. And then I'm going to set up some more things in here. So I'm going to give this a little margin towards the top so that there is some space in between this field and the text views that we have there. And then I'm going to give it a style. So there are multiple different styles that you can assign to such a text input layout. And I'm just going to use the style, which is going to be add style widget material components dot text input dot. Then you can see there are multiple options here. Unfortunately, they are too far off. So let me see it like this. So outlined box is what I want to use. So it's this one. So if we check that out, we cannot see anything in there yet because we don't have an actual added text in there. So this text input layout is just a preparation for our actual added text. Now the thing is, I could of course use the added text, but I want to use the app compat added text, which will work on all the versions just the same way as well. So app compat means app compatibility, so it's going to be compatible to all the versions as well. So it's going to just adjust accordingly to the version that the user has installed on his phone, so the Android version. All right, here the width will be match parent again, the height will be wrap content, and then what we need to set up is a hint. So I'm gonna assign the hint to be name. At this point, we should be able to see something. Once we close this bracket here, we should see that here is this app compat added text that is in there. Unfortunately, we don't see the hint yet. That's something that we would see once we run the application. Now, as the text color, I would like to use the same text color that we had here, this dark text color, for my edit text. So here text color will be #363A43, and then as the text color of the hint, so you can even define that, I want to have this lighter color that we had, so this one here. Let's now add the final part of this UI, and that is the button. So let me create a button down here inside of this linear layout at the very bottom. And we of course need to define this button. So I'm going to give it an ID so that we can communicate with it. And I'm just going to call this one button start. And then the layout width and height will be match parent for the width, and layout height will be wrap content. So it's going to span over the whole width as this button does. So inside of its parent, it's going to span the whole width here. Then, as you can see as well, it has a little margin towards the top. I'm going to assign 16 density pixels here, which is this distance between those two elements here, because otherwise they would be too close to each other. And then I'm going to assign a little background color, which will be the color that we have in our primary colors. So color primary. And finally, the text of it should be start. Now let's run this and then make some adjustments on the way. All right, so there we are. It's almost the same. There are some minor changes here. You can see that this background is a little different, and then the color of the start text is a little different, the size of it as well. So let's define another text size here, which will be 18 SP, and the text color, which will be white. So I'm just going to use Android color/white. All right, let's run it again just to see the changes. And there you can see now the text is white and it's a lot bigger, and we're almost having the same kind of effects that we had in our other example. But what you can also see is that the whole UI pops towards the top once we click onto our edit text here. You can see because the keyboard comes up, and that is due to our settings in the manifest, where we set the window soft input mode to adjust resize. All right, coming back to our activity main. Now, of course, you can play around with all the values. And here our card view that we're using, for example, here the corner radius, you can see it's set to 8 density pixels. So let's say we set that to 50 density pixels. Let's have a look at how our UI will look. You can see it's significantly more rounded. All right, so this is the radius that you can assign here, and I had it at 8 density pixels. All right, so I think at this point we have a great UI from which we can go to the next screen, and once we click the start button, we should go over to the next screen. There's a last thing that I would like to add though, and that is to get rid of our bar there at the bottom, at the top, this status bar. So if you want to get rid of the status bar in your application, because it has its advantages, of course, but in some cases it really just doesn't make the app look as good as it could look, then you can go to the activity settings here in onCreate and set up your window.decor view.system UI visibility, and set that to view.system, and hereby you need to import view. So let's do that real quick. Import, and here it's going to be .system UI flag full screen. Now let's test it again, and you can see there at the top the system UI is gone. All right, so I hope you managed to build at least some parts of this UI yourself. And in the next video, we are going to set up the model and a bunch of other things that are required for this application. So see you there. Welcome back. In this video, we are going to implement a second activity, and we're going to prepare something inside of the activity. So let me just enter a name here, press start, and then you can see we get over to this activity. So that is the goal of this video. But on top of that, we are going to prepare what will be displayed in here. So not the UI itself, but the data. All right, so let's get started. First of all, let's create a new activity. So here, right click, new activity, and I'm going to create an empty activity. And this one will be called quiz questions activity. All right, let's create it. And for this one, I want to have the same UI settings as for my other activity. So I'm going to go here and I'm going to copy that. Well, we don't need this resize part, but the other two I want to have in there. So the no action bar theme and also the screen orientation should be portrait for this activity as well. So our quiz question activity. And actually at this point, having an action bar isn't such a bad idea, because then we can potentially go back. So let me get rid of this no action bar theme here. All right, so that's the first part of this activity. Then the next thing that I need to create is a validation that the user has entered something. So if we go here, I want to have a validation. So if we press start and no text was entered, then I want to let the user know with a little toast. So let's go to our main activity, because that's where the magic happens. And then let's get the button start, which is this start button here. And once we click on it, set on click listener, I want to execute some code. So first of all, we check if our edit text et_name dot text to string is empty. So here et_name is of course going to be required. So where is that from? Well, let's go over to our resources, because here in our layout activity main, we had this card view in which we had this text view and so forth. But what's important is this edit text compat. So here we need to create an ID, which will be et_name, because now we can access it and see if there is an entry or not. So what I'm saying is the text to a string empty? So is it actually an empty string in there or no text inside of this field? And if that's the case, then I want to inform the user about that. And I'm going to use that therefore this toast feature. And how you can do that is you enter make text, and then it creates this toast.make text. And here you need to pass in the context. So it will be inside of the context of our main activity. So it should be shown in the same screen. Then we need to enter the text that should be displayed. So please enter your name and then the length of the toast. So toast.length short. And finally, we want to show this, of course. So overall, it's going to look like this. Toast make text, please enter your name, toast length short dot show. Now let's test that. So let's click on start when it's empty, and you can see please enter your name. Let me enter something there and press start again, and now you can see nothing happens. But of course at that point we want to move over to the next screen. So we want to move over to our quiz questions activity. So let's just do that. Let's say, okay, if the text is not empty, so this edit text, then let's create an intent which will move us over to this other activity. So we create a new val intent, which will be of type intent. And here we need to import intent with Alt Enter. We need to say from which context we want to start. And this will be this class here. And then to which class we want to move over, or to which activity we want to move over. And here it will be the Java file. So here ::class.java. Now at this point we of course need to start the activity, and that is done with start activity with the intent that we prepared. And we can also execute finish here, which will close the current activity. So we move over to the other, but we at the same time close this activity right here, which is our main activity. Because in the end, we want to be inside of the quiz until the user is done, and then we come back to this page or to this main activity. All right, and now let's prepare our questions. So we have questions in every quiz, right? And that is the most important part pretty much. So let's go ahead and create a new class which will take care of that. So I'm creating a new Kotlin file class, and I'm going to select class here, and this one will be my question. So I will define how every single question is going to look like. Now the thing is, this question class will not have any specific features and functionality. The only thing that it will have is data information. So it will know about the question text, so to speak, the image, then the different options that there are, and which one of the options is correct. So how I'm going to do that is I'm going to do that with a data class, because this question class doesn't need to have any function. So it just needs to be a very basic data class. So I'm just going to say I need to have an ID of type integer, so that I know which question I'm currently looking at. All right, and then you can, of course, now go ahead and add all of the other features that we want to have inside of this question. And by the way, these need to be brackets. So not the curly ones, but the rounded ones. So I want to have the ID. And then what else would I want to have? Now try to think of the different variables that we need to have here when creating a question. All right, so we need the question itself. So question, which will be of type string. Then the image, which it's uncommon, which will be of type int. So I'm going to assign an integer to each image. Then option 1, which will be of type string. Option 2, option 3, and so forth. So all of the 4 options that we have, so option 1, 2, 3, and then finally I need to know which one of those 4 options was correct. So, well, correct answer. You could have called this correct option as well, but I'm just going to call this one correct answer, and that will be an integer. So I'm just going to store the value 1, 2, 3, or 4 in there in order to know which one of those is correct. All right, and then of course I need to have all of the questions, and there are multiple different ways how you can do that. You could have an XML file or a JSON file which contains all of the different questions, but in our case we are going to work with constants. So we're just going to create a new file here, a Kotlin file, which I'm going to call constants, which will just be a file, and we're going to use object and call this one constants. So in here I want to have all of my constants, and the thing is I will create one constant which will contain all of the questions. So fun get questions, which is going to be a constant, but it's going to be a function which returns all of the different values. So here we're going to say that it's going to return an array list of questions. So what I'm doing is I'm going to use this getQuestions function in order to get all of the different questions. And what type are they? Well, they are question type, and they are in an array list. So basically I want to have an array list which contains a bunch of questions, and every single question needs of course to have all of this information here. As you can see, we need the ID, the question, the image, the options, and so forth. So inside of this getQuestions, what I'm going to do is I'm just going to say, okay, let's create this questions list, which is going to be an array list of question. And for now, it's going to be empty. But then I'm going to fill it up. So for example, question 1 will be of type question. And then I'm going to assign an ID, and as you can see now I need to assign all of the different values. So the first question will have the ID 1. It will have the question, what country does this flag belong to? And now of course you could say, okay, the question is always going to be the same, so why do we even have this question in there? Well, the thing is, this is a blueprint for you. So if you decide to adjust the questions, then you can do so freely. All right, so it's not necessary for this specific example, but it's going to be super great for your own applications. So then the next thing after the question is the image. So we saw here in our question KT that we have the image as an integer. Well, that one is a little confusing, but the thing is that our drawable dot, and then, for example, our background that we used is in fact of type integer. So it's going to return an integer. So now, of course, I don't want to use the background, but I want to use other images. And you can get the images from the course. So you can download it inside of the course, and they're attached to this lecture. So I'm just gonna paste them all in here. You can see it's all of those images here. I see flag Argentina, Australia, Belgium, and so forth. So now, of course, we can use the image that we just downloaded. So for example, I see flag of Argentina, which will be this one here. And you can also see it here on the left hand side. Okay, so the next thing that we need to pass is option 1, then option 2, option 3, and option 4. All right, so let's enter some options here. For example, Argentina, which is the correct answer, then Australia, and then option 3, which would be, for example, Armenia and Austria. And then finally we need to tell which of the answers is the correct answer. So is it option 1, option 2, option 3, or option 4? So I'm going to say it's going to be the number 1. So here it's going to be the value 1, which means Argentina is going to be the correct answer. So let me bring that into a more readable format. And now you can see that we have all of the different values that we had for the question KT here. So for our data class. So now our question itself is correct. What is missing though is, as you can see, this getQuestions function should return an array list of questions. So let's add this question that we just prepared to our questions list. So questions list dot add, and in here we add our Q1 or question 1, and then we return our questions list. And with that, our function will be happy, so no more errors. And now, of course, we only have one question. And now, instead of boring you with all of the different questions that we need to put in here, I'm just gonna copy them from the prepared code that I have here. And you can, of course, copy it from there as well, so that you don't have to type in all of the questions manually. Okay, so I'm gonna put them just underneath the point where I add my first question. So in here, I'm gonna put all of the other questions. And now at this point, you could be creative and create your very own questions with your own answers and your own images. Okay, so feel free to do so. Now there's one important thing left to do so that we can actually see if that worked. So if we can actually work with the questions that we have there, and that is not going to be to display them yet, but what I'm going to do is I'm going to create a new questions list variable here, which will be from my constants dot get questions. So here we had this constants class, or it's not really a class, it's an object, right? It's an object which is available from everywhere. That is the power of it. So I can just go ahead and say constants get questions, and it's going to give me all of the different questions that we had. And now we can test if that worked by using a log statement. So I'm going to say log I. It's going to be questions size, for example, how many questions do we have in there, and the message should be that is questions list dot size. All right, and at this point we will be able to see how many questions there are. So let's run this and see if the logcat is gonna offer the information. Therefore, you need to open the logcat here at the bottom, set that to verbose, and enter questions, because otherwise there would be way too much information here. So if you enter question, you can see it's filtered. And now let's go to the next screen, and we can see question size is 10. All right, so the questions are there. We can get them to this activity, to this quiz questions activity. So that means that we can now go ahead and populate our screen accordingly with this information. All right, so let's go to the next video where we're going to do that. Welcome back. In this video, we are going to build this UI that you can see here. So we have a scroll view. So this whole thing is inside of a scroll view. Then we have a linear layout, so that elements are put on top of each other. And then here, those two elements here, this is a progress bar, which has a text view next to it. So this is another linear layout where we are using the orientation horizontal instead of vertical. And of course, these 4 buttons, and then at the bottom we have 1 more button. But these 4 buttons, by the way, they are not buttons, they are text views. So I'm using text views here. So if you want to build this UI, you can do so yourself. Of course, you may not forget that we have a text here at the top and an image view here as well. All right, let's get started. Let's go to our activity quiz question. And as I said, this is going to be a scroll view. So scroll view, and I need to add the viewport setting. So fill viewport, I'm going to set that to true so that it fills the whole viewport. So the idea is that this will still look good on super small devices and will still work on very small screens. Now, of course, inside of the scroll view, I have my linear layout, which has a match parent width and a wrap content height. And inside of this linear layout, we want to have all of our other elements. So what's important for the linear layout is to know the orientation. So let's set the orientation to vertical so that things will be on top of each other. I want to have a little bit of padding towards all directions. So that is visible here. You can see there is a little distance towards all directions here, these 16 density pixels. And then I also want to center elements. So as you can see, they are centered here. All of the elements, they are not pushed towards the left. So in order to get there, we need to set the gravity to center. All right, so that's our linear layout. Inside of this linear layout, first of all, we had a text view here at the top. So let's create that text view. Text view, which has a width of match parent and the height of wrap content. And I'm going to assign an ID here so that we can access it. So I'm going to give this ID the TV question ID. Okay, so that's how I'm going to call it. Then I'm going to give it a little margin towards all directions so that it has a little distance, and that will be 10 density pixels. I'm going to center the text, so I'm going to get the gravity to be centered. Then we need to have a specific text color here. The text color I'm going to use is 363A43. So at that point, you can see we reused this text color multiple times. So at that point, you could go ahead and save that inside of your values colors XML. All right, so now it would make sense at this point. So if you want to, go ahead and do that. So text size, of course, needs to be set. So 22 SP is going to be fine. And then the text itself. So what country, and this is just a default text. Later on, we are going to override it with the question that we have in our constants KT. And it's going to be the same question, but still, we still need it here. All right, so that's our text view. And then underneath that, we have an image view. So we have this image here. And I'm gonna create an image view in here, image view with a width of wrap content and a height of wrap content. then a margin towards the top of, let's say, 16 density pixels, a source, that's the most important part, and that's actually our image that we want to use. And I'm going to use Argentina here, or you could use any color or any flag that you want to use here. And then because we want to access it, we should give it an ID. So I'm going to give it the ID IV image, because we want to change this image through code. And if we want to do that, we of course need to assign an ID to it so that we can access it. All right, the next thing that we have here is a progress bar. So you can see this is a progress bar, and then we have a text next to it. So if you want to have both of them and you want to have them next to each other, you need to have another linear layout. So you can see we create a linear layout within a linear layout. And this one will match parent in terms of width and wrap content in terms of height. And then it's going to be this linear layout which holds our progress bar and another text view. So I'm going to assign some more variables here. So let me assign those real quick here. We can see we have an ID. LL progress details is how I'm calling this, a linear layout. We have a little margin. I'm setting the gravity to be centered vertically. And the orientation, that's the most important part, is horizontal. So now the two elements, or all elements that are inside of our linear layout, will be next to each other. So as I said, I want to have a progress bar in there. So let's go ahead and create a progress bar. Now this progress bar should have a width of 0 density pixels. And what is 0? Why does it make sense? Well, the thing is, we are going to use weight here. So we're going to use the layout weight property, and I'm going to show you in a second. So then the height will be wrap content. So it's only going to take its own height here. And then you can see it's complaining. So the width is complaining. That's because we don't have the layout underscore weight yet. And I'm going to assign 1 to it. And you see the arrow disappeared. So at this point, because there's only one element in our linear layout, it would take the whole width. So it would take every bit of available space there. Then I'm going to set the maximum value to 10, even though we could then, of course, access that later on and assign the value via code. So if we want to access it via code, we need to give it an ID. So let's call this one progress bar. I'm going to set the minimum height of it to 50 density pixels. So even though it's going to wrap its content, it should at least be 50 density pixel high. And then the default progress. So the progress at the start, you can set that via the progress property. And I'm going to set that to 0, because it should start at 0 and then it should fill up each time that we get to the next question. Then there are two more settings that I want to set for our progress bar. And one of them is to make indeterminate false. So we can set the value to false if we want to make it a determinate progress. So determinate mode for the progress bar when you want to show that a specific quantity of progress has occurred. So here, for example, you can see determinate progress bar that is 25% complete. So the progress is set to 25. So I'm going to set indeterminate to false. And then finally, I want to assign a style, or define a style that I want to use. And here it's going to be Android, and here not the at sign, but the question mark. At question mark Android attributes, and then there is the progress bar style horizontal. So I want this to be a horizontal progress bar style. And then underneath I want to have a text view. So I'm just gonna paste in the text view here. And by underneath I mean underneath the code, even though in the visibility or in the view it will be next to each other. So the text view will be next to the progress bar. You can see now this is the text view that we have here, and this is the progress bar. So this is how the UI currently looks, because we haven't filled it up completely yet. But you can see here that the text view has an ID so that we can access it, because we need to change its text. Currently it's 0 out of 10, but later on we will fill it up each time or increase the value each time that we answered another question. Then we set the width and height to wrap content. The gravity is centered. We have a little bit of padding, 15 density pixels, so a little bit of distance there. And the text color hint will be this gray color, and the text size will be 14. So that we then in the end get this element here. All right, and underneath we have 4 times this text view here. So this is not a button, this is an text view. All right, and underneath we have 4 times this text view here. So this is not a button, this is an text view. So let's go ahead and use text views here. And I'm just gonna paste them in here because they all look the same, and I'm gonna go through one of them for you to see. So it has to be in between those 2 closing linear layout brackets, because it's underneath this linear layout, but it's inside the greater linear layout, which is our second highest parent, so to speak. All right, so let me put that in there. So what I want to use are 4 text views, and they are all the same, pretty much. The only difference is, of course, the text that they will display and the ID that they have. All right, so the ID in this one is TV option 1, text view option 1. They're going to match the parent in width, use only the height that they need. The margin should be 10 density pixels so that they are slightly apart from each other. Then I'm using a default option border background. So what this is going to be my own drawable resource. So let me create this file by hovering over it. So what you can just do is you can set the background as add drawable, and then just create a name that you have not created as a drawable yet, and then hover over it to create this resource file. And then you can just leave the default. And we're going to implement this file right now. So what I want to have is a shape. So basically I want to shape my text views so that they appear like buttons. And you can do that with the power of XML. So you can pretty much create your very own design by using XML files. All right, and what I need in here is to assign the right shape to it. So here I'm going to say that it's going to have the shape of a rectangle. So this text view here is a rectangle. It has a certain background, which is white, as you can see. And then it has this little gray stroke that surrounds it. So what we need to do is we need to create all of that. We need to say, okay, I want to have a stroke surrounding it. I want to have a solid background color, and I want to have rounded corners, because you can see, even though it's rectangular, it has rounded corners here. So let's do it one by one. Let's create the stroke first. So I want to create a stroke in here. And the stroke will have a certain width, and I'm going to say it's just 1 density pixel thick, so it's a super thin stroke. And then I want to define the color, which will be a very light gray, so it's going to be E8, E8, E8. So this is going to be, as I said, a super light gray. And then I want to have a white background color. So if you want to have a background color, you use solid here, because it's a solid background color, which is part of the shape. So here I'm going to use add Android color /white. And then finally, as I said, I want to have rounded corners. So I'm just going to say the corners should have a radius of 5 density pixels. And that will then create this rounded corner shape that we have here. All right, so this is going to be how this shape allows our text view to look like. So going back to our activity quiz questions XML, now the error disappeared and it accepts this background here. So you can see there are our buttons, and they are rounded, and they have a white background and a gray stroke that surrounds them. Then I centered the text, so I'm setting the gravity to center so that the text is centered inside of the text view or button, however you want to call it, even though it's not really a button. I have padding so that it makes the whole button bigger. So this padding is taking care of this distance between the text itself and the stroke that surrounds it. So here it's 15 density pixels between Argentina, so this text, and the stroke towards the bottom and towards the top. And then we set the text color to be gray and the text size to be 18. And of course the text in the tools would just be, in this case, Apple, in the second entry this Google, and so forth. So you can see they are all the same. The only difference is this tools text. And by the way, tools is just for us to see it in this design overview here. So if we want to look at it and see it here, so it's just to see it inside of our IDE. It's not going to be visible in the application itself during runtime. And then of course they have different IDs. So one of them is TV option 2, TV option 3, and TV option 4. Okay, so now there is one last element to be added, and that is this submit button here at the bottom. So let's go ahead and add that there as well. It's inside of this linear layout, and it's just a regular button this time. So we're not only using text views as buttons, but you can see the possibilities are limitless. You have a lot of options how you can do that. All right, so layout width is going to be match parent, and the height will be wrap content. So we've seen that multiple times before. And then what's important for buttons is that they get an ID, because we want to be able to click on them. So submit should be the ID. And then we need to define the layout margin so that we have a little bit of distance towards all directions. Then the background, and I'm going to use the color primary that we have. Okay, so it's this purple color. Then the text should be submit. The text color should be white. So if we look at it, currently the text is white, and as you can see it's also bold. So let's make it bold as well. It's a little bigger than this text, for example. So it's 18 SP. So the color will be Android color / white, and the text size will be 18 SP, as well as the text style will be bold. And now at this point, the colors, they don't look like the colors here. So in our app, if we run it, they don't look the same. We don't have those exact colors. So let's change those as well. And we can do that in the colors XML. So it's inside of your resources folder, then values, and then colors.xml. So the colors that I want to use are 9013FE for the color primary. The color primary dark is 6A1B9A, and the color accent will be the same as our color primary, even though we're not really using it, but in some cases internally this color will still be used, so that will be important. And before running it, I'm of course missing something in the color here. So when creating a color inside of your default option border BG XML, or in general when using XMLs, you of course need to have the hashtag at the beginning of the color name. All right, so let's go ahead and run it again. Okay, so there we are. So you can see the hint now also has the right color. So that was an error before, or a mistake that I had in there yet. And there we are. So you can see, of course, that the text is not really filled yet, so it doesn't display anything. But other than that, we can see that our UI is there. Of course, the texts are still missing. And of course, we have to assign all of those values in our quiz questions activity. So we get the data from our questions list. So please go ahead and try to assign all of those values. So pause the video and try to assign the relevant information or the relevant values. So for the progress bar, the TV progress, the questions, the options, everything. Quick hint, you will need to have the current position that you're looking at. All right, so I hope you tried it. So val current position is going to be 1. So we start at 1, the first question. And then the question that we're currently looking at will be of type question nullable, which we assign to questions list at the current position -1. So why do I use -1 here? Well, that's because the current position is set to 1, because that's how we named our constants. So the first question, we gave it the ID of 1, but internally, this is the 0th index. So it has an index of 0 inside of this array list, because as you know, array lists start counting at 0. So that's why we need to use the current position -1 here in order to get 0 as the first entry of our questions list. And then at that point, we can just go ahead and assign the progress bar. So we're just going to say progress bar dot progress is going to be the current position. So it's going to be our progress bar here at the top. We called it progress bar. So we gave it the ID progress bar. So I'm just accessing this thing here and I'm assigning the progress 1. And then TV underscore progress dot text should be our current position plus slash and the progress bar maximum. So progress bar get maximum or get max, and that will actually just be max. And then accordingly we need to set the text of the question. So TV question will be text is equal to question dot question. So the question is the current question that we're looking at, and every single question object has a question string. Okay, so not to confuse you, but that's how we called them here. Then we need to set the image of iv underscore image dot set image resource, and that one will be question dot image. So that's how we can set the image resource. I think that was the most difficult part of trying this little exercise. And then we have TV underscore option 1, option 2, and so forth, and we need to assign texts to them. So text of the TV option 1 will be question dot option 1, and so forth. All right, so let me paste them in here, and there we are. Okay, so at this point we can run the code again and see if everything will be populated accordingly. All right, so let me enter my name, and there we are. So what country does this flag belong to? We have Argentina, or the Argentinian flag. We have our progress bar, which is set to 1 because we are at the first question. And then we have all of the 4 possible answers, as you can see, in the same style, and then at the bottom we have the submit button. All right, we covered a lot this video, and we finally brought everything together. So we brought the model that we prepared and the UI together to display what you see here, and that is super powerful. So what's happening here is really powerful, and it's also a very important approach that you will need many different times. So using objects is very strong and very powerful. So that's what we're doing here. This is the model that we created, and now we use this model over and over again, and that is a big part of object-oriented programming. All right, I'd say let's move on to the next video. Welcome back. In this video we are going to set up this activity here, our quiz activity, quiz questions activity to be precise, and it's going to have the functionality where we can select one of the options, and it will have a different appearance once we selected it. As you can see, there is a stroke here which has a different color surrounding this text view, and it's a lot thicker. So what we will need to do is to also reset that for all of the buttons, or in this case it's text views, but then set it for the one that we click on, because we don't want them to stay all active, so to speak, after we clicked on another one, for example, if we change our mind. In order to create this functionality, we need to first of all create such a background color or such a drawable for our button. So we had this default option border, but now we also want to have a selected option border. So very similar to what we have here. So we can just go ahead and copy that, and then we can rename it selected option border. And here we need to make a minor change. So here the color will be color primary, that one here. And then we could of course also change the width, but maybe it doesn't make sense. So it really depends on what you prefer. But I think for now this is going to be fine. So now we just change the color for the selected option, and now we can go ahead and use that. So let's go back to our quiz questions activity, and here we are going to require several variables. For example, we need to know which question we currently are at, then the questions list, and then which option is selected. So these are very important variables. If we look at it, you can see the question, well, in our case it's always the same question, so it wouldn't be that much of a problem here. But still, if you each time have different questions, then you of course need to take care of that. Then we need to know the questions list in order to have the questions in general, so to even know which questions we should position at the right spot. And then of course the options that we have here, as well as the selected option. All right, and the questions list will of course contain the information about the different options, because a list of questions is a list of our model that we created, so of objects of this model that we created, which is called question, as you might recall, which has the question but also all of the options, the image, and the correct answer number. All right, so let's go ahead and create those variables first. So private variable, which I'm gonna call mCurrentPosition, which is going to be an integer, and I'm going to assign 1 to it, because each time we get to this activity we should start with the first question. Then I'm gonna have a variable for the questions list, which will just be an array list of questions, so of our question object that we created. And for now I'm just gonna set that to null, because I will need to initialize it later on, so inside of the onCreate. And then private var mSelected option position, so I need to know which option the user has selected. So for example, this one, option 1, option 2, option 3, option 4. So then I can go ahead and then check if the answer is correct. So why did I make this null? Well, because I need to have an object that I can use in order to set this questions list. Okay, so what we did before was we created this variable, but only locally, so it was only visible inside of this onCreate, so it's not in the scope of the whole project. So we changed that now, and we are going to use this mQuestions which is our global variable here that we created, that we can now go ahead and use. All right, so this log request will not be required anymore. And then also this part here is also something that we just created for testing purposes, so we will need to change that of course as well as pretty much this whole part. So we want to put that into a function which will take care of that. Okay, so we could go ahead and create a function for this, which I'm gonna call setQuestion, and in there we're pretty much going to do the same thing as we've done here. So let's go ahead and put that here. Of course, we now need to change the variable names, because we had this global variable called mCurrentPosition, as well as the questions. We get them from our mQuestion list. So here we're just gonna say mQuestions list, and by the way, we assign it here, mQuestions list get the mCurrentPosition -1. So it's pretty much the same code that we had before, and here we can also directly use the approach, as you can see, so you don't need to use the get function here. All right, and then of course the progress bar should be at the mCurrentPosition, because now we're not using the local variable that we had before, but we're using this global one which we have here. All right, and this one of course will also be the current position accordingly. All right, the rest can stay the same for now. And of course we need to go ahead and call this questions or set questions method here in onCreate. All right, the next thing that we need is a function which will take care of assigning the default layout for our buttons, which they have by default when we get to the screen. So we could either go ahead and start with defining the color here, or defining this background that we used for the selected button. But the thing is, each time that we click this button or click on any of the buttons, we also need to make sure that all the others are default. So what we can do is we can make them all default and then change the one that we have selected. Okay, and in order to do so, I think it makes sense to start with the function that makes them look default first. And that will make more sense once we do that. So private function default options view should be well options array list of text views. So you can see we can even create array lists of UI elements or of view elements, as this text view is one. So what I want to have is the different options that we had. And the different options are our text views here. Text view option 1, text view option 2, and so forth. So what I'm going to do is I'm going to assign them to my options array list by saying add. And then I'm going to assign an index, and this one will be TV underscore option underscore 1. Then options add 1 TV underscore option 2, and so forth. All right, so we need to add all of the options that we have here. And as it is with arrays, we start at 0. So with array lists, we start counting at 0. And options add 3 TV underscore option 4. All right, now we can go through a for loop or create a for loop which will go through all of the different options and which will assign the default user interface or the default UI for our button, which is this default drawable that we created. So this default option border, which was just this white or slightly gray border which surrounds the buttons. Okay, so let's do that. Let's run through a for loop for option in options. I want to go ahead and set the text color to be colors or color dot parse color, and it should be the gray color that it was by default. So it's not in here, it's actually in our activity quiz colors. So here we had this color here, which is this gray color. So I want to use this same color here. All right, so this is the default color. If you look at the button, you can see that this is the default color for the text, and we want to set that because you can see when it's selected, the color is not the default color anymore, but it's this black. All right, so we need to make sure that we set that accordingly. Then another thing that I want to set is the typeface. So option dot typeface is going to be typeface dot default. So what is this typeface? And I need to type it correctly here like this. So the typeface, set the typeface and style in which the text should be displayed. So we just set it back to the default typeface, so the default appearance, so to speak. All right, and then I need to assign a background for my option. So option background, and what is this background? Well, it's our drawable that we created, which is this default option border BG. In order to set such a border BG in this case, so such an XML file, we can use the following approach. So context compat get drawable, and then we need to pass in the context, which is this, so in this class, and then the drawable that we want to use, and it's in our resources folder, so we use R. Then we get it by going to the drawables folder, so you can see here it's inside the drawable folder, and in there we have a file called default option border bg. That's the file that we created, so this one here. So we just assign it for that now. All right, and that's already it for our default options view. Now the thing is, each time we set a new question, what we also should do, we should set the default options view just to make sure that all the buttons are back to the default appearance before we then later on select one of them by clicking on them, for example. Now, of course, all of our buttons should have an on-click listener so that we can click on them. So I'm just gonna say TV option 1 dot set on click listener, and I'm gonna assign this to it. Then TV option 2 should also have an on-click listener, which I'm gonna assign this to, and so forth. Now you can see that this is not accepted here, and that is because our class, our quiz questions activity, is not a click listener. So we can add that by using the following line in a second. So let me just finish that. On click listener for all of our 4 buttons, and then I make this class an on click listener. So on click listener. So now you can see once you do that, the class is complaining because you need to implement the members. So we need to implement this member, which is the on click method. So let's implement that, and you can see now we have this on-click method here, which we can now define. So what do we want to do once the user clicks on the button? Well, we want to select it. You can see we want to make it selected as we have it here. So it should have another color for the text. Then it should have another color for the background, which is our other r.drawable. So it's just this other XML file that we prepared. All right, so we could of course do that in the on-click each time, but we can also prepare a function which is going to take care of that. And I'm just going to call this function selected option view. So let's go ahead and create that private fun selected option view, which needs to have a text view. So text view, and then the selected option number, which is of type integer. All right, so we need to know which option was selected in order to do the right thing. All right, so here, first of all, what we will do is set the default options view. So we reset everything to the default. Once I click on something, you can see this one is reset. So Armenia, for example, this button is reset to the default view. And this Australia also is for a short moment still default, but just a second later, then we set this design that we had set before. So now we pretty much need to assign that this button that we currently have clicked on is going to be our selected options position. So the selected option, this one here, selected option number, is going to be our new selected option position. And then the next thing we need to do is similar to what we have done here, where we assign the typeface and everything. All right, but this time it's not for the option itself, but it's for the text view that we are looking at. Okay, so let me copy that and put that in here, because now it's not the option as I said, but it's the text view that is passed to this function. Okay, so there we are again, and TV. Now, of course, I want to use a different color here, so I'm just going to use 363A43, which is also this black color, or dark gray color, which we have used before. So, but this I set the color of our text, and then the typeface. In order to change the typeface, you can do it the following way. So you can say that you want to set the typeface by saying which typeface here and how you want to set it. type face dot bold. So I want to make the text bold, so that's how I can do it. And then the background, of course, is now not our default options border, but our selected options border, which is this XML file that we prepared, which has this purple border or purple stroke which surrounds it. All right, and now there's just one thing left, and that is to use this function. And we're going to use it in the onClick here. So we can use a when here, when v.id is r.id.tv underscore option 1. What shall we execute in that case? Well, I'm just going to say selected option view is going to be rv. And then we also need to say which is the selected option number, and it's going to be 1. Now rv is a view, but we actually expect a text view here, so actually what we can say that it's our TV option 1, which is of course this text view here. So we can directly pass a whole text view to a function, which we then can use. Okay, and that's what we do here. So now we call this function that we created. We pass in the TV option 1, which is this text view that was required, and then we pass in the number, in this case number 1 because it's option 1, here as the selected option number. And then it goes through this process here. So it says, okay, let's reset all the buttons, then select the or use the option that was used, so in this case 1 as the selected option position, then set the TV text color to be this dark gray color, set the text to bold, and set the background or the border of the button to be this extra drawable that we created. And of course we need to do the same thing for all the other buttons as well. So here we go ahead and say, what if it's r.id.tv option 2? So if the second option was clicked, then I want to also call the selected option view, pass in TV option 2, and pass in the value 2 as the selected option here. And of course for the other buttons as well. So TV underscore option 3. When that one is clicked, then we also want to say selected option view TV option 3, and the value is 3. And finally the last button, which is r.id.tv option 4. And when that is clicked, we select option view TV option 4, 4. So this is just another way of doing it as we would have done in our onCreate, where we could have set the onClick listener and implemented the code directly here. That would have been an option. But as you can see, there is another option to use buttons, and that's to set the onClick listener in the onCreate, make the class itself, follow the structure of an onClick listener, and implement the onClick event here. So what we're doing here is we are implementing the onClick listener to our class quiz questions activity. And now at this point we can test it, and we will see that we get the same functionality as in the demo that I've shown you before. All right, let's test it. Start, and then let's click on the buttons, and as you can see, they are beautifully set to default, and then also the one that we click on is highlighted. All right, perfect. So we have prepared the buttons, but we also have prepared the selected options and the questions. So we went a little further, and that's what we're going to keep on improving in the next video, because the submit button of course doesn't do anything yet, and that's what we of course still need. So see you in the next video. Welcome back. In this video, I would like to add the functionality that allows us to see if an answer is correct or not. So for example, this is the flag for Argentina. If I select Australia here, for example, and I click submit, you can see that the background color is red, and also the text is fat here because that's a selected answer, and then this green one is the correct answer, or would have been the correct answer. And you can also see that the submit button now works, and once we click on go to next, it goes to the next question. And also here we have, for example, let's say I select Australia here. That's the correct answer. So it's going to give me the correct background. So what I need is a background which is going to be green, and then another background which is going to be red. So green for correct and red for incorrect. And that is something that we quickly can set up. So I'm just gonna go ahead and go to my resources. Inside the drawable folder, we have this default option border, which I'm just gonna copy and paste once again. And I'm going to call this one correct option border BG. And what I'm going to change in here is that I don't need a stroke. So it's still going to be a rectangle, but I don't need a stroke. And the only thing that I want to have is another background color. So here I'm going to use the default color holo on the screen green light color, which will be this light green. This is the correct border. And now let me duplicate that correct option border BG once again. And this one will be the wrong option border BG. And here the only difference is that we are going to use holo red. So holo underscore red, and here also the light color. All right. So I don't use a stroke. As you can see here, there's no stroke surrounding it, so no border. It's just plain background. And now, of course, I need to find a way to set those accordingly. So I want to set the buttons accordingly. And that's what has to be done in the questions activity. So the first thing we can directly do is in the onCreate function, we can give our button submit the setOnClickListener here. And we're going to pass in this. And then we could, of course, go ahead and assign the submit functionality in here directly. So we could just go ahead and say r.id. And the button was called button submit. So once we press that, what shall happen? But the thing is, we have nothing prepared there yet. So we will need to also be able to assign the right color for our background. So for the background of the button. And therefore I'm going to create a new function here, private fun. And I'm going to call this one answer view. And it needs to know the answer, so the int of the answer, and what it should draw. And I'm going to call this one drawable view, which is also going to be an integer because the drawables that we have are internally stored as integers. Okay, and now I can check when the answer is 1, then I want to set my TV underscore option 1 background to be context compat dot get drawable. And where do I get the drawable from? Well, first I need to pass in the context and then the drawable view. And that is going to be the integer that is passed to this function. Okay, so this function is really just going to take care of assigning the right color, so the right background, to our options. So if the answer integer is 1, then it will be setting the TV option 1's background. Okay, now we need to do the same thing for the other options that we have. So same code pretty much, TV option, only that it's not TV option 1, but it's TV option 2, and so forth. All right, so here it's 3 and 3, and here it's 4 and 4. All right, so that's our answer view function. And now when we press submit, what we see here, so let's say this is of course Brazil, but I select Belize here and I press submit, then the correct answer gets a color and the incorrect answer gets a color as well. So this is incorrect. In our case, if we had an incorrect answer selected, then it will be red. And if we had a correct answer selected, it will be green and nothing else will be colored. But if we have an incorrect answer, then of course the correct answer will also be colored in green. So that's what we will need to do once we press submit. So here inside of our on click, that's where the RID button submit functionality is to be implemented. So here I check if the M selected option position is 0, then I want to go ahead and increase that by 1. So increase the current position. And why would I do that? Well, why would I even have this situation where the selected option position is 0? Because the selected option position by default is going to be 0. Here it starts with 0 because we haven't selected anything. So once we have selected something, the value will be overridden, of course, and we will accordingly move on with our code, right? But if it's 0, then I want to go to the next question, so to speak. Okay, and that is done with this position, or it's handled with this position. So I increase the position by 1, saying that I want to go to the next question. Okay, so the selected option position will be of course checked and changed once the user presses on any of the other buttons, and then it will be assigned. But at the same time we will reset that, so the selected option position back to 0 once we are done with coloring everything and letting the user know if he was correct or not. Okay, it's a little confusing, but as soon as we get there it will make a lot more sense. All right, so if we press submit, then there are multiple things that we need to check. So first of all, we need to check when the current position is less or greater than the questions list size. If that's the case, then we want to set the next question. So we want to go ahead and pretty much reset the screen. So when we click on this button, you can see now the question has been reset. So the question text has been changed, the image has been changed, of course the answer options have been changed as well. So that's what happens in the set question function. And then otherwise, so if that's not the case, so else, what I want to do is I want to write a toast here. For now, make text, which is going to be, you have successfully completed the quiz. So at this point, we later on want to display the finish screen, so to speak, or result screen. So you have successfully completed the quiz, which should be displayed for only a short period of time. .show. All right, so that's our toast here. Nothing fancy, but a general toast. And we will replace that later on. All right, so this is our when here, but we had another if surrounding it. So here at this point, that's where I want to have an else. So if we do not have M selected option position 0, it means that we have an option position. So the user has selected an option. So what we need to do is we need to create a question here, which will be our M questions list. Get M current position. So we want to get the question at the current position minus 1. All right, so as we know, the questions list is an array list. Array list starts at 0, so we want to have the first entry or whatever M current position currently is. So if it's, let's say 5, then we want to have the 5th entry, which is our index 4 inside of our M questions list. All right, and that's our question. Now we can check if the correct answer that is inside of this question, so question correct answer, is not equal to our M selected option position. And here it's correct answer and not correct answer. And if that's not the same, then we know that we have selected the wrong answer. So what answer view should do is it should take the selected option position and draw it accordingly. So drawable dot, and here it was the wrong option border background should be set. So the button should be red pretty much. So if we selected the incorrect answer, that's what happens. And in any case, what we want to happen is that our answer view with the correct answer is also set. So question correct answer r dot drawable dot correct option border bg. Because if you look at it, this one here, for example, is Belgium. So if I select Belgium, then Belgium will be green no matter if it's correct or not. Okay, or if our selection is correct or not, of course. And in the next example here, let's say I select France, even though this is, I think it was Fiji, then you can see that my incorrect answer was selected red, or the background was set to red, as this if statement here does. But the correct answer is set to green in any case. So it doesn't have to be inside of an if and else statement, so to speak. Of course, in the greater scheme of things, it is inside of this if else, but not in terms of when we are at the right spot in our code. And then when we are at the last question, we want to make sure that the button here at the bottom changes from go to next question to submit. So what we can check here is m current position is equal to the m questions list size. Then the button submit text should be finish, and otherwise it should be set to go to next question. Now at this point, we have gone through the whole process of assigning the correct color and so forth, and we go to the next question. Okay, so once we click on once again, you can see we go to the next question, because here we set the question. But the thing is, that will never happen if we don't set our selected position back to 0. So that's what I'm doing here. I'm just gonna assign 0 here. All right, and then there is only one last thing to do, and that is to set the submit button accordingly. So you can see we have go to next question and submit, but this is not what we have in our program yet. So we need to set that accordingly, and that is each time that we set a question. So we need to go to our function set question, which is rather far up in my case. So here in set question, after we set the default options view, what we can do is we can check if the current position is equal to the questions list size. And if that's the case, then change the text to finish, and otherwise set the text to submit. So button submit.text is going to be submit. So each time we have selected the answer, you can see the text is changed to go to next question, but we need to set it back to submit, and that's what happens here. Except of course we are at the last screen, then we just want to display finish. All right, and now at this point we can test our application and see if all of that is actually implemented as we expected. All right, there we are. Let's test it. So let's see, Argentina. Okay, answer is correct. Go to next question. And as it seems, we're not moving over yet. So let me select Argentina once again. So we need to make sure that we're actually moving over. And you maybe spotted it. It's exactly this one here, M current position. So we had that earlier for testing purposes, but now it's in our way. So we need to get rid of this line and now test it again. Because what it did is it always, when it set a new question, it set it back to the question number 1. So it's never gonna give us the right question, right? So it's never gonna give us the next question, so to speak. All right, let's test it again. Let's enter a name, let's press start, and now select Argentina, submit, go to next question, and you can see everything works as intended. So we can go through our application as intended. Let's make a mistake here. As you can see, it's still gonna work. And then of course here, if we make a mistake, let's say I say this is Georgia, I can still change it back later on and go to the next question. So we still have this functionality, but I wanted to really keep it super simple. So if somebody wants to trick the system, he can do so. You could of course create an additional helper variable which takes care of the user just answering once and not being able to change the answer afterwards. And that can be done by just simply checking each time that the user presses a button if he already pressed a button inside of this question. So when set question is called, you could have this variable check here. All right, I'd say let's go to the next video. Welcome back. In this video, I would like to introduce activity for result because we are going to require that for quite some applications. So the idea is that you can start an activity and you get information back or data back that you can then use in the activity that started the other activity. So the idea is that, for example, when you take an image with your camera and you send the request from your application, for example, then you want to use the image that you have taken. And the image that you have taken is sent to you back as data that you can then use. So that's basically the idea. And if you, for example, want to get an image from the gallery, then you would start an activity which will then open up the gallery, and then when you select an image, it will give you that image back as the result of that activity. And that's exactly what we have here. So this is a very basic version of it where you just, for example, launch an activity, and then when you go back, you get a success signal. So it just says, okay, the activity result is success. And we're going to define this ourselves. But then a more interesting one is the second activity. So once you launch it, you see that here we can enter, for example, the name and the email address. And this will then allow us to get that information on the main activity here. So we sent this information back, so to speak, to the starter of this activity. Okay, so this is going to be important, as I said, in multiple different cases. So let's look at how we can build that. As you could see, we need two activities here. So I'm just going to create them real quick here. Activity, and this one will be an empty activity. I'm going to give this one the name first, activity. And then I create another one. So let's go ahead and create this second activity here. Another empty activity, and this one will be second activity. When it comes to the XML file, the first activity just has a button, and it doesn't really matter where the button is. What's important is that it has an ID, and if you look at it, well, it's just a button, in my case, in the center. You could have used any type of layout here, but in this case, it's just a constraint layout. The second activity has two edit texts and a submit button. And in my case, it's again a constraint layout, so you could just drag them in there. What's important is that they have the IDs that we can then later on use in order to communicate with them. And then finally, our main activity just has two buttons, and then underneath each button we have a text view. So you can see here a text view, and then another button, text view, and button. All right, that's pretty much it. Now let's go to our main activity, because that's where we then want to start the activities, because that's where the initial point is, our start point, the main activity. And in here, I need a companion object, because what I want to do is I want to be able to store my different variables, my constants, and I want to use them. So one of them will be our first activity request code, and I'm going to assign 1 to it. And I'm just going to do it with the first activity for now, and then later on we will see how to do it with the second one. Now, once I click on the button, so this first activity button that we see, in our main activity here, once I click on this one, what I want to happen is I want to start an activity, of course. So let's just do that. Button underscore launch underscore activity first, set on click listener. Now in my case, I needed to import that button, but then once somebody clicks on the button, what I want to do is I want to run an intent. All right, so let's go ahead and say intent is going to be starting from this activity and it should go over to the other one. So it should move over to first activity : class.java. And of course we need to import intent here. So let's import that real quick. And then how we would usually start an activity, we will just go ahead and say start activity here. Now the thing is, I want to start an activity for result this time. So I want to also get a result from this activity. So let's use that one. So I'm just gonna pass in an intent, and then I will pass in the request code. And the request code is going to be the one that I created here, which is called first activity request code. And I'm just assigning a constant here so that I can then later on get back to this specific request code. And we will see why. Because as soon as we have the on activity result here, on activity result, and that's that one here, once we override that, in here we get a request code, result code, and data. All right, and request code, well, you see it here already, it's the same name. So we will get a response depending on the request code that we passed once we started an activity for result. So the first thing we need to do is we need to make sure that the result code is fine. So we check here if result code is going to be activity dot result underscore okay. Only if that's okay, we want to check the request code. So if the request code is going to be the one that we have defined, so this first activity request code, then we can do whatever we wanted to do once somebody came back from the first activity. So what I'm gonna do is I'm just gonna set the TV first activity result text to first activity result success. Okay, so basically for our main activity here, I set this text view, which is called TV first activity result, to be a value, because currently it's just an empty text view. It doesn't have any text in there. But once I get back from my activity, which was called first activity, then I want to set it. Okay, I want to set the text here. All right, what should I do if the result code is not okay? So if something went wrong, if for example the result code is equal to activity dot result cancelled. So what if the user canceled the activity request? Well, then I'm just gonna write a little toast and add a logcat. So I'm just gonna say cancelled in the log, and then I'm gonna write toast make text result cancelled for a short time. So now let's go over to the first activity, because from here what we want to do is first of all give this button that we have a functionality which will just close the activity, but then I also want to set the result. So button underscore finish, if that one is clicked, so set on click listener, then I want to set the result to be activity dot result okay, and then I want to finish the current activity. Okay, so this is really basic. We're just setting the result to be okay. We're not giving it any additional information. We're just saying, okay, the result was okay, and now let's finish. All right, so now let's test this and see what's going to happen. All right, so let's start the first activity, launch it. We get over to this other screen. Let's finish it. And we can see first activity result was a success. So we set the result to be okay. And then in the main activity, we checked it. Was it okay? Yeah, if it's okay, then let's check if the request code was the first activity request code. And if that's the case, then set the text view to be first activity result success. So basically, we just sent the result that we wanted to get, which is very basic. We just said it's okay. But what if I actually want to have values from that other screen? Well, that's where our second activity comes into play, because in that one, what I want to have is additional information. I want to see what the user has entered in those two text fields, which we have here, which are edit texts. So if we look at it, we have those two edit texts here. And if the user enters something and then presses submit, I want to get this information back to the main activity. Well, what I can do therefore is, first of all, of course, implement my button. So button launch activity second, set on click listener, because otherwise, of course, it's not going to do anything. And here I also need an intent, similarly to what we have done before. Pretty much the same approach. Let's do that real quick here. The difference is that we want to get to the second activity. And then what's important is that we have another request code. So it's not the first activity request code, but it should be the second activity request code. So I'm gonna rename it here, second activity request code. And of course, this doesn't exist yet. So we need to create that in our companion object here. Private const val second activity request code, and I'm gonna assign the value 2. So it's just a constant here which I assign the value 2 to. Now I'm going to start with just a name. So I'm gonna create another constant here, which is gonna be a value called name. And I'm gonna assign the value name to it. Okay, so this is the constant variable name, and this is the string that I assigned to it. So I just called it name. All right, so from the second activity, I want to get back to my main activity, but I also want to send some information over. And in order to do so, what I'm going to create is an intent here and an on-click listener. So button submit set on click listener. This pretty much means as soon as somebody clicks on the submit button, I want to do something. So that's what this does. And then I want to create an intent. So I'm just going to create an intent object here. And this time you can see I don't pass in the activity that I'm currently in, so no context, and I don't pass into which class I want to go. But in this case, the only thing I do is I want to assign information to this intent so that I can send it over. So in this case, I'm just going to say intent put extra, and you can see there are many different overloads for this function. So you could put a lot of extra information or different types of information to this intent. For example, strings, doubles, integers, all the different types of simple data types, so to speak. Okay, and then you need to give it a name. So the name hereby is a key. So we have the key value pair, which pretty much means we have the key, which is where is the information, and then the value, the information itself. So the key will be my main activity dot name. So in there I have this variable called name, this one up here, which is this constant, and then the value that I want to put extra, so the information that I want to pass over. And in my case, I want to pass over the name of whatever the user has entered, so of this edit text, which means I want to pass in this edit text here. All right, and now what I can do is I can set the result to be activity result okay. So here it's this result okay, and I can pass in some more information, which is my intent. So I'm just going to say intent here, and then I can finish the activity. Okay, so this time I'm adding some information that I want to set back or send back from one activity to another, and you can see we set the result and then we send the intent. Now, of course, we need to catch that information in the main activity in our onActivity result. So here, the last time we checked that the result code here, and we checked that the request code, which was first activity request code. But this time we're looking at the second activity request code. So here, else if the request code is equal to second activity request code, then what I want to do is I want to set the TV second activity result text to be, and in this case it should be, of course, information that I get from the other activity. So how do I get the information? So the cool thing is when you use onActivity result, you get some data here as well. You can see the result can have data. So it has a request code. We check that one, which is this code that we use ourselves. Then the result code, which is either result okay or maybe canceled. And then we get some data as well, or some data can be sent. And that is what we have sent here as this put extra data that we pass. So now we can use that data if it's not null. So if there is some data, so if it's not null, then please do something with it. And I want to get the name from the user, and I get that from the data that was passed to me, and here get string extra. So here I can just get the extra from name. So why do I use name here? Well, because we passed the information via name here. So we used mainActivity.name, which is the string, so which is the key, so to speak, and now we use the same key in order to get the information back. So it's the same as if we would have used name here. Why is that? Well, because behind name we have the string name. All right, and now of course we can set our second activity result. So for now I'm just going to use name here. All right, now let's test this and see if it's going to work. So let's launch the second activity. Let's enter a name. I'm just going to enter Dennis. I'm going to press submit, and you can see Dennis was entered here. And that is because we set the result text based on whatever the user has entered. Now let me go over here and press back. You can see result canceled. So when you don't actually set the button, so when you don't actually set the activity result to be okay, then you get the canceled event, which is this result code that we have here, result canceled. All right, so now you can see that you get the data, and now the little challenge for you is to extend that functionality so that it will not only display the name, but also the email address that the user can enter in this activity here. Okay, so please go ahead and try that. All right, I hope you tried it. So first of all, I need a new constant. So const val email is going to be email. Then we can go ahead to our second activity and we put extra information. So we put extra, and this time main activity dot email, and we get the information from et email dot text to string. All right, now we put some additional information into the intent that we then set as the result, and then we finish the activity. So now in our main activity we can get that information, and we get that via val email is equal to data get string extra. And what's the name of the extra information? At least the key to it. Well, that was the email. And of course I can go ahead and use that. So here it's going to be name and email. All right, now let's test it again. And let's launch the second activity. Let's enter a name, and here I'm just gonna enter test, and you can see Dennis and test both worked. All right, so this is something that you will need quite often, for example, when you start an intent for the camera. So if you want to get something from the camera when the user takes a picture and you want to set that into your screen or into your image view, or if you get something from the gallery, or in general, when you start an activity to another, for example, application where you get the data from, such as the gallery and so forth, or if you have an activity which just opens up, such as a pop-up, for example, where the user can enter some data and then this information needs to be sent back to another activity where you can then display the information or work with it. Welcome back. In this video, our goal is to create this UI here, this XML file, and of course we also need a new activity, which is going to be the result activity. So this is what should be displayed in the result activity. And for now, the goal is just to create that and also to have a variable which knows how many answers we had correct, or how many correct answers we selected. And yeah, that's pretty much it for this video. So if you want, you can of course try to build that yourself. So you can pause the video and just go ahead and try to build that UI. You will of course need to have the image. You can download it from the lecture, and then yeah, good luck with it. All right, otherwise, of course, I will show you how to do it. So let's go ahead and create a new activity here, which will be an empty activity. And I'm going to call this one result activity. Once it's ready, let's go to the manifest and adjust the activity accordingly. So I want to have the no action bar theme and also the portrait orientation for my result activity. So I'm just going to add that here. And then we can go back to our quiz questions activity, because here what we needed is a variable which knows how many times we have answered correctly. So let's create one, private var m correct answers. It's going to be an integer, and which is going to be set to 0 at the start. And when do we want to increase that value? Well, each time that we assigned the green button as the option. So each time that we had a correct answer here. So pretty much we had this if statement where we checked if we were incorrect, and if we weren't incorrect, then we can increase the correct answers by 1. So we are inside of our onClick function here for the submit button when we had the correct answer check here. And if it was correct, then we increase by 1. So pretty much what we say, if it wasn't incorrect, then we increase by 1. Now in this video, because we have already created so many different UIs, I'm just gonna keep it super simple. So I'm just gonna paste it in here, and I will talk over what the activity result XML looks like. So what we have is a linear layout, and it matches the parent in both directions, so width and height, and it has a certain background, which is our drawable ICBG. Then it's centered horizontally. The orientation itself is vertical, so things are put on top of each other. We have the padding of 20 dp, so a little bit of padding in all directions. And then we have a text view here saying result, which is bold and has a text size of 25 sp. It's white text. The margin towards the top is 25, so it's not all the way up, all the way at the top. So that's the idea behind it. And then there is one very important part missing, and that is this image view here. So you can see I need this IC trophy. So what you can do is, of course, you can download it from the resources and go over to your projects, to your resources folder, drawable, and then paste it in there. And once we paste it in there, we can see that it appears here. So in this case, the device that is by default used here is this pixel in my case. All right, so this is how it's going to look like in the pixel. That's why I only have this IC trophy PNG, which is the size MDPI. But if you want to have all the different sizes for the different screen sizes, so to speak, then you should of course import the whole folder. As you can see, there are different sizes here the low density pixels, medium, high, extra, extra high, and extra high. So it's going to adjust accordingly to the screen size if you have all of those in there. In my case, I just kept it simple for this video, so I'm just using the IC trophy PNG. But otherwise, of course, import the whole folder here so that it looks fine on different screen sizes. So for example, if I now go over to this screen size, you can see it's pushed towards the top a little bit because the image is not that big. All right, so it really depends on the screen size that you look at. All right, so that's our image view, and as you can see, it wraps the content. We have the content description of image, and then underneath we have a little text view saying congratulations, and it says, hey, congratulations, which is white, 25 SP, bold text, so it's this one here. Then we have the username, which is another text view. You can see it's not as big, it has 22 SP, has the same margin towards the top, also wraps content in both directions. Then we have the text view, which says your score is 9 out of 10, and it's important that this one has an ID so that we can override it. And it has less margin, as you can see here, so the margin is not as big as it was here. And then the button finally, which also has a margin of 10, so it's this one here towards the top, so they're equally far apart from each other, those three elements, each time 10 density pixels, and then text size is 18, and the text style is bold. And the difference here, as you can see, is the background is white and the color of the text is, in this case, this purple color, which is our color primary. So if we change the color primary, that color will change as well. All right, and in the next video, we are going to finalize this whole thing. So we're going to add some more features that will then finally allow us to get over to the screen, because the screen needs to know how many answers we had correctly and so forth. So we need to put this information over to this result activity. All right, so see you in the next one. Welcome back. Now there is one last thing to do in our application, and that is to finish the result screen. So what do we need on this result screen? Well, we need the username, and we need to have the amount of correct answers and of course the amount of total answers. So these are information that we need to send over to the screen. And where do we get them from? Well, we get the username from our first activity, which is our main activity, and we can pretty much get the other two from our constants variable. So here in our constants variable, we can go ahead and create several new constants, which will be const value. This one will be underscore username. I'm going to set that to being a string, and I'm going to call this one username. Then const value, and here of course I'm saying value, but it's a val. It's an immutable variable. So then we have total questions, which also will be a string of type total questions, or at least that's going to be the entry in there. And then finally another variable, which will be the correct answers, which will also be correct answers as a string. So why do we even need them? Well, if we go to our main activity now, we need to open up here the main activity, we can see that we have this intent, and this intent sends us over to this quiz questions activity. So we need to put some extra information into this intent. So we can go ahead and say put extra. And what do we want to put extra? Well, first of all, we need to have a key, so to speak, and that will be the username that we sent here. So constant dot username is going to be, and what is the username? Well, we get the username from the user entering his name into et name. So we can just go ahead and read that from there. We can just say et underscore name dot text dot to string. So now we send this information over with the intent to the next activity, which is our quiz questions activity, because we move over to this activity by starting this intent, right? So we now can retrieve this information in the next activity, which is our quiz questions activity. So here I'm going to create another variable at the very top, which will store the username. So var username, which will be of type string, nullable, and I'm gonna set that to null for now. All right, so now of course I need to set the username. And how can I set it? Well, I get the username from the intent, so I can do it in the onCreate, because as soon as the onCreate is fired, we already were sent over, and the intent has already sent its extra information, which we have put in the main activity. So here we can go ahead and retrieve this information by storing it in our username variable, which is intent.get string extra. And now at which position was the string extra? Well, it was at this position here. So that's the key. That's pretty much the name, not the username itself, but the name of the username key. All right, so it's going to be this one here. So now we get the username, whatever the user has entered in the main activity, over to this activity here, which is our quiz questions activity. Now the thing is, in this activity, we don't even need it. We just need it in the results activity. But the thing is that we have this flow that we move from the main activity over to the questions activity, then over to the result activity. All right, so this is one way to do it. So we send it over with intents each time. Of course, we can also store it on the device each time and override it by using shared preferences. But in this case, we're going to keep it simple. We're just going to send it over to the activities via the put extra functionality. All right, now we need to find the right spot to move over to the result activity. And that is in the onClick when we click submit. So once we click submit and we move over to the next screen, or we should move over to the next screen, which is here. Currently we have this make text here, but instead at this point we want to move over to the next screen, right? So we need to create a new intent. So let's go ahead and do that. So intent is going to be a new intent, which needs to have the context. And of course we need to import intent. So let's do that. Alt enter to import it. And then we need to say to which screen we want to move over. And here it's the result activity class.java. And here it's a colon twice. So double colon. So that's our intent. Now the intent itself is ready, but the thing is I want to give this intent additional information. So I want to put some extra infos to it. So I'm going to use put extra here again. You can see there are many different overrides for put extra, many different options. So either we pass in a string or we pass in an integer and so forth. So we could pass a lot of different information in there, but we just go and use the same function every time. So we can just pass different information. It's going to use the right information every time. So first of all, it needs a string. So here constants dot username. So we're just going to use the username again to pass it over. And where do we get it from? Well, we created this variable called username, which we created here at the very top. So here the username, and then we filled it in the onCreate here. And now we use it when we press the submit button. All right, so that's our first intent put extra. Then we need to put some more information extra, and I told you which ones they are. So if we look at our result activity, we can see it's the amount of correct answers and it's the amount of total answers. All right, so let's put this extra information here, constants dot correct answers, and it's the correct answers variable that we created. And then another intent put extra where we put the extra total questions. So constants dot total questions, which is our questions list dot size. And now the M questions list is a nullable, so we need to force unwrap it here, or force it here. And now, of course, we can start this activity with that intent that we prepared. Okay, so here we put all the extra information. So this is the key, and this is the value, and we have different keys, and we prepared those keys to be constant so that we can always use them with the same name, so to speak, and we don't have to write them here manually, because here the correct answer constant is, of course, going to be correct answers. All right, so at this point we send it over, and now we of course need to receive it and retrieve it in the result activity. So when we get to the result activity, and that is in the onCreate, that's where we get this information, but we need to use it. So we need to catch it, so to speak. All right, so in order to get the username, we can just create a variable here called username, and we get this from the intent. So get string extra at the position constants dot username. And now we can use this name to set it as the tv underscore name dot text, which is going to be the username that we prepared. So that one here. And what is this tv name? It's our text view in the activity result here, which is this text view called tv name. So this one where currently it says username. So we need to import tv name. You can see here it needed to have this import, which is this one here. And now we can use it. All right, so we set the username. Now we need to set the score text, which is of course going to be dependent of two values. So one is going to be the amount of correct answers, and the other one is the amount of total questions. So val total questions is going to be intent get int extra this time, because if we look at it, here we sent over m correct answers, and it's an integer. All right, so we need to pass in the right value, of course, and we need to get the right value here. So we're not getting a string as we did before, but we get an int. So get int extra is going to be constants dot total questions. And now val correct answers will be intent get int extra, because the correct answers is also an amount, so it's also an integer. Constants correct answers. Now the thing is, you can see that it's complaining here when you get an int extra that something is missing. And that is because something could go wrong in that process. So if something is missing, then I want to use the default value of 0. So I'm going to do that in both cases. I'm just going to say the default value will be 0. So if for whatever reason the int wasn't sent over, then use 0 as the alternative value or as the default value. All right, and at this point we can go ahead and say tv underscore score dot text is going to be your score is, and then the correct answer, and maybe I should call it correct answers out of, and then total questions. All right. So then if we look at our activity result, you can see here we have this finish button. So this button currently doesn't do anything, and it's inside of our result activity, of course. So what would make sense to give this button? Well, I'd say it would make sense to give this button the functionality of when it's clicked that it sends us over to the main activity. So you can of course create an intent and then in the next step use the start activity, but you can also pass in a new intent directly here. So you can directly say this and then send me over to the main activity : class.java. All right, now intent needs to be imported here as well. So let's do that real quick. And that should be it. So now we have everything prepared and we can test our application. All right, so I'm going to use my name here, Dennis. Now I'm going to go through all of the questions here. And now let's submit the last 2 answers. And we can see we get to the results screen. Your score is 10 out of 10. It says Dennis here, as we have entered in the first activity, in the main activity. And now let's finish and move over to the main activity. All right, now at this point, of course, we can still go back because we didn't finish this activity, but that's something that you can, of course, do here as well. So you can just say, okay, finish. Now this will close the activity. Another thing, if we look at this activity, we see that at the top we have the status bar. So of course, we can get rid of the status bar as well by just using the same line that we had in the main activity where we said, okay, deactivate this, please. So let's just do that in here as well, and then it will be fine. So testing it again, we will see that those 2 features now have been implemented. So I'm gonna say test here this time, so it will be a different name. I'm gonna make some mistakes this time. I'm gonna go real quick through this. I wanna make plenty of mistakes, doesn't matter. And then let's finish, and we can see your score is 3 out of 10. Now let's press finish. Close the activity, because when we go back now, you can see we go back to the quiz activity. Now, of course, you could go ahead and say, all right, I don't want to have the quiz activity as well. So maybe it makes sense to go to a quiz questions activity. And once we move over, so once we send this intent here when submitting, we also finish the current activity. All right. So that was it. I hope you enjoyed this chapter. So we created this little app. Now, of course, you can go ahead and change your constants, which means change your questions. You can change the amount of questions you have. You can change the type of questions you have. You can use different images and so forth. So you pretty much have created a whole quiz app that you can now adjust to your liking and then send to your friends, publish it to the store, whatever you like. All right. So I hope you enjoyed this, and thanks a lot for being part of this. And see you in the next one.
Alrighty, so now we're done with the quiz app. I hope you enjoyed this chapter. I hope you went along and built your own quiz out of it. And if you didn't, then please do so. Just search a bunch of images, search a bunch of questions, or write your own questions and potential answers, and then make your own quiz out of it. I think that would be super awesome to see your application on the store. So if you build something, just get into the habit of putting it on the store once you think it's good enough, all right? And then you can share it with us. So just go ahead and share it with us and share the link so that we can check out your application and give you some feedback. And thanks a lot for still being with me and also building this pretty cool application, right? So I hope you enjoyed it. We used the manifest, so we looked into the Android manifest file, which is an important file when it comes to developing an Android. Then we saw how to use models, how to create our own classes that we can then use objects of, which is super important when it comes to handling data. Then we looked at using multiple screens, so activities, so also how to move from one activity to another, how to move and also get information back, and then use it in the activity that's sent to the other activity in the first place. And then also you saw how to use user input and work with it. All right. So let's get to the next chapter, in which we are going to draw. So quite a drawing application with a bunch of new features. So see you in the next one.